Hello and welcome to this video course on advanced Java programming. In this course, we're going to cover topics that are beyond what is normally taught in a beginning Java course, hence the name Advanced Java. So you should have some previous Java programming experience, either through self-study, through a course somewhere, or hopefully through our Infinite Skills beginning Java programming course. In this course, the topics we're going to cover are fairly broad. And let me speak a little bit about the broad nature of this course. What I've tried to do is cover several advanced topics, but not cover any one particular topic in too much depth. Because to be honest, each one of these topics is a course in and of itself. So what I hope to do through my courses is give you the confidence to explore these topics in more detail after I've given you an introduction to them. So let's look over the topics we're going to be talking about in this course. First of all, we're going to be talking about generic programming. Generic programming allows us to build classes and methods and data structures without specifying a particular data type for the underlying data, at least not at compile time. Then when we run the program, we can specify, or when we write the program to utilize the class or the data structure, we specify a particular type. That's what generic programming is in a nutshell. After that, we're going to talk about sequential collections or data structures. Sequential meaning linear. After that, we're going to be talking about associative collections or associative data structures such as maps. Next, we're going to talk about classic data structures, and by that I mean stacks and queues and linked lists. The things you might have studied in a data structures course in college, if you took one. Next up will be sorting and searching algorithms. We'll look at 3 or 4 of each type, from relatively basic to somewhat complex. Then we'll talk about exception handling and how to deal with the errors that come up in your programs. We follow exception handling with database programming with JDBC, and we'll also be using the MySQL database. After that, we'll talk about network programming, primarily TCP/IP programming. After that, we talk about GUI development using the Swing toolkit. Follow that with a brief overview of multi-thread programming. I emphasize brief because that's a very complex topic, certainly a course itself, but we will cover the basics of multi-threaded programming. Next, we'll talk about Java Applets. Those are little programs written in Java that run on the web browser. We follow that with a section on Java web applications, or also called servlets. Those are programs written in Java that run on the server side of the web. Next, we talk about JavaBean programming, and that's creating component-based software in Java. Then we talk about a new set of classes for performing input and output called NIO. So that's Advanced Java Input Output. Then we talk about strings and the StringBuilder class. Strings can be somewhat inefficient when you're doing large operations on strings, and so Java has a class called the StringBuilder class that makes those operations more efficient. We follow that with a section on regular expressions, followed by some very basic graphics in Java, drawing simple lines and shapes. And then we wrap up the course with a little overview of using the Eclipse IDE. I will mention that, as in my first course, I stick to Notepad and basic text editors in the course, primarily because I don't want to try to influence you with any particular IDE, because not everyone will use the same one. And learning IDEs is also separate courses, so we could have a whole course on Eclipse, or a whole course on NetBeans, or one of the other Java IDEs. In a couple of places in the course, I reference a couple of textbooks that you might want to look at for further study. Those are Java, the Complete Reference, the 8th edition by Herbert Schultz, and Java Programming Advanced Topics, written by Joe Wigglesworth and Paula McMillan, and there is no relationship between myself and Paula McMillan, so this is not some sort of kickback opportunity. This is just a book I used in a college course I took on advanced Java programming, and I found it very helpful. It's quite readable with good examples. So that's an overview of this course. and I'm excited to be bringing this material to you, and I hope you're excited about learning it. And with no further ado, let's jump right in and start learning about generic programming. In this chapter, we're going to be discussing the concept of generic programming. Generic programming allows us to define classes and methods and defer specifying a data type until defining runtime code that uses the class or method in question. The reason we want to do that is to make our classes and methods more flexible so that they can handle multiple data types. A simple example will help explain this concept, and we'll be defining that example in the next 2 lessons. So let's get started. We're going to create a list class, and this list class will allow us to create a list of items. It could be a list of items we need from the grocery store. It could be a list of phone numbers. It could be a list of grades. It could be a list of the amounts we spent at the grocery store. It could be lists of anything. And because of that, we don't want to tie ourselves down to a specific data type when we create the data structure that stores the items in the list. So the way we get around that is by using generic programming. The way generic programming works is in the definition of a class, we specify a type placeholder. And we do that by writing less than sign and then a letter or variable. It doesn't have to be just a letter, followed by a greater than sign. This letter, the letter T in this example, is a placeholder where the data type will be provided later on when we write code that uses the list class. But when we're just defining the list, we defer specifying a data type by using the type placeholder. So to continue on with the definition, we need to create an array field to store the elements of the list. And here's where we use type placeholder. So our field is called data store, and we know it's going to be an array because we put open and close brackets right here. But we're not specifying the data type by putting a placeholder value in instead. We also need a field to store the size of the array, and we need a field to store the current position inside the array as we add or remove elements from the array and from the list. So those will be our fields. Now let's define at least just the constructor. And in fact, that's how we'll finish this lesson, by defining the constructor. And then we'll go back in the next lesson and flesh out the definition a little bit more and test the class. The constructor has to do a couple of things. First of all, we have to decide the size of the list, so we're going to pass that in when we instantiate a new list object. We'll set the current position to 0, and then finally, and most importantly, we have to initialize data store, our array. And that involves a little trick. So what we have to do is we have to create a new object array and then cast it to the data type that's going to be provided when we instantiate a list in user code. But for now, we use T as a placeholder for the type that's going to be defined later. So I know that looks a little odd, but it's the only way we can correctly initialize the data store field. And that's all our constructor has to do, so we'll finish that up, and then we'll finish up our class definition for now. So let's compile it very quickly to make sure that it works. And understand that there's going to be a couple of notes that we're using an unchecked code, and we can't really change anything about that. So let's give it a try here. So there's our note that we're using an unchecked or unsafe operation. Understand that in real life, we would not create a class of this type because there are much better list type classes defined in the Java libraries. This is only to demonstrate how generic programming works. So with that, we're going to wrap up this first lesson, and we'll move to the next lesson where we're going to continue the definition of our list class. In this lesson, we're going to continue to add to our generic list class and then demonstrate how it can work with multiple data types. So let's open up the class definition again. That's in list.java. And what we want to do is add a method so that we can add data to the list. We're going to call that method add. and then we're going to write a toString method to display the elements of the list. We're going to postpone any further development of the class to the exercises for this chapter. So our add method is a void method, and here again is where we need to use our placeholder for our data type, because we don't know, as we're defining this class, what data type is going to be used, so we use the placeholder T instead. The code, we simply add the element to the current position in the list or in the array data store, and then we increment position by 1 to be prepared for the next add. And that's all we have to do. Again, the key is the fact that we're using our placeholder T for the data type, since we do not know right now, as we're defining the class, what the data type is going to be. And finally, we're going to override the toString method. And what we'll do is we'll build up a list of elements as a string by looping through the array. And then adding each element as we come across it to the string. And we'll put an extra space in between each element also. Then when we're finished, we'll return elements. And that's all we have to do. So let's exit and save. And let's compile the class. And it works. Now let's write a program to test the class. So we'll call this program list driver, because it's a driver for the list class. We have public class list driver. The first thing we're going to do is create a list of strings. We're going to create a grocery list, so we'll call it glist, and we'll call the constructor and say 10 items to the list. So the 10 is passing in the number of items we want in the list, although we're not going to add that many. And let's just put a couple in there. We'll do milk and eggs. That's good enough. Then let's display the list, like so. Let's close off the program. Let's compile it and run it. It compiles just fine. And then we run it, and there's our grocery list. So let's go back into the program, and let's add a new list to demonstrate the generic capability of our class. And let's create a list of numbers. This time we'll just make it 5, although we're not going to add 5. We'll do 3. And we'll just do 3 simple numbers. And then we'll display our list. Just like so. Save the file. Let's clear the screen. Recompile it. And then run it. And there is our grocery list, originally milk and eggs, and our list of numbers 1, 2, 3. So looking at the code again for the list class. Bring it back up. We are able to make our class generic by putting a data type placeholder in the heading of the class definition. And then every time we need to refer to a data type, we simply use T. So in the declaration of the data store array, we use T. In the actual initialization of the array, then when we're adding elements of that type, we also use T there as a placeholder for the data type. Then when we want to actually use the class, we substitute T with an actual data type. So here we have string. Right here we also have string. Then for our numbers, we have integer, and we have integer. Now, notice that when we're working with generic classes, or with generic methods also, which we'll see later in the chapter, we have to use the object data type and not the primitive data type. So rather than lowercase int, we have to use uppercase integer. And with string, it's the same for both, so it doesn't really matter. So that's how we create and use generic classes. And now we're ready to move on to the next lesson where we're going to talk about creating generic interfaces that can then be used to create generic classes. In this lesson, we're going to learn how to create a generic interface that can then be implemented by other classes. So let's get started. We're going to keep working with the concept of lists, and this time we're going to create a list interface so that we can create different types of lists. So we're going to call this program ilist.java. So we begin our interface by writing public interface ilist, followed by our placeholder for our type. We're going to make this a minimal interface. So we'll start out with a void add method, which takes a t element, since we don't know the type yet. And then we're going to have a tGet method that takes n as an argument and will return the nth element from our list. So like I said, this was going to be a minimal interface, so we're going to stop right there. So you see how the type placeholder is used very similarly to how we do it with a regular class. So let's exit and save. And let's compile our interface to make sure everything's all right. Now let's create a class that implements the interface. We're going to call this class numberlist.java. So we write public class numberlist t implements ilist t. The first thing we do is declare our fields. So we have data store. We have size, and we have position. Our constructor, initialize position to 0, and then initialize our array. And again, what we're doing here is we're creating a new object array and then casting it to the type that we want it to be when we declare the type at runtime. So our next step then is to implement the two methods that are part of the interface. So we'll start with add. Add is a void method that takes a t element, and we store the element at the current position of the array, and then we increment the position by 1 in order to move to the next free array position. And that's all that method has to do. Then we're going to implement the get method. Well, let's do that. Start at public tGet, and it takes a index position and returns the data at that position. So again, notice how we use the type placeholder in the appropriate place. Here we use it as the data type for the argument to add, and here we use it as the return type for the get method. Let's save our file, and let's compile it. And except for our warning about unchecked operations, everything, it looks just fine. Now, just for fun, let's use this definition to create yet another type of list. So I'm going to do a Control-C to copy, and we're going to close. And then let's create a string list class. All we have to do is change the name, and then save it. And we'll come back and compile. Copying and pasting always leads to problems. Should have done a find and replace. There we go. So we needed to change that number list to string list. Now let's try that again. And that time it works fine. I'm going to save a test of these classes that implement the ilist interface to the exercises. But I feel very confident that everything's going to work fine since our classes both compile without any problems. So let's take a look at the interface one more time. The interface is really nothing fancy. Let's do it like this. But again, it gives us the extra control that we want, provides us with a means of building on a hierarchy of objects, which is always a nice goal when you're doing object-oriented programming. And this shows that we can do it generically as well by creating a generic interface. So with that, we're going to leave class definitions for a while, and now we're going to look in the next couple of lessons at how to create generic methods. In this lesson and the next lesson, we're going to learn how to create generic methods. And we're going to create these inside static classes. So rather than have a generic class that includes in it methods that use the type parameter that's part of the class definition, we're going to create generic methods that don't rely on a type parameter from the class definition. Instead, the type parameter is provided just in the definition of the method itself. If that doesn't make sense, you'll understand what I'm talking about in just a minute. So in this first lesson, we're going to create a method with a single type parameter. And in the next lesson, we'll create a method with two type parameters. So take a look at the program in front of you. And I've created a very simple array and put some names into the array. So what I want to do is write a method that will display the elements of this array, but that I can then turn around and use again with an array of a different type, such as an array of integers or array of booleans. So let's see how to do that. So we come up outside of public static void main, and we begin our definition of the method. And because we're not working inside a class, we have to define this method as static. Then we provide the type parameter, followed by the return type of the method, which is going to be void, followed by the name of the method, which is display, followed by the type parameter to indicate that it's an array of generic type, and a name for the array. At this point, the rest of the code is a simple for loop that loops through the elements of the array and displays them unless the array element is null. So we're going to check to make sure that each array element is not null, and if it's not null, then we're going to write it out to the system prompt along with the blank space. We close off our loop and close off the method definition. And let's come down to the bottom of our code, add a call to display with names. Let's save our program. Back to our system prompt, clear the screen, compile, and then run. And there are our names. So now, to test to see if the method is truly generic, let's create a new array. And this time we'll create an array of 10 integers, the integers 1 through 10. Notice that I have to use the object type, capital I integer, not lowercase int. Remember that generic classes and methods only work with object data types. Or the best way to say that would be that the data types are objects as opposed to the primitive built-in data types. So once we've created the array, then we should have no problem displaying it. Let's add a blank line between the two, like so. So there we go. So let's save the file. Come back to our system prompt, compile it again, and then run it. And there we go. So to create a generic method, we simply have to provide a type parameter before the return type of the method definition and after the access modifier. So public, private, in this case, static, since it's a static method. So with that, we're finished with this lesson. Now let's move on to the next lesson where I'm going to demonstrate how to create a generic method that has two type parameters. In this lesson, we're going to see how to create a generic class that has two type parameters. What we're going to do is we're going to create a class called the pair class, which allows us to store pairs of data values and treat them as one. In other languages such as C++, the pair class becomes the basis for associative structures such as a map that have key-value relationships. In other words, one piece of data is a key and another piece of data is the value that is based on that key. So let's go ahead and see how to create a pair class using two type parameters. So we'll start off, we'll create a file pair.java. So we'll start out public class pair, then we'll provide our two type parameters, and what we'll do is we'll name the first one T1 and the second one T2. Sometimes you'll see two different letters like T and U, doesn't really matter. We'll use T1 and T2. So our first item, which we will call first item, the first value stored in the pair, will be of T1 type, and the second item, which we're going to call second item, will be of T2 type. Then we'll create a constructor This is all very straightforward programming. Of course, notice we use T1 and T2 as the data types for the two parameters. And then the last two methods we're going to create will be methods for returning the first item and the second item. I don't want to spend too much time dragging out the definition of the class. The point is to just demonstrate how two type parameters can be used. This is all we need for the class definition, so let's go ahead and save our file. Bring the command prompt window back up and let's compile it. Make sure it works okay. And it does. So now let's use the class. So we'll create a program called pairprog.java. Let's get our screen in place. There we go. So once we get main defined, here we go. We'll create a simple pair using string and integer to demonstrate how the class works. So for example, we might say grade 1. And then what we're going to do is I'm going to drop down to the next line to pass in some arguments. Like so. Let's do one more. Just like so. Then let's display the name and grade for each one of these. So we'll do a system out print line grade 1 first, and then system out print line grade 1 second, and then do the same thing for grade 2. And that's all we need to do to demonstrate how the class works. So let's save the file, come back to our command prompt, compile, and then run it. And there are our two pairs. So to create a class with multiple type parameters, we simply list them out using a comma to separate them and provide separate names. And then other than that, we treat them just like we were working with a single type parameter. So that wraps up the lessons for this chapter on generics, and we're ready to move on to the exercises for the chapter. For this exercise of the chapter, we're going to build a class called the Node class. And we're actually going to use this later on in the course when we work with data structures. A lot of data structures require an object called a node, which is used to hold data and references to other nodes in, for example, a linked list. But here I just want to use the idea of a node to demonstrate how to work with a generic class. So let's go ahead and build the node class. First thing I want to do is make sure I don't already have it built. So the node class will just have one type parameter, and that will be for the type of data the node is going to store. So our field is data, and it's of type T. We use the type parameter there because we don't know in advance what the type is going to be. Our second field is a field called next, and it holds a node that the current node will be pointing to. Our constructor takes data of T type. Again, we'll decide that at runtime, and assigns it to the data field. And then our next field will be automatically assigned the value null. Last thing we want to do is provide a way of getting the piece of data out of the node object. So we'll use a getData method here. And it just returns the data. So it's a very simple class, as you can see. So let's exit and save. Then let's compile it. Make sure everything works correctly, and it does. So next thing we need to do is create a program to use our node class. And so we're going to create a program called linked list that will use nodes to create a very primitive linked list. We'll do a better job later in the course, as I mentioned earlier, of creating linked lists. But for now, I just want to demonstrate how to use nodes. Let's get to the beginning of the program here. The first thing I want to do is create a node of string type, and we'll store a name in the node. Then we'll create another one. And actually, let's just go ahead and create a third. That's node 3. So each of these nodes' next field automatically points to null. So what we want to do is we want to link them up. So we're going to say node1.next equals node2. Node2.next equals node3. And then we want node3.next to point to null, although it already does. And actually, we don't want it to point to null. So what we're going to do is, let's change that. Let's create another node. We're going to call it a footer. Lots of different names we could use for that. And it will be what node 3 points to, so that it will be the last node in the linked list. We could also create a header node, but we won't do that for this example. So the next thing I want to do is create a dummy node. In fact, I'm going to call it that. And we're going to assign it the value node1. And then we're going to say while dummy.next is not equal to null, write out the data for that node. Then to move through the set of nodes, we just say dummy is equal to dummy.next. And so what that's going to do is that's going to move us from node 1 to node 2 to node 3. Then it's going to move us to the footer node, which will trigger the end of our while loop. Let's close out the main and close out the class. So let's save the file. Go back to our command prompt window and let's compile. And it compiles fine, so then let's run it. And there's our 3 names. So what we want to look at is not the linked list code, but just to refresh our memory on how to write a generic class, let's look at the node class again. And so we just use the type parameter. Where we need to use it And primarily with a node, it's going to be used to represent data. Then we can create nodes of any type we want. Here I created strings, but there was no reason I couldn't create a linked list of integer nodes or a linked list of Boolean nodes or a linked list of our own data type, like our own defined class. Or I could have even mixed them, although it doesn't really make sense to mix names and numbers all that much. But I primarily wanted to show you how a generic class might be used in practice. And that sums up how to use generic classes, and that brings us to the end of this chapter. In this chapter, we're going to study data structures called sequential collections. And a sequential collection is a data structure that stores collections of objects in a sequential or linear manner. The sequential collections we're going to look at are all based on a series of interfaces. What I'd like to do in this lesson is look at just a couple or three of the interfaces we'll be working with. The first of these is the collection interface, and it's actually the foundational interface for the sequential collections. And what I want to do is just very briefly go over the different methods that are part of the collection interface, and we're not going to look at all of them. Here's a list in front of you, and you'll see that some of the things we can do with the collection is add items, clear the items from the collection, check to see if some other collection is equal to the current collection, check to see if the collection is empty, remove an object from the collection, remove all the objects from the collection, return the size of the collection, the number of elements that are in the collection, and take the collection and turn it into an array. Again, these are just the suggested methods for a collection. Another interface that we'll be basing our work on is the list interface. If we scroll down to look at the methods, you notice that they're also very similar. Add all, clear. We have a get that returns the element stored at a specific index position. Index of, we can return the index of occurrence of a specified element. Iterator allows us to iterate over the elements in a sequence. And then some others that we're familiar with, remove all, size, and toArray. Another interface that we're going to be working with is the set interface. Let's take a look at its methods. It's not quite as large, the number of methods that are part of the set interface. But as you can see by looking at the list, again, they're all very similar, including add all, clear, is empty, size, iterator, toArray. So it's obvious that these interfaces all have a similar set of methods that we can use. And again, these are all really based on the collection interface, which list and set are based on. But we're not quite finished looking at interfaces, so what I want to do is go on to the next lesson, where we're going to look at a couple of interfaces that are a bit different than what we've seen here. And after that, we'll be ready to start actually looking at the classes that we can build sequential collections from. In this lesson, we're going to look at two more interfaces that we're going to be examining in more detail in this chapter, and that's the queue interface and the deck interface. A queue is a particular type of sequential container that allows you only to enter items in the back of the structure and remove them from the front. I've brought up the wiki page for queue so you can see a diagram of how a queue works. So you'll notice that the part here labeled in queue represents entering an item. So this item represented by the blue triangle enters or in queues, if you will, from the back. And then we dequeue an item or remove it only when it's at the front, when it's the front item in the collection, or in this case in the queue. The queue interface itself is quite small. I have another page for that. And you'll notice there's only a few methods. Element, which retrieves but does not remove the head of the queue. Offer, which will insert an element at the back of the queue. Peek, which lets you look at but does not remove the head of the queue also. Poll, which retrieves and removes the head element of the queue, and then finally remove, which does the same thing, retrieves and removes the head of this queue. So as you can see, it's a very small interface. Another type of queue is called a deck, and a deck stands for a double-ended queue. If we go back to our queue diagram, what that means is that double-ended allows you to enter new elements from the back or the front, and it also allows you to remove elements from the back or the front, which makes it more flexible, but also takes away a little bit from the abstraction of a queue being like a line, like the line at the grocery store or at a bank, for example, where you enter the line at the end and then you leave the line when you're the one being served. The interface for the deck is a little bit larger since we have to allow for both entry and removal from the front and back of the structure. So you see we have several different methods, many of them similar: add last, offer last, remove first, poll first, get first, peek first. And then we also have other deck methods that are similar to stack methods. We'll be talking about stack methods in a later lesson. Add first, remove first, and peek first. Normally, add first would not be part of a queue, but it is part of a deck. So those are the two other interfaces I wanted to introduce before we start working with specific types of sequential containers. But now we're ready to go ahead and move on to the next lesson, where we're going to look at the first of the sequential containers I'm going to cover, and that's the array list. The first collection class we're going to talk about in this chapter is the array list. Array lists are very similar to arrays in that we can store elements sequentially and access those elements by indexed position. But a main difference between an array and array list is an array list is dynamic in that its size can grow and shrink, whereas the size of an array is static based on the size you declare when you create the array. So let's take a look at how to work with array lists in Java. We're going to call our program alist.java. Notice the capital L in list. First thing we need to do is import the Arraylist class. So we import java.util.arraylist. Our class is called alist. Okay. So the first thing we're going to do is declare our array list. In this case, we're going to create an array list of 5 numbers, although the size, again, doesn't really matter. So we write array list, followed by the data type of the elements of the array list. Notice we have to use the class name for integer and not the primitive or built-in name. So it's capital I integer and not lowercase I int. We're going to call this array list grades, and then we call the constructor for the Arraylist class, like so. Once we've declared our array list, we're ready to add elements to it. And to do that, we use the add method. So all the add method takes is one argument, and that's the data you want to add to the array list. So bear with me while I add 5 grades. Now that we've added the elements to the array list, we're ready to access them. We access them via the method get. Get will take an indexed argument and will return the element at that indexed position. So let's write a for loop. Well, first of all, let's create a variable total to store the total of the grades. Then let's write a for loop that starts at 0 and then runs 1 less than the size of the array list, which we can determine using a method called size. And that will return the number of elements in the array list. And we'll increment I by 1 each time. So the total is equal to the total plus the grade that we retrieve with I as an argument. So now we can compute the average by taking the total and dividing it again by the size of the array. Then let's print both the size of the array, so we can see that, and our average. All right, then let's close everything out. Save our file. And let's run it. There we go. So we see we have the size of your grades is 5 because there's 5 elements in the array list, and the average is 80. One of the advantages to using a collection class like the array list over the array is that we can use other means of accessing the elements rather than just a good old-fashioned for loop. For example, the for each loop will allow us to do the same thing a for loop does without having to worry about where to start or where to stop. The for each loop will determine that for us. Here's how the for each loop works. Starts with a for, then we have an open paren, followed by the declaration of a variable. That variable is followed by a colon, followed by the name of the array list. And so what we're saying here is we're saying for each grade in the array list grades, do something with that grade. So what we want to do with that grade is add it to the total, just like that. So the for each loop uses a built-in iterator to access each element of the array list in turn, from 100 to 90 to 80 to 70 to 60, and it knows exactly when to stop. So let's save the file, compile it again, and then run it. And you see that we get the same result. Finally, before we leave, I want to demonstrate how sizing of array lists works. Let's remove one element from the array list. So we do that using a method called remove, which takes an index position and will remove the element at that index position. So now we can look at the new size of the array. So let's take a look. Save it. Compile and run. Now we see that the size is 4. Now let's add 2 more elements in. Let's add 60 back. And then let's add 50. And let's print out the size again. We'll change the heading on that a little bit to newer size. There we go. Save the file, compile, and then run. And you see that now the size is 6. So there are 2 main advantages to using array lists over arrays. One, we can take advantage of the for each loop to make it easier and safer to access all of the elements of our collection, in this case an array list. And we can use the fact that array lists are dynamic to remove elements that we don't need and add new elements in without worrying about whether or not we've gone beyond the size of the initially declared array, because array lists grow and shrink as you need them to. And with that, we've wrapped up this lesson on array lists. In this lesson, we're going to see how to use the Hashset class to store a collection of data. So let's go ahead and get started. We're going to call this program names.java because we're going to store a set of names in the hash set. So the first thing we're going to do is we need to import the Hashset class. So we'll do that first. Then we'll start our program off. So the first thing we have to do is to declare our object. So we're going to write Hashset, followed by our data type, which is going to be string. And we have to use the object or class version of the data type. But of course, for string, it doesn't really matter. Then a name for our Hashset, we're going to call it names, and then call the constructor. And now we have a new object. The next step then is to just add some names to the collection. So we'll put a few names in here. We'll just use first names. Now at this point, we might want to see how many names we have in our collection. Of course, we can tell because we just added 3. But if we're doing this programmatically, we can use the size method to show us the number of names. So let's call that method. And that's just size with open and close parentheses. And let's go ahead and compile and run the program at this point and see what we have. So we're going to save it. And we go back to our command prompt and then compile and then run. So the number of names is 3, so that's good. We might want to see what those names are. So to do that, we can use a for each loop. So we'll say for string name colon names, or as I like to say, for string name in names. And we'll print each name 1 to a line. So let's save that and then compile and run it. Clear the screen. Compile again and then run. And there's our names. If we need to remove a name, we can do that easy enough with remove. We can add another name, just like so. Then we can check to see if our name is actually removed. Well, one thing we could do is print the list out again. We'll get back to that. There's another method called contains, which we can use to see if a given piece of data is actually in the hash set. So let's use name again. Let's make sure David is actually removed. And we'll say if names contains, and then we'll use the variable name here, and we'll write something out. And we'll have an else. And write out another little message. Let's compile that and run it. And David is not in the collection anymore because, as we see from our code, we removed it right there. So we can print out the names that are in there. Let's do that again. So we'll save and compile and run again. I'll leave it up this time. We'll leave this error in, again, so you can see how to fix it. Very simple mistake. We already declared name more globally. Again, remember that in a for each loop, that declaration is local to the loop. But here I created a more global declaration for name. So now I've either got to comment this out or create a new variable. Well, let's create a new variable in right here. Good enough for this example. Save the file. Try it again. And there are new names, Cynthia, Brian, and Raymond. So finally, before we leave this lesson, the one other thing we can do is we can clear a collection out to start over again, clear a hash set out using the clear method. Now we'll copy and paste our size call, our call to the size method, to verify that we indeed cleared out all the names. Let's take a look at that. Let's clear the screen, compile, and then run. So after this list of names, we call clear, and then we have the number of names is at 0. So those are the main methods that are part of the Hashset class, and I've demonstrated in a fairly fundamental manner how to use them. We'll come back to this in the exercises where we'll use Hashset to do something a little more interesting. But for now, we're ready to move on to the next lesson where we're going to talk about the Treeset class. In this lesson, we're going to be looking at the Treeset class. The Treeset class differs from the Hashset class in that the Treeset class, as you add elements to the collection, will store them in their natural sorted order. For example, alphabetical if it's strings, A, B, C, D, or in ascending numerical order, 1, 2, 3, if you're dealing with numbers. We'll work with strings in this lesson and then deal with numbers in the exercises. So let's start a new program. We're going to call this one alpha.java. And the first thing we need to do is import the Treeset class. So we do that first. Then we'll set up our program. And again, we're going to be working with names, just because that's an easy example to work with. So we'll create an object, a Treeset object. We'll call it names again. And call the constructor. Now we'll begin adding some names, and we're going to add them in a fairly random order. And I'll add several names so that we can see how the tree set is alphabetized as we add. But we won't get too many so that we can keep track. A couple more, and that'll be good enough. And let's stop right there. First thing we'll do is we'll look at the size of the collection by using the size method. Just like so. Let's go ahead and compile at this point and run to make sure we're on track and don't have any mistakes. And then let's run it. And so we have 6 names, which is correct. 1, 2, 3, 4, 5, 6. Now let's see how the names are stored. So we'll write a for each loop, just like we did in the last lesson. And we'll print them one to a line. Let's compile and run that. And notice that the names are in alphabetical order, even though we entered them in a fairly random way. We also have ability to clear out the tree set and start over, and remove items at will, as well as check to see if items are in the collection using contains. But what I want to focus on are a couple of other things that we can do that have to do with the tree set being ordered. So let's go back to our code. We're going to look at 4 different methods. The first one is called lower, and it's going to retrieve the first element that is lower in order than the one given. So let's see how that works. So we'll pick Jennifer. I just barely got that on the screen. So let's save the file. Let's go back and clear the screen and then compile it again. And then run it. I have after, I should have had before. I'll fix it for the next printout. So lower gave us the name right before Jennifer. Now since we're picking on Jennifer, let's pick the name right after Jennifer, which is what it looked like I was trying to do the first time. And of course, we could use a variable here instead of a literal, trying to keep things simple in my program. Compile again, and then run. And so then we see that the name right after Jennifer is Mike. So lower gives you the name right before a given name, and after gives you an element right after a given element. We can also see the first and last elements in a tree set by using methods called first and last. So let's look at those next. So first we'll return the first element, and last we'll return the last element. So let's save. Go back to our command prompt. Let's clear the screen, and then we'll compile again, and then run it. So our first element is Brian, and the last element is Terrell. So the tree set gives us a way to create a collection and add elements into the collection and keep them in a sorted order. And with that, we're ready to leave this Treeset class for now. We'll come back to it in the exercises. And we're going to look at a third class for storing sequential collections called the Priorityqueue Class. In this lesson, we're going to look at how to use the Priorityqueue class. We discussed queues in the beginning of the chapter. I showed you a diagram from Wikipedia that demonstrated how a queue takes data in at the back of the structure and then removes data from the front of the structure. It's an abstraction for a waiting line like you might see at a bank or a grocery store, for example. Priority queue is a little bit different than just a regular queue because it stores the data in its natural order. So in other words, as data is entered into the queue, it's sorted into whatever natural order for that data type is. So for example, string data will be stored alphabetically, and numeric data will be stored in ascending order 1, 2, 3, 4, 5, 6, etc. So it's a little bit different than just a regular queue, but it can work very similarly to a queue. Let's take a look at the fundamentals of how our priority queue works, and then in the exercises we'll look at a more extended example. So we're going to call this program line.java. We have to import the Priorityqueue class, so we'll do that first. And we're ready to start our program. So the first thing we're going to do is, of course, instantiate an object. So we'll call it line. And before that, we have to have the data type. We'll make it string. Set the angle bracket right there. And then open and close parentheses. Now we're going to just work with names as we usually do. So let's add a few names into our priority queue. And let's do one more. Now, just to see how the priority queue looks, we'll write a for each loop and print the names. And then let's compile and run it to make sure everything's working correctly so far. We'll save it, go back to our command prompt, let's clear the screen, compile, and then run. And there are our names. To remove an item from a priority queue that is at the head, we do that by using a method called poll. And with poll, we don't have to have an argument, we just remove the item. So let's just do that. So we're going to call poll. Then let's use our loop again so that we can see that a name was indeed removed. I should also mention that we used the standard add method to add the names. I didn't mention that before because we've been doing it so much, I just kind of took it for granted that all of these classes that we've been looking at this chapter add data primarily using the add method. All right, so we're going to use poll to remove the head element from the priority queue, and then we'll use the for loop to take a look at the rest of the line after that. So let's clear the screen, compile, and then run. And it's hard to tell exactly where our line left, but you can see that Brian is no longer at the head. So the line now starts at Clayton and runs through David because Brian was taken out. We can also remove items using the remove method. Let's take a look at that. Here we can remove a particular item. So if we want to remove Raymond, for example, we can remove Raymond like so. And let's add a header into this. Let's call it the line. And we'll just copy and paste that into place. Okay, so again, to remind you what we just did, first we used poll to remove the head element. Now we're going to use remove to remove a specific object or a specific element. Let's clear the screen, compile, and then run. Poll got rid of Brian. Here's the line there. Then we got rid of Raymond using remove. So those are the two methods to remove. If you're trying to simulate a line or a queue, then you want to use poll. If you're just trying to remove an item, then you can use remove. Last thing I want to show you is how to look at the head of the queue, the priority queue, and that's using a method called peek. Peek lets us see what's at the beginning of the line at any particular time. We'll save it, and then compile, and then run. And so peek shows us that after all of our polls and removes, Clayton is now at the head of this particular line. So those are the primary methods that we use in working with priority queues. So that wraps up this lesson, and we'll look at a better simulation of using a priority queue in the exercises, which will begin next. But we're going to start with an exercise using the Treeset class. In this first exercise of the chapter, we're going to use the Treeset class to create a list of unique words in a set of strings, essentially a text. I grabbed a paragraph out of Alice in Wonderland and put it into a Java program, and then we're going to create a set or a list of unique words in that text. And to do that, we're going to first take the text, put it into an array. Then once it's in an array, which we can do with one method call, the split method, then we can take the array contents, loop through that, and put them into a tree set, and then the tree set will give us the list of unique words. So let's get started. I've already started the program, just to save you the tedium of watching me put the text into a string. Let me adjust it on the screen here. There we go. So here's the paragraph that I chose. I took all the punctuation out to make it easier to parse the text, although we could do it with the punctuation. I just like to take it out. And so that each word is separated just by a space. And so what I did was I created one long string by using concatenation. That was the easiest way to do it. I could have put the text into a file and read it in from there, but I wanted you to be able to see the text at the same time you were looking at the program, so I did it this way instead. So the first thing we have to do is we have to take the text and put it into an array. We'll do that using the split method on the string variable. So split works by taking an argument, and that argument will be a delimiter, and then it's going to split each piece of data based on a space and put it into this array. So it's going to take either, put it into words, then it skips the space and gets the next word, the, puts it into the array, and so on and so forth. We can view the words by writing a for each loop. And we'll print each word. We don't need a quote mark there, like so. So let's go ahead and compile and run this part of the program. We'll save it, go back to our command line, compile, and then run. And there are words. We can also write out the number of words. Total number of words. And call the length property. Let's compile and run it again. Let's clear the screen. Compile and run. And the total number of words is 698. And there's the list of all the words. Now the next thing we want to do is go back to the program. Now we want to take these words and create a tree set of only the unique words. So we're going to do that by creating a tree set. We'll call it word list. The first thing we have to do is instantiate an object. So we'll do that first. Then we'll write another for each loop. We'll just use the same basic structure. And this time we'll say word list add W for each word. Now let's write out the total number of words. I'm not going to write the list out again. We'll say total number of unique words. And let's drop this down to the next line. Like so. Make sure I didn't get rid of my closing curly brace. There it is. All right, so let's save. Back to our command prompt. Clear the screen. Compile it. And then run it. And the number of unique words is 88. If we want to see that list, let's add it to the end of our program. We'll just borrow this for each loop right here. Change that to word list. Save it. Clear the screen. Compile and run. And starting right here is our list of unique words. So using the tree set to filter out duplicate words is a very efficient use of the tree set. And one of the reasons why we have collections like that is a lot of times we don't want to see every piece of data in a larger data set. We want to see the unique values. And that's what we get by filtering out duplicate words from an array into a tree set. And with that, we're ready to move on to the second exercise where we're going to work with the priority queue to simulate a square dance. For the second exercise of the chapter, we're going to create a simple simulation, or at least the beginnings of a simulation, that involves priority queues and a square dancing scenario. So let's get started. We're going to call this program squaredance.java. First thing we need to do is import a couple of libraries. We need the priority queue library, of course, so that we can work with the priority queue. And we also need the IO library because we're going to do some file reading. What we're going to do is we're going to read a file that contains a set of names and a gender designation. Let me show you what the file looks like. Let me pull my command prompt window up real quick. See if I can get this right the first time. There's the file where we have the sex and the name. And so what we're going to do is we're going to read these names from a file, store them into priority queues based on the sex, and then partner each man and woman up for a square dance. And then if we have anything left over in the queues, then we'll indicate that in the program. And we could use that as a basis for a simulation of how the square dance lines or the queues for dancers wanting to get into the square dance should operate. So let's go back to the program. We'll get started here. First thing we're going to do is set up our two priority queues, even though we're not going to use them for just a bit. We'll call them men and women. We're just going to copy that and paste it in and change the name. Save me a little typing right here. All right. Next, we're going to set up a couple of variables. We need a line variable to store our lines as we read them. We need a variable called file to store the name of our file. We need a variable to store the sex of the dancer. And then finally, we need a buffered reader object for our input file. Now we're ready to begin reading the file and storing the data in the priority queues. So we have to put file IO inside a try catch. The first thing we'll do is set up our input object, like so. Now we're ready to loop through our file. So while the line that we're trying to read is not equal to null, first thing we do after we've read a line is get the sex, and that's using the substring method. Pull out the sex of the dancer. And we check to see if it's a M for male. If it is, and we add the rest of the line, which we get with a substring 2, and add that to the priority queue for men. Otherwise, add it to the priority queue for women. Just like so. Close off the else, and close off the while. Close the file. Close the try. Then we need a catch, which we'll make very generic. We'll just write out a message saying couldn't open the file. And close the catch. So now we've got all of our dancers into the queues. So now we're ready to continue by working through the queues and partnering up the dancers. And we're going to do that while both queues are non-empty. And they both have to be non-empty. So what we're going to do is we're going to pull out a male and female dancer. And then we're going to announce who they are. That's what I'm doing right now, is setting up the output. So we do a poll on men and a poll on women. And that will announce the partners. Now, after that, we check to see if either of the queues is empty. And if the men is, for example, then we'll have to assume that there are going to be some women waiting. So we'll use the size method to say how many women are still in line waiting to dance. Then we'll drop down to the next line for more output. We'll do a print line here. And then we'll announce who the first woman in line will be. And that should get it all. Check my parentheses real quick. And then we'll write another if statement and essentially do the same thing with women. Let's see if I can copy and paste. That's always a challenge to get it right without leaving anything behind that's wrong for that particular situation. All right, so we're going to change this to men. All that's left to do now is close out public static void main and the class, save the file, and let's compile. And we see one error. Again, I like to leave these in as long as it's not too time-consuming to show you where you're going to make your mistakes. And this is a really easy one to make, leaving out this inside parenthesis and this while loop. This is all one statement right here, so I'm going to show it to you so you'll see it. And that's compared to not equal to null. Well, that should fix most of our problems, I would think. Let's clear the screen and try it again. See another simple little error that we made. We left off a quote right here, and we left off a quote right there. So we fix that. Clear the screen. Compile again. There we go. So there are our pairs. And as you can see, we had 2 men left waiting to dance. Raymond Williams is the next man dancer. So this is an example of how to use a priority queue as a means of simulating a real-life queue situation, or a line, if you don't like to use the word queue. You could also run this in a more real-time situation where you have the user actually entering data as more people would come into the line. Like with 2 men waiting, you could have another woman come in, and then that would release the men at the front of the line with that woman, leaving 1 man. Or you could have 3 women come into the line at once. So that would get rid of the 2 men who were already waiting and leave 1 woman. And there's lots of things you can do with that, but we have time constraints here, so I wanted to give you the basics for setting up a simulation. And that's what we did in this exercise. And with that, we're finished with this chapter. In this chapter, we're going to talk about associative collections. An associative collection is a collection where a value is associated with a key that is used to look up the value. So a common example of an associative collection is the phone book, where you use a person's name to look up their phone number. The name is the key, and the phone number is the value that you're looking for. In Java, the interface that associative collections are built on is the map interface. So we're looking at the documentation page for the map interface now. And so you'll notice that at the very beginning here, we have map and then K, V, which represent type parameters for the key and the value. So that's the first thing you have to know about working with maps, is that we're going to enter a data type for the key and a data type for the value. And they don't have to be the same. In a phone book application, they might be. String for the name, string for the number. Well, let's say we were making a grade book. There we would have string for the name and some numeric type, double or integer, for the value. So let's scroll down a little bit and take a look at the methods that make up the interface. And we're not going to look at all of them. I'm just going to mention a couple right now. The first one we're going to talk about is put. Put is the main method for adding data to a map. So we have a key and a value that we can add to a collection. The main method for retrieving information is get, where all we provide is a key, and then the value is returned if the key is found. After those two, we have primarily maintenance methods, such as remove to remove a key, size to find the size, values, which returns all of the values stored in a map, and then key set, which returns all of the keys. So those are the primary methods that are used in implementing the map interface. So without further ado, let's move on to the first real lesson of this chapter, where we're going to look at a particular implementation of the map interface, and that's a class called the Treemap. In this lesson, we're going to get an introduction to one of the associative collection classes in Java, the Treemap class. And we're going to use it to store a set of names and phone numbers. So let's get started. We're going to call this program numbers.java. The first thing we need to do is to import the Treemap class. So we'll do that first. Then we'll start our program. To instantiate a Treemap object, we have to tell it the data types of both the key and the value. So for a phone book, it's going to be simple string and string. String for the name and string for the number. So we'll call our Treemap object numbers, and then call the constructor. Then open and close parentheses. To add a key value pair to a map, you use the put method. So we'll write a name and a number. Let's do a few more. Let's do one more. There we go. To retrieve a value, we use the get method with an argument of a key. So for example, if I want to see Cynthia's number, I'll write numbers.get and then pass in Cynthia. So let's compile this and see what we get. Javac numbers.java and then Java numbers. And we see that Cynthia's extension or phone number is 2335. Let's add another number. Then let's look at the size of our map at this point. So we call the size method, and it will tell us how many key value pairs are being stored in our tree map. Let's compile and then run. So we see that we have 5. If we want to remove one, we call the remove method with a key. And then we can check the size again. And see if the size went down to 4 when we removed an item. Those are the primary methods that we use to work with Treemap. There are some other things that we can do. I'm going to save that for the exercises. So now let's move to the next associative collection that we're going to look at, and that's called the Hashmap. In this lesson, we're going to see how to use the Hashmap class as a way of storing key value pairs. The Hashmap class differs from the Treemap class that we just looked at in that a hashmap cannot guarantee the order of the items in the collection. So for example, in a Treemap, the keys may be in alphabetical order or numerical order throughout the lifetime of a program. With a hashmap, there is no guarantee of any such order. Other than that, they are exactly the same, and for most situations, they can be used the same. Since generally when we're working with associative containers, we're not worried about the order so much as being able to retrieve a value based on a key. So let's look briefly at how to use the Hashmap class. We're going to write a program called grades.java, and in it we're going to store a set of grades. First thing we have to do is import the Hashmap class. So we'll do that first. Then we'll start our program. First thing we want to do is instantiate a Hashmap object. So we have to provide the data types for the key and value. So we'll do string integer for a set of grades, followed by open and close parentheses. To add name grade pairs, we use the put method. We'll put a few grades in here. We'll do one more. To retrieve a grade, we use the get method with a key. So for example, if I want to print out Smith's grade, I would write grades.get and then provide Smith as the argument. So let's compile at this point, see what we get. And so Smith's grade is 88. We can check the size of a hash map using the size method. Let's try that real quick. We have 4 grades in our collection. If we need to remove a grade, we have a remove method where we provide the key, and it will remove that key, assuming it's there. Well, let's add the size back in. So let's copy and paste that. Add that back in. There we go. And now we just have 3 grades. If we want to check to see that a key exists before we actually remove it, which is usually a good idea, we can say grades contains key brown and put that inside an if statement. And we might add a little message here, call it a record. Let's compile and try that again. There we go. And another method that I won't demonstrate here, but can be used, is one called contains value, where you might want to check to see if a particular value exists in a collection. It's not used as often as contains key, though, so I won't demonstrate it here. But with that, you see the general operation of the Hashmap class. These are the methods that you'll use the most often. And with that, we'll wrap up this lesson, and we're ready to move on to the exercises for this chapter, where we're going to take a look at some practical examples of using the Treemap and the Hashmap classes. For this exercise, we're going to create a word list, and then we're going to create a word count from that list of words. So I've got a quote from Lewis Carroll's Alice in Wonderland that we're going to use. We've used this before. So I've already got the program started. We're calling it wordCount.java. We'll pick up right after we've assigned the quote to our variable text. So the first thing we're going to do is create an array by using the split method to split on a space. So I've taken out all the punctuation as I did before, and all we're left with is words and spaces. So that's the first thing we're going to do. Then we're going to sort the array into alphabetical order by calling the sort method from the Arraylist class. Now we're going to introduce a count variable, which we'll use later to track how many times a word appears in the quote. Now we're going to print a list of the words, so we'll have a list to work from. That's what this for loop does. Now we're ready to begin building the word count. We're going to use a Treemap object with string and integer as the key and the value. The word will be the key, and the number of times the word appears will be the value. And we'll call our object word list. So that creates the object. Now we're going to create 2 variables, this word and next word. We use that to work through the word list, checking to see if a word appears more than once. You'll see how that works in just a moment. In fact, we'll start that right now. So we're going to write a for loop. And in that for loop, the first thing we're going to do is take the current word and assign it to this word. And at that point, we'll increment count by 1 for the first occurrence of a word. Then we'll assign the next word, the I+1 word, to the variable next word. Then we can perform what I like to call a negative comparison. So we're saying if not this word equals next word, put this word and the current count into the Treemap word list, and then set count back to 0 because we're getting ready to start looking for a new word. Otherwise, stop the loop. So what's going to happen here is we're going to be comparing the current word and the next word, this word and the next word, the word that comes after the current word. If they're not the same, then we put this word and the number of times this word appears in our Treemap object word list and set the count back to 0. Otherwise, go back up to the top of the loop and start over again. Now, this works very well for an even number of words. There is a problem with odd number of words, so let me add that piece of code in, although we have an even number of words in this particular little comment here to talk about handling an odd word list count. This will get the last word in the array and put it into next word. And then we'll check to see if it's equal to what's in this word. And if so, increment count. Otherwise, then this is the only occurrence of that word. And set count equal to 1, and we're done. And then finally put that last word into the word list. But we only need to do that if we have an odd number of words. So what I'm going to do here is I'm going to say if words.length mod 2 not equal to 0, word list put next word count. And in fact, what we might choose to do is put all of this into a if statement. This is a touch inefficient. I'll leave it as an exercise for the viewer to put all of this code inside this if to only occur if we have an odd number of words. We'll leave it like it is for now and move on to the rest of the lesson. The next thing we want to do is we want to generate a listing of the words and the word count. So to do that, we're going to have to create what's called an entry set, which is a set of all of the entries in the word list. So we do that by using the set class and create a set object, and then call the entry set method of word list to create that set. Next, we create an iterator to allow us to move through the set. And then we say while I has next, in other words, while there is a entry to display, get it, that's what I.next does, and cast it into a map entry object. In other words, a key value pair. Then display the key. And then display the value, just like so. And that's all we have to do. So let's save our code. Compile it. And there's our list. We have a list of the words first. Let me scroll back up so you can see that. Then we have a list of the number of times the word appears. Let's pick one to test it. She appears 10 times. Let's go back up into our word list. Find she, and let's count. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So yes, indeed, she does appear 10 times. Let's look at 2 real quick. 1, 2, 3, 4, 5, 6, 7, 8, 9 times for 2. We'll find it in our word count. 2 is 9. So we could take our time and go through each one of these. That's not necessary. but our program works as advertised. So with that, we wrap up this exercise and we wrap up this chapter on associative containers. In this chapter, we're going to be looking at some classic data structures. And the first of those data structures is the stack. So I've put up the Wikipedia page for the stack just to let you look at a diagram. A stack is an example of what's called a last in, first out data structure. And by that I mean that the last item put onto the stack is the first item taken off. You see an example here in the diagram. We use the method push to put a new item onto the stack. And then when we're ready for the top item to be taken off, we use the pop method. And those are really the two primary methods of the class. There also are sometimes some helper methods, and we'll look at two of those in our example. Peek, which allows us to look at the top of the stack without actually popping the top off, and empty, which lets us know if a stack is empty or has data in it. So with that, we're ready to start looking at how stacks work. So let's get a command prompt window open, and let's start our program. We're going to call it stackexample.java. First thing we need to do is import java util.star. Then we're ready to start our program. We start a stack with the keyword stack, followed by the name of the stack, and then calling the constructor. Notice that unlike our earlier collections, we don't provide a type parameter. All the data stored in a stack is stored as the object data type, which is a bit inefficient, but it's fairly flexible for what we're going to use a stack for. So again, the way we add data to a stack is with the method push. So let's push a couple of names onto the stack. Then let's look at the top of the stack, see what we have. And that's the peek method, and peek returns the top of the stack. So let's compile and run this program to see if everything's working correctly. Notice we get a couple of warnings, but there's no problem, so let's move on and run the program. So the top of the stack is David, which is right. David was the last item added to the stack, so it's at the top, and peek always returns the top. So if we want to remove David from the stack, we'll use pop, and then we can peek at the top of the stack again. Just copy and paste that. So let's compile and then run. So now Raymond's at the top of the stack because we popped David off. Let's push another name on. Then look at the top of the stack. Then let's use empty. So we might say if not names empty, names pop. And then we can look at the top of the stack again. So starting with this line, we added a new name, Cynthia. Then we printed out the top of the stack. Then here we check to see if not names empty. Normally, you'll see the not right by the object name, so we'll take that space out. If it's not empty, we'll pop it because it's an error or an exception is thrown if you try to pop an empty stack. So we almost will always check first. We didn't above just because I knew that the stack was an empty and I wasn't quite ready to introduce the empty method yet. But normally you always want to check before you pop a stack. All right, so let's save that. Let's clear the screen, compile again, and then run. So we started out with Raymond and David. Then we popped David, left with just Raymond. Then we pushed Cynthia. Then we popped Cynthia, and the top of the stack left is Raymond. We can pop one more time. So let's go ahead and do that. And again, I'll leave the empty out. I won't check because I just know it in this case. And then let's see what happens when we try to display the top of the stack. We'll just compile from here and then run. And there's the exception. You can't call peek from an empty stack. So that's why checking lots of times is the best thing to do. So we could add this right here. And then we'll add an else here. A little stack empty message. Let's try it again. Compile, and then run. And notice we don't get an exception this time because we checked first. And so after we pop Raymond, then we try to do a peek. That's in the if statement right here, where we try to peek. And it wouldn't let us do it because names was indeed empty. So we went to the else, and it wrote out stack empty. So those are the basics for using a stack. And we'll come back into the exercises in just a little bit, a few lessons from now. And I'll demonstrate one possible use of a stack, and that's to convert decimal numbers to binary. In this lesson, we're going to look at the queue data structure. We already covered a type of queue earlier in the course when we talked about priority queues. Now we're going to look at just a very standard queue implementation. But we're not really going to use a queue class. We're going to use another built-in class that's already part of the Java library, the linked list class. And we're going to narrow down the linked list to just a couple of methods that we're going to use. And then in the exercises, I'll demonstrate a use of using a pure queue class. So let's get started. We're going to call this program name queue because we're just going to put some names into a queue. Keep the instruction on this simple. First thing we need is our linked list class. And before we start, let me talk a little bit about what a linked list is. A linked list is just a data structure where each element is linked to the other element. A lot of times we call those elements nodes. And in fact, we're going to look at nodes in the next lesson on binary trees. But a node is simply an object that has room to hold data and pointers, either to an object that follows it or also to an object that precedes it. A singly linked list is a linked list that has pointers to the nodes that follow it. A doubly linked list is a list that has nodes that have both forward pointers and backward pointers, succeeding and preceding pointers, if you want to look at it that way. But we're not going to worry about that. We're going to simply use our linked list to talk about queues. So let's talk for just a minute about queues, although we should already be familiar with them. A queue is a data structure where the data goes in at the back and goes out at the front. Again, we think of a line at a grocery store or the line at a bank as an example of a queue. So what I'm going to do in this lesson is show you the methods that you need to operate a queue or to write a program using a queue. And then in the exercises, we'll look at an example. Here, we're just going to simply put names into the queue to demonstrate how they work. So the first thing we have to do is instantiate our queue as a linked list. So we're going to write linked list string names equals new linked list string open close parentheses. As I mentioned earlier, data is always added to a queue at the end. So the method that we use is add last. So add last will put the name in at the end of the queue. So let's add a few more names. Write a for loop to go through the names, just to display what's in the linked list. So we'll write our for loop like so, using the standard format we've been using. Here we'll simply print them out, one name per line. Let's close out the program, save it, and compile. And then we'll run it. And there are our names. So, adding data to a queue is performed with add last. To remove a name, we use remove first. And we don't specify a name, we simply say remove first, and the first name, the name at the head of the queue, is removed. So let's take a look at that. So we'll remove one name, and then we'll display the queue again. Save it. Let's clear the screen. Compile it, and then run. So we had Cynthia, Raymond, David. Now we just have Raymond and David. Now let's add a name into the list again. And then we'll print it out again to see where that name comes into the queue relative to the names that are already there. And what we probably need to do is after each one of these for loops, we need to add a blank line just to make it easier to see where we're displaying information. Let's run again. So we'll compile and then run. Okay. So you see that we started out with Cynthia, Raymond, and David. Cynthia was removed from the line. Clayton was added, and see that Clayton goes in at the end, and Raymond will be the next name that is removed. We can also look at the size of our queue, how many elements are in it, using the size method. Let's take a look at that real quick. Compile and run. We have 3 names in the queue currently. And then finally, we can also check to see if our queue is empty and only try to remove if our queue is not empty using the isEmpty method. So we can say if not, names is empty. And let's display the size again. Let's clear the screen first. And we'll compile. Then run. So we used our isEmpty method to make sure that the queue was not empty, and it wasn't. So we removed Raymond from the list, and we can verify that by using our for loop again. We'll compile, then run. So you see that now we're down to David and Clayton. So those are the fundamental methods you'll use with the queue. Now, they're certainly not all the methods that are part of the linked list class. But what I was trying to do was minimize the interface to just those methods that are typically used with the queue. And even those are not all the ones that are used, but the ones that we're the most interested in. So we're ready to move on to the next lesson where we're going to talk about binary trees, and we'll come back to queues in the exercises where I demonstrate a different use for queues than we saw in the previous chapter with priority queues. In this lesson, we're going to look at another data structure, the binary search tree, which is a specific type of a binary tree. I pulled up the Wikipedia page for binary search tree so that you can see a diagram of what a binary search tree looks like. Binary search trees are made up of nodes, parent nodes and child nodes. A parent node will have 2 child nodes, a left node and a right node, and that's all. That's the binary part of the tree. The first node in the tree is called the root node, number 8 here, and 3 and 10 are the left child and the right child of the root. The root node does not have a parent node, but has 2 child nodes, but other child nodes can have parent nodes, such as 1 and 6 have the parent 3, 13 has the parent 14, 14 has the parent 10. Oh, I should also mention that binary search trees have a property that make it very easy to find the minimum and maximum values of a tree. We're going to explore that feature in the exercises. So let's see how to create binary search trees in Java. So the first thing we're going to do is we want to create a node class. So we'll start off public class node. We're going to use all integer data for this example to keep things simple. So our first field will be the data field, which is integer. Then we create left and right child nodes. So those are the other 2 fields of the class. Next, we're going to create a constructor, which takes 1 parameter, and we assign it to the data field. And then we assign null to the left and right child nodes because they will be assigned values through the insertion process, which we'll look at in just a moment. We'll also create a default constructor right there. And then finally, we'll write a getData method to retrieve data from a node. So let's exit and save. And then let's compile it just to make sure everything is working fine. Okay, so now we're ready to build our binary search tree class. So we'll call this program binarysearchtree.java. The only field we're going to define is the root node, and we'll make it public so that we have easy access to it. So we'll declare it first. Then we'll create our constructor, which will simply assign the root node null, the null value, and then it will get assigned data later. Now let's define an insert method. So to insert a new node, the first thing we do is create a new node. Then we assign the data to the node, like so. Then we check to see if the root is null. And if the root is null, then that means we're creating a new binary search tree, and the new node becomes the root because it's the first node being inserted. The first node inserted is always the root. Otherwise, we create a node called current and assign it to be the root. Then we create a parent node, and these are all just temporary values. Then we set up a loop that will run until we break it. Set the parent equal to the current. Then if the data that we're trying to insert is less than the data that's stored in the current node, then we want to move to the left. If you remember how the binary search tree was set up, lesser values go to the left. And if the current node is null, then we're going to set the value of the left child of the parent to the new node and then break. Otherwise, if the data is not less than, then it must be equal to or greater than. So in that case, we're going to go to the right, like so. Check to see if the current node is null. What that means is that there hasn't been any data assigned to it yet. And then we assign data to the right child of the parent, and then we break. So we close off the if, close off the else, close off the while. Hope I get these lined up. Close off the other else, and then close off the insert method, and then close off the class. So we'll know here in a moment if I got all those braces correct, as we're going to compile. And I did. Surprised a little bit. So we're going to learn how to traverse a binary search tree and check minimum and maximum values in the exercises. But let me do one more thing before we end this lesson. Let's just create a program that we're going to flesh out in the exercises. So what I'm doing is I'm creating a new binary search tree object. Then we're going to insert a few values. And what I want to do is I want to compile this just to make sure that everything's working correctly. And then when we get to the exercises a bit later, we'll learn about traversals and finding minimum and maximum values. There will be no output from this, but we'll run it anyway. Make sure we don't have any runtime errors. And we don't. So that's how we create a binary search tree. It's really just a matter of moving to the left or right down a set of nodes until you get to a null node and then inserting the data at that point based on whether you're going to a left child or a right child, and that depends on the value of the data compared to the value of the data in a current node. So with that, we're finished with this lesson, and we'll come back to binary search trees again in the exercises. In this first exercise of the chapter, we're going to see how to use a stack to do something useful. In this case, we're going to use a stack to convert a decimal number to binary. So let's get started. We're going to call this program convert. First thing we need to do is import java.util.star. Then we can start our program. What we're going to do is we're going to create a function, and we're going to call it binary. and it's going to take an integer as a number, and then it's going to convert that number to a binary form. So the first thing we're going to do is create a final variable base. It's int, and assign it 2 because we're going from base 10 decimal to base 2 binary. Next, we create our stack. Our stack is going to hold the digits. I'm going to explain how that works in just a minute as I get through the algorithm. Now we write a do while loop. So what we do is we push onto the stack the result of number modulus base. And that's going to end up being a bit or a binary digit. And so that's the first thing we do is we take the number modulus the base and push it on the stack. Then we take the number and divide it by the base and store it back into the number to continue on to the next placeholder. And we do this while the value of number is not equal to 0. That's how the algorithm works, or at least the main part. That will create our string of bits. Then what we have to do is we have to get those bits out of the stack. So we're going to create a string. We're going to call it bits. And then we just say while not digits empty. So while there's data in the stack, grab it with peek, then pop it off, which is one way to do it. And that's all we have to do. Then when we're finished, return the bits, and there's our method. So now we'll write our main program. We'll do 5. 5 in binary should be 101. Then we'll just say system out, println, num, and binary is, and call the function with num, just like so. A very simple main program. So let's save it. Bring up our command prompt, compile, and then run. And 5 in binary is 101. So let's look at the algorithm again. Very simple. Take the number modulus the base, push it onto the stack. Divide number by the base, store it back in number, and continue doing that while the value of number is not equal to 0. That will get your string of binary digits. Then simply loop through the stack, grabbing the top, either through peek or pop, until you're out of data on the stack. Then return the result, and that's your number in binary. And with that, we're ready to move to the next exercise. In this exercise, we're going to use queues to perform a type of sort called a radix sort. This is a fairly lengthy exercise, so I've already written some of the code in advance. In fact, I've written all of main already to save us a little bit of time. The way radix sort works is that we create a set of queues, in fact, an array of queues. And the queues we're going to hold numbers 0 through 9, 10 through 19, 20 through 29, and so on and so forth. And then what we're going to do is we're going to take the numbers in the array that we're trying to sort and distribute them among the queues based on their values. And then once all the numbers have been distributed, then we're simply going to go back and collect them into one array. And by taking the queues in order from the 0 through 9s through the 10 through 19s and so on, then we'll have our numbers in sorted order. So that's what we're doing in main. We're creating an array of queues. Then we initialize that array, or each queue in the array. Then we create an array called numbers. Then we assign it some random values. Then we display it to see what it looks like unsorted. Then we'll begin our series of distributions. A set of distribute and collect for getting the numbers in ones place. Then we display. And then another set of distribute and collect for the tens place. And then we display the final result. So let's go on now and define our methods. The first method is distribute. It takes an array, a linked list array, or array of linked lists, and then the digit type ones or tens that we're trying to distribute. So then we write a loop, and we check the digit type, and if it's equal to ones, then we take the current element mod 10 of the array. That's going to be the queue that the number is going to be stored in, and we add that number to the queue using add last. If we're not doing ones, then we're doing tens. So here we divide by 10 and then add that number to the appropriate queue. Close the else, close the for, and then close the method. And that's how we distribute. Next, we have to collect. The parameters are the queue array and our numbers, the numbers that are in the regular array. So we declare a variable I and set it to 0. And we have a for loop. It looks at each queue in order. And as long as it's not empty, in the correct position of the array, add that number to the array by removing it from the appropriate queue. And notice that because queues or linked lists store elements as object, we have to cast to integer right here to get that into the right format. So that's how we collect. And then finally, last but not least, our display method, which I probably should have copied from somewhere else, but I didn't, so I'll write it out here real quick. We've seen this before. Here I'm just trying to display the numbers in lines of 10. I won't spend a lot of time describing how this works so I can get it typed in. Just have to make sure I don't type too fast. So that prints a blank line if we've had 10 items printed. And then we print a blank line at the very end. And we're done. So again, here's the main program. Most of the code, or at least half of the code, is just in getting things set up. Then to perform the sort, we only need 4 method calls, actually. Of course, those method calls themselves have many more lines of code. So let's save the file. Compile. Cross our fingers that there aren't any errors. Only one typo. Not too bad for a program of this size. I know exactly what the problem is. Let's find it. Our array type is called digits, not digit. So there we go. We'll save. Come back. Clear the screen. Compile again. Here's our unsorted array. Here's through the first pass. And the last pass is the array sorted. Now later in the course we're going to talk more about sorting algorithms, and we're going to look at some that are much more efficient than this. But I wanted to demonstrate a use for queues besides simulations, and radix sorting is certainly one application for queues. But with that, we're ready to move on to the last exercise for the chapter, where we're going to work with binary trees. In this exercise, we're going to look at 2 ways of traversing a binary search tree. One way is called in order, and the other way is called pre-order. There's actually a third way, post-order, but I'm going to leave that out because it's not all that useful, and you can figure out how to do it very simply after you see how to do pre-order and post-order. We're going to recreate the binary search tree you see in the diagram in front of you after we've written the methods for binary search tree traversal. Then we'll use those 2 methods to generate a list of the nodes in the tree. So let's get started. We're going to go back to our binary search tree class. Here's the class again. And now we're going to create the 2 methods. The first one will be the in order method. And all this first method does is present a public interface to call a private method by the same name with the root as its argument. So here's the private version. So InOrder is a recursive method that checks them first to see that the root node, which will be the original parameter or the original argument, is not null. If it is, then you move to the left. Then once you've moved as far left as you can, display data at that node. Continue moving left. And then when you're finished moving left, then you start moving right. And this probably looks too simple, but as any good method should be, it's just simple enough, and you'll see how it works here in just a moment. Now let's go ahead and write the preorder method. It also calls a private method of the same name with the root node as its argument. Its definition looks very similar to InOrder. The only difference is we write out the data in the nodes first as we come across them, and then move to the left, and then move to the right, like so. So let's save the program, and then compile it. Okay, now let's look at our program to test. So here we have our old B-tree program that we used in the lessons. Let's start over again. I'll just leave these in place and just change their data. And we're going to create several nodes here. So we'll do a little cutting and pasting, just making sure that we change the argument for each insert. And here's our last one. Let's do InOrder first. All right, so let's see what we get. Remember the order, 8, 7, 13, 3, 10, 6, 4, 1, 14 is the way we put them into the binary search tree. Now let's watch what InOrder does to display them. Clear the screen. In order, 1, 3, 4, 6, 7, 8, 10, 13, 14. So again, let's look at the InOrder method. Move to the left, go as far as you can, then display, then start over again, keep moving to the left, and then when you're done moving to the left, move to the right. So now let's try preorder. We'll just comment out InOrder. Save the program. Clear the screen. Compile. And then run. Notice how everything below 8 is here, everything above 8, 8 being the first item we entered, which will be the root, is below. And that's how preorder works. So the other traversal method is called postorder, and I won't implement that. It's very simple to do. Simply do postorder in.left, postorder in.right, and then display the data. And that'll show you how the binary search tree data is traversed in postorder. What I'd like to do now is move to the final exercise, where I show you how to write minimum and maximum methods for a binary search tree. In this last exercise of the chapter, we're going to develop methods for finding the minimum and maximum values in a binary search tree. Looking at a binary search tree, you can see that it's very easy to find the minimum and maximum values. To find the minimum value, you simply travel down the left of a tree until you reach the last node. To find the maximum value, you simply travel down the right nodes of the tree until you reach the last right node. So developing the methods will involve simply doing that, following the left or right nodes until you're out of nodes to follow. So let's develop the methods. We'll do minimum first. We'll call it min. First thing we'll do is we'll create a node and assign it to the root. That's where we always start, is at the root. And then we're going to simply say while current.left is not equal to null. In other words, while there's yet another left child node to travel down, travel to the next left node by writing current equals current.left, which will move us one more node down to the left. We'll stop when the leftmost node does not have a left child, because that will be false, or current.left will indeed be equal to null. So then at that point, we can simply return the data that's stored in that node. That will be the minimum value. To find the maximum value, we'll call our method max, and we'll simply travel the other way. So while current.right is not equal to null, move to the next right child node. And when you've reached the last one, return the data, or get data. Just like so. That's all there is to it. So we'll save the file, compile it. Now we'll go to our B-tree program. We'll use our same data that we used before. And we'll call min right here, like so. And then for the maximum value, and that should be all we need. So we'll save the file, back to our command prompt, compile it, and run it. The minimum value is 1, the maximum value is 14. Let's take a look at our code again. And indeed, minimum is 1, maximum is 14. So, again, one of the great advantages of binary search trees is making it very easy to find data. No matter how large the tree is, it's a minimum number of jumps, if you will, by just consistently traveling down the left or the right. It would be so much easier than if the data was in a linear format. Now, of course, if you're using some sort of data structure that you can sort, then it's much easier to find the minimum and maximum values, because the minimum value is at the beginning of the sorted collection and the maximum value is at the end. But for data that cannot be sorted, that's simply collected using a binary search tree, works great. So with that, we're finished with this exercise, and that wraps up this chapter. In this chapter, we're going to be looking at sorting and searching algorithms. And in this first lesson, we're going to start with one of the simplest sorting algorithms, the insertion sort. What you're looking at on your screen right now is an animation from Wikipedia that demonstrates how the insertion sort works. Essentially what we do is that we check each element as we come across it and then put it in the correct place in the order, so that when we're finished going through the array of numbers, in this case, we'll have a sorted list or sorted array. Now, the insertion sort is not particularly efficient, and I wouldn't suggest using it on anything other than a small set of data. But for a small set of data, under 1,000 items or so, it's fairly fast. Now let's see how to create the insertion sort algorithm. Let me delete any old ones that I may have. So we're going to call our program insertion sort.java. All right, we're ready to start. First thing we're going to do is set the size of our array, which we're going to keep it small so it'll be easy to see what's happening. After we've set the size, we'll declare an array of that size. Then we'll initialize it by writing a simple for loop and assign each element of the array a random number in the range of 0 through 100. So that's what I'm doing right here. After we've initialized the array, next thing we'll do is display the array so that we can see what the data looks like before it's sorted. So we'll call this before sorting. Essentially, this is the very same loop. So what I'm going to do is I'm going to copy and paste, and then we'll just modify it a little bit. Just like so. The next step then is to begin the sorting algorithm. So I'll skip a space so it's clear to see what's going on there. So we start out with an outer loop that runs from the first element of the array through the end of the array. Then we have an inner loop that begins at whatever value of I we are on, runs while j is greater than 0, and we decrement each iteration of j. Now we do a comparison. And then we say if the value of data sub j minus 1 is greater than data sub j, then we want to swap those elements. So we create a temporary variable, temp, and we're going to do a swap. And then data j is equal to data j minus 1. And data j minus 1 equal to temp, like so. Then close the if. Close the inner for. Close the outer for. Print a blank line. And we'll do an after sorting. And then we'll use this loop right here to print out the results of our sorted array. It's like so. Close main, then close the class. So let's see how it works. Save. Come back to our command prompt. Compile. So you see we have 88, 53, 80, 0, 50, 47, 95, 39, and 2 40s. And we have 0, 39, 40, 40, 47, 50, 53, 80, 88, and 95. Let's run it again. We see we still go from a unsorted to a sorted array. Let's do it one more time. Again, we're looking at the bottom here. And you'll see that the sorting algorithm works just fine. So again, this is a very easy algorithm to implement. It's easy to understand, but it's inefficient for larger data sets. And later on in the chapter, we'll look at an algorithm or two that are much better for large data sets. But for now, we're going to move to the second sorting algorithm in this chapter, another one that's easy to implement but not all that efficient, and that's the bubble sort. In this lesson, we're going to look at how to do a sort using the bubble sort algorithm. And I've got an animation of the bubble sort algorithm running right now. The way the bubble sort algorithm works is it works through an array and swaps greater and lesser values. So notice we're at 8, 7, and we swap it with 7, 8. Here we have the combination 8, 2. We swap it to get 2, 8. Next, we're going to have 8, 4, and we're going to swap that to get 4, 8. So what we're doing is we're bubbling lesser values to the front of the array and greater values to the back of the array. So notice the 3 and the 5 swap here. Now the 1 and the 5 is going to swap. Now the 5 and the 6 are in order, so they won't swap. 6 and 7 are in order. The 7 and 2 are not, so the 2 and the 7 will swap positions. The 7 and the 4 will swap positions. And so notice how the 7 now is in its right place. Notice that when they're in the right place, they change to a black square. So now the 1 is in the right place. 3 and 5 are correct. 5 and 6 are correct. The 2 and the 6 will swap here. Now the 6 and the 4 will swap. And now we have 6, 7, 8 in the right position. We'll start over again. The 1 and the 3 are fine. The 3 and the 5 are fine. The 5 and the 2 are not, so we'll swap those. The 5 and the 4 are not, so we're going to swap those. Now we're just down to 1, 3, and 2. We really only have to make one more swap right here. So we make this swap. Now everything is in the correct position. So let's see how to implement the bubble sort algorithm. We're going to use the insertion sort program we used before as a base for our bubble sort. So let's copy that code. You'll see I've already done a little bit of work on that. And we're going to create notepad bubblesort.java. Create a new file, paste in the old. Let me take that out. So what I'm going to do, and what I've already done actually, is I've commented out the code for the insertion sort. And what I'm going to do is I'm going to write a function this time for the bubble sort. So let's take a look at that. The bubble sort method will take an integer array as its parameter. The first thing we do is we determine the size of the array by getting the length. That will become a variable we're going to use in our for loops. And we're going to write nested for loops just like we did before. Our outer loop will start at 1. It'll run through the end of the array and increment by 1 each time. Our inner loop starts at 0, continues on while I is less than size minus pass, and increments by 1 each time. And here's where we do our comparison and then our potential swap. Array sub I is equal to array sub I plus 1. And array I plus 1 is assigned the value in temp right here. With that, we're finished, so we close everything out. It's a void function because arrays, of course, are reference objects, so we don't have to pass an array back and forth. Now let's go back and look at our main program. In our main program, we have the same code we have before. So we write our first loop to initialize our array with random values. Then we display our values right there. So where we had the insertion sort, which is this commented out code, we will put a call to bubble sort along with our array data. Save the file. Go back to our command prompt. Let's clear the screen. Compile. Now run. So we had 39, 61, 61, 48, 10, 18, 51, 66, 60, 72, and 10, 18, 39, 48, 51, 60, 261, 66, and 72. Let's run it again. I won't read them all out, but you can check to see that it is sorting, so you can see that it works. So the bubble sort is another very simple sorting algorithm to implement. But again, and we'll give the same warning that we give for all of these, they are very inefficient for large data sets. So use them only on small sets of data when you need to. And as I'll mention later, that you should really use library sorts anyway. But, these are possibilities for sorting that are easy to implement should you choose to implement your own. But with that, we're ready to wrap up this lesson and move to the next lesson where we're going to look at the first of the more sophisticated sorts that are useful for large data sets, and that's called the merge sort. In this lesson, we're going to look at the more robust merge sort. Merge sort works by splitting up the array into individual pieces, as you can see in the animation in front of you. Then it compares adjacent elements and puts them in order. So notice now the 8 and the 7 will be swapped, and the 2 and the 4 will stay in place. Next, it looks at adjacent elements of each pair and then orders those. So now we have 1, 3, 5, 6, and we'll have 2, 4, 7, 8. And then finally, both parts are merged and sorted into the final correct order. Notice that each half is in order, so it's just a matter of taking one from each pair, sometimes 2, and then putting them into place. All right, so let's see how we would implement the merge sort algorithm. We're going to call our program mergesort.java. I'm going to take the beginnings of the bubble sort program. First, let's change its name to merge sort. And then let's get rid of any code that represents either the insertion sort right here, we'll get rid of that, or the bubble sort call right there. Okay. The other thing we're going to do is we're not going to create our array from random numbers. So we're going to delete that section. We're going to assign our array with an initialization list. So let me do that real quick. Okay. Another thing we have to do before we implement the algorithm is set the values for the lower bound of the array 0 and the high or upper bound, which is 9. We'll see how that works in a minute. Now let's get into the actual merge sort algorithm itself. So we're going to write two methods. The first one is called merge sort. It's the main method, but it's going to use a helper method also. The first thing we do is create a variable size that holds the array's length. Then we make sure that low is less than high. And if it is, then we compute a middle value, which we'll use to split the array into two. And then we're going to call merge sort with the lower half. That's this one. And then call it with the upper half. Like so. Then we call a helper method merge to do most of the actual work. And that's it. The merge method is a little more complex, as you'll see. First thing we do is we create a temporary array. Go back and compute the size again. Then we're going to initialize the temp array. And we need three variables to represent the low, the position right past the middle, and then we need the low value again in K. We'll call it right there. Now we're ready to loop through the data and sort it. That's what we'll be doing right here. I won't be doing a lot of talking here because I need to concentrate on my typing. So please bear with me. So what we're doing is we're using the temporary array as a placeholder to sort out the data, so to speak. And then once we have it in the order that we want, then we put it back into the regular array, which is ARR. So that's what I'm doing right here in these lines. And we have one more while loop. This is the final loop that pulls everything together. Increment K, and then increment I. Close the while. Close the method. Go back to our program. Here's where we would have the merge sort call. So we'll call it merge sort with data, low, high. And remember that low and high represent the lower bound of the array 0 and the upper bound 9. So now let's save our code. Back to our command prompt. Clear the screen. Compile. And then run. And there's our original array, and there's our sorted array. In the exercises, we'll try this with a larger data set because we're going to do some timing experiments. And we'll see how much faster merge sort is than, say, insertion sort or bubble sort. So we'll come back and look at this algorithm again in the exercises. But for now, I'm ready to move on to another lesson where we're going to look at another robust sorting algorithm, the Quicksort. In this lesson, we're going to look at the Quicksort algorithm, which is another divide and conquer algorithm for sorting data. We're looking at an animation of it now. What happens is in a Quicksort, you pick a pivot point. The pivot point then becomes a tool for comparing values. Notice what we're doing is we're sorting values to be on either side of the pivot point, 3 being the pivot point, depending if it's less than or greater than the pivot. Now 1 is chosen as the pivot because we're continually bisecting the array. The pivot is always found as an approximate midpoint until the data is sorted. So now we see that 1, 2, 3 is sorted. It's going to pick another pivot. Everything's in order. Now it picks another pivot 4. It compares it with the other n 5. Those are out of order, so it swaps them. Now it looks at 8 and 6, and 8 and 7. Those are not less than 4. Now the new pivot is 6. 5 is less than 6, so 5 and 8 are going to be swapped. 7 and 6 are also out of order, so 7 and 6 are going to be swapped. 6 and 7 are in the right order. Now it picks a new pivot 5. 5 and 6 are already in order. Now it picks a pivot 8. 7 and 8 are already in order, so nothing else has to happen, and our array is sorted. So let's look at how to implement the Quicksort algorithm. I've already begun a program. Let me spread it out just a little bit here. I have a display method to display the contents of an array, and then we create an array, and we call a Quicksort method to sort it. So all we have left to do is implement Quicksort. So let's get to that. We're actually indented just a little bit too far, but I'm not going to change that. That'll be fine as it is. So our Quicksort method takes 3 parameters: the array we're trying to sort, a left value, and a right value. So if you see down in the method call, left and right are always the lower bound of the array and the upper bound of the array. That's the starting point. The first thing we do is we take left and right and assign it to some variables, I and j. Next, we create a temp variable we're going to use for swapping. Then we compute our pivot. And as you'll see, the pivot is chosen by taking the left and right values, again 0 in the upper bound of the array, and dividing by 2. That gives us an approximate midpoint for the array. So now we begin the process of sorting the data. If the data is already less than the pivot, which is what we're looking for right here, then we simply keep moving. And if data on the right-hand side is already greater than the pivot, then we move down and don't do any changes. Otherwise, we swap. And then increment I and decrement j. Close the if, close the while. Now, because we're doing segments of the array, we may need to call the Quicksort method again. Most times we will, as you saw in the animation earlier. So here's where we recursively call Quicksort if we need it. Just like so. And that's all we have to do. Okay, so here's our method definition. Here's our program again. We create a simple array of 10 elements, print out the unsorted array, call Quicksort, and then display the sorted array. So let's save our file. Open our command prompt window. Let me clear the screen there. Now we're ready to compile the Quicksort program. It compiles just fine. Then let's run it. Here's our unsorted array, 5, 10, 1, 9, 4, 8, 3, 6, 2, 7. And our sorted array, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And again, Quicksort is a method that we should use on large data sets. And it works just fine with small data sets also, but certainly should be used when a large data set is presented. And most library sorts implement the Quicksort algorithm for sorting. So it's clearly the preferred method for sorting data. And with that, we're finished with this lesson, and we're ready to move on to the next lesson where we're going to leave sorting for a while and move to searching algorithms. In this lesson, we're going to look at a simple algorithm for doing a linear search. And a linear search is simply starting at the first element of an array, or really any data collection, and moving down element by element, searching for a particular item. What we'll do in this particular lesson is write a method called min, or minimum, which will find the minimum value in an array, which is the same thing as searching for the minimum value. But you can use this algorithm to search for any item. So let's get started. We're going to call this program linearsearch.java. And we'll skip a space because I'm going to come back to write our method in just a minute. So I'm borrowing the main program from the Quicksort lesson earlier, just so that we can use the array. We'll change a couple of these things. Actually, we don't need the middle part at all, so we'll just get rid of all of that. Really, all I wanted was the array. So let's write our minimum method. Public static int min, we'll call it min to save a little bit of space. And it's going to take an array as the argument. And what we're going to do is we're going to start the search by assigning the first array element as the minimum value, just arbitrarily. And then what we're going to do is we're going to work our way down the array until we've searched or looked at every element in the array and swap out the values if we find one that's less than the one that's originally assigned. So here's how we'll do that. We'll say for int I equal 1, I less than array.length, I plus plus. If array sub I is less than minimum, then minimum is equal to array sub I. That's all we have to do. This is a very, very simple algorithm. Then we'll return that as the return value for the method. So we can use it in our program like so. We have our array set up, and we can say int minimum equals min data, and system out print line. The minimum value is plus minimum. And that's all we have to do. Let's save it. Compile it. And then run the code. So what happens is that, of course, if you're looking at the array elements here, 5 is assigned to minimum first. Then it looks at 10. It says, is 10 less than 5? No. So then it moves down to the next element, 1. Is 1 less than 5? Yes. So now minimum becomes 1. Then it looks at 9, 4, 8, 3, 6, 2, 7. You see at no point are any of those values less than 1. So 1 becomes the minimum value. Again, we call it a linear search because we're working sequentially down through the array element by element in a linear fashion. It's a very simple search method to implement, but the problem with it is it's not very efficient. Imagine we had 5, 10,000, 100,000 elements, and the minimum value is way down in the data set. Well, it's going to take a long time to reach that value. So there is a faster way to perform a search, and it's called a binary search, and it works on a sorted data set. Notice that our array in this example was not sorted. The binary search works only on sorted data, but it's quite a bit more efficient, and we're going to look at how to implement the binary search in the next lesson. In this lesson, we're going to look at the last of the algorithms for this chapter, and that's the binary search algorithm for searching for an element in a sorted collection, such as an array. And it's very important that the collection or array be sorted before the binary search algorithm is applied, because it won't work if the elements are not sorted. So let's go ahead and get started. I've already written part of the program here, so let's go over that real quick. We have a display method for displaying the elements of our array, so we can look at them after they're generated. In fact, we need to add that into our program right here. After they're sorted, we need to display them. And then, of course, I've generated an array full of random numbers, 100 numbers to be exact, 0 through 99 in the array. And we use the math random method to generate random numbers. And then we prompt the user to enter a number to search for. And at that point, we're ready to call the binary search algorithm, so we need to go ahead and implement that. So we'll start it right here. We return an integer because it's going to return the index position in the array where it finds the element being searched for, or it's going to return -1. Key is the value that we're searching for. So the first thing we do is we set up a couple of variables. First is the lower bound of the array. Last is the upper bound of the array, which is the length of the array minus 1. Then we have a while loop that says while first is less than or equal to last. And the first thing we do is calculate a midpoint, first plus last divided by 2. That'll be the middle element of the array. Then we say if the key that we're looking for is greater than the element that's at the midpoint, then adjust the first of our array, or in other words, move up to the top half of the array. So now the first of the array becomes the midpoint plus 1. Otherwise, else if the key is less than the midpoint, then adjust the last down. In other words, move to the bottom half of the array by making the last element the midpoint minus 1. If neither of those situations are true, then we've obviously found the element, so we return the midpoint. Finish off the while loop, and then if we go all the way through the loop and haven't returned the midpoint, then we never found the element, so we return -1 to indicate the element wasn't found. What we'll do here is we'll say int found equals binary search, numbers is our array, num is the element that we're searching for. And we can say if found is greater than or equal to 0, found key at position plus found, else key not found. Making sure I have all my closing braces in order. Looks like I do. Let's save it. Go back to our command prompt, clear the screen, compile again, and run the code. Here are our elements. Let's look for one that's in the middle of the pack. Notice we have some duplicates, and we forgot to do a new line there, but that's okay. So we'll do 36, and found key at position 45, which is right about in the middle. Let's run it again. We're not going to worry about any of our little discrepancies in formatting. Let's look for one that's close to the end, 98. Found 98 at position 98. That's fine. Do it one more time. Let's search for 3. That's right, found it at position 1. Clear the screen. Run it again. Let's try 19. 19 is not there, and key not found. So that's how the binary search algorithm is implemented. And with that, we're ready to move on to the exercises for this chapter. In this exercise, we're going to look at the timing differences between the bubble sort and the quicksort, so that you can get a feel for why quicksort is considered a more efficient sort. So I've created a program called timing.java. I've already put the 2 sort methods into the program. And then if we scroll down, you'll see that I've already started the main program by declaring an array and initializing it with random values. So now what I want to do is write some code to time both the bubble sort and the quicksort. So the way we're going to do that is we're going to create 2 variables, start time and stop time. And we're going to use a system time method, nanotime, which will record the current time in nanoseconds, as our starting time for the bubble sort. Then we'll call bubble sort on our array numbers. Then we'll create another variable, stop time, and it will also gather in the current system time in nanoseconds. And then finally, we'll create a third variable, duration, which is equal to stop time minus start time. And then we can say bubble sort took plus duration nanoseconds. Just like so. So let's save and compile just to make sure we're going correctly. So bubble sort took 311,841 nanoseconds. All right, let's go back to our code. Get the start time again. Call quicksort. Get our stop time. Get our duration. And display our result. Save the file. Let's clear the screen. Compile again. And then run. And you can see the huge difference. This time the bubble sort took 296,965 nanoseconds, and yet Quicksort only took 36,248 nanoseconds. Now, if you'll notice, we set the size of the array to only 100 elements. Let's bump that up to 1,000, and then let's run the program again. So we'll compile, and then run, and notice the difference. Bubble sort took 5,016,280 nanoseconds, and Quicksort took 442,165 nanoseconds. So even with this imprecise method of timing our code, we can still see that the Quicksort is much, much faster than bubble sort. I encourage you to take this code and insert the insertion sort instead of the bubble sort and try it out for yourself, but you'll see similar results. So that wraps up this timing exercise. Now we're going to do another timing exercise with searching this time, where we compare the linear search with the binary search. And we're going to do that in the next exercise. For this last exercise, we're going to compare linear search versus binary search by timing a linear search and a binary search on a fairly large data set. I have the linear search code and the binary search code already loaded into this program, which is called time search. And what we're going to do is we're going to create an array, unsorted, and then search it using linear search. Then sort the array, and then search it using binary search. To make things work the most efficiently, we need to make sure that the array that we use does not have any duplicates. That can cause some issues for our sorting. So to do that, we're going to have to do a little creative hacking, as it were, to get an array that doesn't have any duplicate numbers using random number generation. So what I'm going to do is I'm going to first use an array list, because using an array list, I can very easily check to see if an item is already in the array list before I add it. And that way I don't have to add any numbers that are already in the data set. So I've created an array list. Now I'm going to write a loop. And first thing I'm going to do is generate a random number. And we'll do that in the range of 100,000. That way I can be sure I'm not going to put any duplicates into an array of only 10,000 numbers. So the first step is to generate a number. Now I write an if statement and I say if not nums contains n, then we want to add it to the array list. Now once we have it in the array list, then we're ready to convert it to an array, but first we're going to print it out. And we'll go ahead and do that now. We want to display all the numbers so that I can see what numbers I'm working with. That's a lot of numbers, I agree. So I'm not even going to try to print it out in any particular formatted order. I'm just going to print them out using a for each loop. Let's print an empty line right here. Now I'm ready to take the numbers out of an array list and put them into an array. So the first thing we're going to do is declare our array. Then we'll write a quick loop. And notice we're having to cast the number coming out of the array list into integer, because remember that array lists store data as objects. You saw that up here in the for each loop, or you should have seen it, although I didn't mention it specifically. Now we're ready to search using linear search. So we're going to ask the user to enter a number. So to do that, the first thing we have to do is create a scanner object. We'll do that first. Then we'll prompt the user. and we'll get that number from the user using nextInt on the input. Then we'll get the system time in nanoseconds. Call the lsearch method. Get the stopping time, or the stop time. Then figure out the duration, which is stop time minus start time. Then display a little message to the user. Now we're ready to move to binary search. So to do that, we need to sort the array. So we call arrays.sort with our array. Prompt the user again. Get the number from the user. Call the binary search method. Record the stop time. Compute the duration. And then display the time. That's all we have to do. Make sure we've closed out the method, main, and the class, and we have, so we'll save the file. Compile it. Then run it. There's our long list of numbers. Let's let that run through. Let's pick a number out somewhere. Just pick one that's not too far long. 18,031 will be the number that we're going to pick. And we see that its linear search time took 54,756 nanoseconds. Let's do the same number again using binary search, and notice that it took just a touch longer. So let's do that again. Pick a number farther down. Let's look for a very large number. 91,375. That one took 40,019. So notice we're still getting a little bit worse time for binary search. So let's go a little bit higher in the numbers. We can find one. We're not going to get much higher than in the 90s. 98,207. So you see the time there. Run it again. So you see we're still very close. Let's go back and take a look at the program. And what we might do is we might increase the size of the array and increase the numbers generated. And let's see what happens when we run it again. Clear the screen, compile, and then run. Printing is going to take a minute as we're trying to print a very large number of numbers. So let's be patient with it while it goes. So it took quite a while to get the numbers to display. I/O is always very slow on any system. It's going to take a minute too as we scroll through the numbers. Hopefully this will give us a better sense of the difference between linear search and binary search. Okay, so we'll try 370052. So we see it takes almost 687,000 nanoseconds. In binary search, it took 46,724. Let's run the program again. Although this time, of course, we're going to have to wait for the numbers. There we go. So now we're about ready. Again, the scrolling will take just a minute or so here. Hopefully not too long. All right, so let's pick a number. 885,880. Took 916,000 nanoseconds, give or take a few. Do it again in binary search. 36,527. So clearly you can see that the binary search method is much more efficient for very large data sets. For smaller data sets, linear search actually is a little bit faster. But when you have a lot of data, it's always best to use binary search. The difference isn't so great that you shouldn't just go ahead and use binary search all the time. And in fact, most of the search methods that are built into most languages are based on binary search anyway. And as I always say, if there's a library search method available, always use it over something that you build yourself. It's instructive to build these methods yourself to see how they work and to practice with programming. But in quote-unquote real-world programming, it's always best to use something that's already built in. And with that, we've wrapped up this exercise and we've finished this chapter on sorting and searching. In this chapter, we're going to look at handling exceptions. And exceptions are errors that occur in your program at runtime as opposed to compile time. You're quite familiar with compile time errors, where you type a built-in function name wrong, or leave out a semicolon, or make some sort of syntactical mistake. Those are compile time errors. Exceptions occur when something goes wrong in the more normal course of the program. The examples I'm going to show in this lesson are trying to divide by 0 and trying to access an array element that doesn't exist. In other words, you go beyond the bounds of the array. I have 3 elements in an array, and I try to access the 5th element. That leads to what's called an out-of-bounds exception. These exceptions will cause your program to crash unless you handle them using something called a try-catch statement. And that's what we're going to spend this chapter looking at, how to work with try-catch. But for now, I just want to demonstrate in this lesson a couple of examples of exceptions being thrown and what happens when they are thrown. So let's get started. We're going to call this program exceptions.java. So we'll start with trying to divide by 0. That's a very common mistake that people make. And I'll set it up by just doing a very simple program. 2 variables, numer and denom. And then we'll try to print out, display, the result of dividing numerator by denominator. And watch what happens when we do that. You see that we have an arithmetic exception, divide by 0. So again, we compiled just fine. There was no problem with the compilation. The compiler doesn't recognize a 0 denominator as being an exception. It's the runtime system that catches this error or exception and causes our program to stop with an exception being thrown. That's the terminology that we use. An exception has been thrown. So divide by 0 is one example. Let's look at another example. We'll just comment out this code. Let's create an array. Make it a very simple one. 1, 2, 3. And then let's try to print num sub 5. Notice we're only going 0, 1, and 2. Those are the only elements that we have. So 2 is our last index position. So 5 is definitely beyond the end of the array. And again, watch what happens when we compile. No problem, but when we try to run, we get an exception. So those are 2 examples of how exceptions are thrown in Java. And now what I want to do is move on to the next lesson where we're going to look at how to handle these exceptions using something called a try-catch statement. In the last lesson, we saw what happens when an exception is thrown and it's not handled. In this lesson, we're going to begin to look at how to handle exceptions by using a try-catch statement. So let's get started. We're going to start a program called try-catch.java. And before I begin actually demonstrating the try-catch, let's look at the general form of a try-catch statement. So we'll have before the try-catch probably some sort of set of statements that we're going to begin with. Then once we do, then we'll have the try. The try is followed by an open curly brace that indicates the beginning of the block in which exceptions may be thrown from. In other words, these are the statements that could possibly be throwing exceptions. So we'll write that out right here. So those go inside a block. To make that a little bit easier to follow, I'll put it down here. The try is followed by a catch. The catch always has a parameter, and that will be some type of exception object. It can be a built-in exception, for example, one of the ones we saw in the last lesson, or it can be an exception that you create yourself. You can create your own exception objects. Inside the catch will go a set of statements to clean up whatever went wrong. Again, we're doing this so that our program won't crash and go back to the operating system level. So inside the catch will be whatever we need to do to clean up the mess that we made, so to speak. So with that, let's look at an example. Let's recreate the exceptions example from earlier. So we had a numerator, which we set to a value. Then we had a denominator, which we set to a value. In this case, the value is 0. Now, at this point, we're ready to introduce the try catch. So here we'll put the division expression itself. And that's all we need to have in there. Now we'll have the catch. Our parameter will be the exception that can be thrown, which is called an arithmetic exception. And then we'll just write E as our variable for that, or object. It's very common just to use the letter E. You can certainly have something more expressive if you want to. Now here we'll have some sort of display or some sort of message to the user telling them what went wrong, as well as something to clean up the problem. So here we might say system out, print line, can't divide by 0, followed by some way to fix that, and then try the statement again. Now, of course, right here, I'm simplifying things quite a bit. If this was a real program, we'd probably have a graphical user interface, and we'd put the focus back in the text box for the user to enter a new denominator, or wherever it is the user's entering the data. In a character-based program, I might prompt the user to enter another denominator. But just to keep things simple, I'm just going to reassign it myself right here to demonstrate that we can work our way out of this by reassigning a non-zero value for the denominator. So let's save this, go back to our command prompt. So now let's compile the program, javac try-catch.java. Then let's run it. So we see we printed the message, can't divide by 0, then it divided 12 by 2 to give us 6. So that's how the try-catch statement works. We try something that could lead to an exception. If the exception occurs, then it's caught here, and we do what we need to do to clean it up, and then continue on with the program. Of course, this is the end of the program, so we stop. But if there was more, it would go right after we end the catch. So those are the basics of the try-catch statement, and let's move on to the next lesson where we're going to look at another example. In this lesson, we're going to continue our examples using try-catch. This time we're going to write the beginnings of a program that will display the contents of a file, kind of like the type command in Windows or the cat command in Linux. So let's get started. We're going to call this type.java. First thing we need to do is import a couple of utilities. So java.io.star and java.util.star. And then public class type, public static void main. And this time, when we type string args for the array, we're actually going to use that array. Let me explain what we're going to do. I'll put some closing curly braces here while I talk. We're going to capture the file name that the user wants to display at the command line. And so it's going to be stored in the args array, in arg sub 0. That's going to become our file name. So what we're going to do is demonstrate how the file not found exception works by trying to type out a file that doesn't exist. And then in the next lesson, we'll demonstrate how to handle that exception, as well as write out the contents of the file. But to do that, we have to catch yet another possible exception, and that's going to be the topic of the next lesson. So in this lesson, all we're going to do is demonstrate how to catch a file not found exception. So the first thing we do is we take the command line argument in arg sub 0 and assign it to a variable. So that's string file equals arg sub 0. Now we're ready to try. And what we want to try is to open a file. So we have a buffered reader object in file equals new buffered reader new file reader file. Just like so. And that's all we have there. Then we're going to catch a file not found exception, E, and we'll simply write out a message, file not found, try again. And that's it. So let's save the file, compile it, then let's try a file that I do not believe exists, mydata.dat. And rather than going right into an error, we get file not found, try again. Let's try to type one that I think does exist. Ants.txt. And we have nothing. So we might want to add just a little statement here, just to let us know that it worked. So let's save it. Compile again, run it again with that data, file found, output to come later. So here's another example of try catch. We try to open a file. If the file's not found, it throws the file not found exception. It's caught right here, and our message is displayed. If the file is found, then we continue on through the rest of the program. Our file found message is displayed, and the program ends. So now in the last two lessons, we've seen some examples of singular catch statements or singular catch clauses in a try catch statement. Now let's look at how we would work with multiple catch clauses in a try catch statement, which will be the topic of the next lesson. In this lesson, we're going to continue working with our type.java program. This time we're going to add code so that we can actually read the contents of a file. So to do that, we need to modify the program a bit. We need a variable to store data when it's read, and then we need to read the data. So we'll do that in a while loop. Like so. And then we'll print out the data once it's read into the variable. And that's all we need. So we'll save the file. Compile it, and you'll see that we have an error. It says unreported exception java.io.io exception must be caught or declared to be thrown. So when we read from a file, we need to be able to catch an IO exception. So what we need to do is go back to our code and add another catch clause. So we'll come down below the one we already have and write catch IO exception E. Then we'll just print a message, problem reading file. So let's save, go back to our command prompt, let's clear the screen, compile, and then run it with a file that we know exists. And there we see that it reads the file. So the moral of this lesson is you can have as many catch clauses as you need to cover the different exceptions that may occur in your program. So if you needed 3 more catch clauses, we could just add them after the one we just added, or we can have just 1 or 2 depending on the situation. The point is that you can have as many catch clauses as you need, and you just line them up one after another. So that wraps up this lesson on multiple catch clauses, and we're ready to move to the last lesson of this chapter where we talk about the try, catch, finally statement. In this lesson, we're going to look at the final part of a try catch, and that's called a try catch finally. A finally clause or block will contain code that's executed no matter what, so that even if exceptions are thrown throughout the program, And no matter what state the program's in or where the code happens to be, before the program completes, the code inside the finally block will execute. So I've got our type program on the screen again, and we're going to add a finally block to it. So we do that just by typing finally, then open a curly brace. Then all we want to do here in this particular example is close our file. So we'll write an if statement that says if mfile is not null, then try to close the file. And we still have to catch because we still could have a possibility of an exception thrown. So we need to catch even the fact that we're trying to close the file. Of course, at this point, there's not much you can do here, but we're still going to catch it anyway. Close the if and then close the finally. So again, to make the point one more time, the code inside finally is going to execute regardless. In fact, even if we had no catch blocks or catch clauses in our code, finally would still execute if we have written it out. You need to use finally when you are needing to close resources. For example, closing a file. Because without doing that, you leave resources open and you can have all sorts of problems. Another good example, and we're going to learn how to do this in the next chapter, is working with a database. You always want to close a database after you've opened it, and you might put that in a finally block to close it at the end of a program, because again, you don't want to leave that database open. It's a waste of resources to leave files and databases open at the end of a program. So that's how the finally block works. We don't need to run this because you're not going to see any result from it. So I'll just leave the code here. And again, use finally for any code that you need to clean up your program before the program quits, because the finally block will be executed at the very end as long as it's present in your program. So that wraps up this lesson on the try catch finally, and we're going to move on to our exercise for this chapter. For this exercise with try catch, we're going to demonstrate how to add the ability to throw exceptions into your own class. So let's go ahead and get started. The class we're going to work with is a list class that we created earlier. Here's the class. And what we want to do is we want to add the ability to throw an exception when the user tries to use the toString method on an empty list. Since there's nothing to be displayed in an empty list, it makes sense that you could throw an exception saying you can't display this because the list is empty. To add exception throwing to this class, we're going to have to do a few things. Since we're already in the class, we'll start here. If we want a method to throw an exception, we have to tell the compiler that the method can throw the exception. So right here we add throws list empty exception to the method. Now down below in the definition is where we'll actually throw the exception. So what we're going to do, we're going to say if data store sub 0 is equal to null, in other words, if the list is empty, then we want it to throw a new list empty exception. And yes, I recognize that we haven't actually created the list empty exception class yet. We're going to do that right away. But that's all we have to do in the class definition to throw an exception. So it's fairly easy to add that to a class definition. So let's save that. Can't compile it yet because we don't have our exception class. So let's do that next. So we're going to write notepad list empty exception.java. And here's our exception class. I went ahead and defined it earlier just to save a little bit of time for the exercise. The way we do that is we write public class list empty exception extends runtime exception. Any exception that you create yourself has to extend one of the built-in exception classes, and I picked runtime exception. All we need is a constructor so that when we write throw new list empty exception, it will call the constructor. And all the constructor does is goes back to the base class, to the superclass, and calls the constructor for the runtime exception class along with the message list is empty. Let's put a period right there. And that's all we have to do. So let's save that. Go back to our command prompt and let's compile it. And it compiles just fine. Now we're ready to test our exception. So here's our program to test the exception. Again, I went ahead and wrote it up in advance. The program is called NameList, and all it does is it instantiates a new list, and then without adding any names to it, calls the toString method. If there are no names in the list, then it will throw a list empty exception, and that's caught right here. Our object is E, and we have it called the print stack trace method for exceptions. And all that does is displays our list as empty message along with line numbers for where the exception was thrown from. So let's compile that. Then let's run it. And there's our exception thrown. List empty exception, list is empty. At list to string, line 20, at name list, line 5. So the stack trace is useful for debugging purposes if you want to see where exceptions are being thrown. Now, it's not all that useful to the user, and in a real program, of course, we would present a message asking the user to go back and enter some names into the list before trying to do a toString. But for the purposes of this exercise, I thought a stack trace might be nice just to see how it works. So to review, you create a exception class of your own design that extends one of the built-in exception classes. Then in your program, at some point you will throw an exception. So here in the toString method is where we threw the exception. And then in the program that will work with the exception, you'll have to catch the exception at some point to make it worthwhile to do the design in the first place. So that's how you create your own exception classes. And with that, we're finished with this chapter on exception handling. In this lesson, I'm going to show you how to install MySQL on the Windows platform. If you're a Mac user, you can skip this lesson and go on to the next lesson where we'll install MySQL on a Mac. But if you're working in Windows, the first thing you need to do is open your browser and navigate to www.mysql.com. Once you get there, you'll notice that there's a tab right by the mysql.com tab that says Downloads. Click that tab, and right in the middle of the screen is the MySQL installer for Windows, which will have everything that we need and then some. So click Download, scroll down, find the MySQL installer for your particular operating system. Most Windows users are x86 32-bit, so select that. Otherwise, you can find the 64-bit. You'll need to log in, so log in with your email and your password, unless you don't have one, and then go through the registration process, and it will take you to the same place. At this point, it says you have chosen to open, and then the installer, click Save File. And then we begin the process of waiting while we download. Okay, we're just about finished. Just a few seconds left to go here. Now, once the download is complete, you can double-click the file to launch it. And once again, there's a lot of hurry up and wait while we go through the Windows installer process. If you see this message, click Yes. It probably won't happen on your machine. Let's click on this window to see what came from behind us. Here we go. So we want to install MySQL products, so we click that link. We will accept the license terms and move to Next. Click Execute. Click Next. We could do full installation. Developer default is more than enough for what we need. If you think you're going to use MySQL for other uses than just using it with Java, then by all means do the full installation. It won't change how this looks. It just may take a little bit longer. It'll take up more space on your hard drive. But I'm going to do the developer default. Click Execute here. We will accept the license terms. Click Finish right here. Click Next. Click Execute. Now we're ready to click Next again. go through a configuration process. Development machine is correct. Port number doesn't really matter. You can change it if you want to, or take it out if you don't want network access. Now these are very important. Make sure you remember what your root password is. If you want to add some extra user accounts, now you can, or you can do it later. Service name can be whatever you want it to be. The standard's fine. Standard system account is fine also. The most important thing here is to not forget that root account, although you can change it. Click Next again. Click Next, then click Finish, and we're set to go. Now I should mention that while it's loading the MySQL Workbench, which we're not going to be working with, that your installation is in the Program Files subdirectory, so be sure to go and look there after you're finished. I'll close my Downloads window out, and we are finished with the installation. The next lesson is on installing on a Mac, and if you're using Windows, you can skip that and move to the next lesson where we begin using MySQL with Java. In this lesson, we're going to see how to install MySQL on a Macintosh. So let's get started. Open your web browser. Then we're going to navigate to the MySQL web page. That's www.mysql.com. Once there, we're going to look for the Downloads tab. Click that. Then select Community Server. Then scroll down, looking for the 64-bit Mac OS X version. Click the Download button. We can skip registering, so scroll down to where it says No Thanks, just start my download. Click that. Now the download begins, so we'll wait this out for just a moment. Okay, we're just about finished. Wait while it verifies. First, close the Downloads box. Minimize this screen. And we're going to double-click or open the package. Now just follow the prompts for the installation. Hit Continue. Continue, agree, continue, and click Install. Enter your password for this account. Now we have some more waiting around while the package is installed. Just about finished. Click Close here. Now we're going to click the Pref pane to finish the setup. Click Install for all users, and then click Install. Enter your password. Click Start MySQL Server. Enter your password again. Now close this window. Close the Install window. Open a terminal window. CD to the following directory: user, local, MySQL, bin. List the files, type /MySQL, and this will verify that the program is running. And we have our MySQL prompt, and it's working fine. And with that, we have MySQL installed, and we're ready to begin using it on our system. In this lesson, I'm going to show you how to download the driver for connecting Java to MySQL. The driver is called connector/J. So let's just Google that. We'll find it right here under MySQL.com products connector. Our connector for MySQL is, like I said, connector/J. So we'll download. Then you need to pick your platform. We're going to work with the zip file, so we're going to download from the zip archive. We're going to open with WinZip. You can use another product if you need to. That's going to take us directly to the driver. Now, let me caution you that I have an account with MySQL and it automatically recognized me. You may have the extra step of having to either log in or set up an account. But at any rate, you should still come to this point. And then when you get here, next thing you're going to do is double click. And the file that we want to actually install, you can certainly extract all of these, but the one we really want is the jar file. That's where the driver is. So we're going to select that and we're going to click Extract. Following that, the next thing you're supposed to do is install it in a path. I'm going to show you that path in a minute, but first we need to look and see what the most recent version of JRE is that we're using on our machine. So I'm going to come back to my browser and I'm going to type in the URL javatester.org/version.html. And that's going to tell me what version I have. And my most recent version is 1.6.0_31. Now from that, I can go back to my extract and then navigate this file dialog box to get to that point. Now it's a little confusing, as you're going to see. Here's my Java subdirectory. Because if you'll notice, I don't have a 1.6.0_31 directory. So what I did was I went into several of them and installed it. I'm going to show you how to do it. Open up the JRE 1.6.0_ whatever your version is. Double click lib and then look for the directory ext and then extract to that. And it'll look just like that. At that point, you're finished and you have the driver installed and we're ready to write a little test program to see if it works. We'll call it testdriver.java. First thing we're going to write is import java.sql.star. We're going to put this into a try catch. Then write driver D is equal to we might have a problem with this long name, so let's drop this down to the next line. And this is going to create a new instance of the driver named D. And if that works, then we have a good connection. And we'll write connection works. Otherwise, we have an exception. And we'll just simply say connection failed. Although it's really not a connection, we'll just call it that anyway, because that's what we're ending up with, is a connection. In the next lesson, we're going to actually connect to a database. But without the driver working, we can have no connection, so this is fine. So save this program, then we'll compile it, then run it, and we have a connection works. If your connection didn't work, or if you get the message connection failed, then you didn't get the jar file into the right directory. So go back over the directions for that. There's lots of instructions on the internet on how to set up Java and MySQL, so you might want to look through some of that. But if you follow my instructions, it will work just fine. And with that, we're ready to move on to the next lesson where we're going to see how to actually take Java and connect it to a database in MySQL. In the last lesson, we saw how to test to see that our JDBC driver works. Now we're going to test to see that the driver can actually connect to the database. So we're going to start a new program. We're going to call it connect to db.java. First thing we do is import SQL classes that we need. First thing we have to do is create what's called a connection object. We'll call it CONN. And initially we will set it to null, but we need to put it where it is as null because we're going to put the rest of the statements inside a try catch. So we want to make sure the connection object is at a global enough scope that we can work with it in try catch and finally. So the first thing we do is we create a variable to store the username. I'll use my username into my MySQL system in Macmillan. I don't use a password, so we're going to set that to null. On your system, if you have a password, you should use it. You have to use it, actually. Now we create a URL that will represent our machine. So JDBC :MySQL, that's standard, / localhost. If you're connecting to the machine you're on, which I'm doing, then you'll put localhost, and then test is the name of the database. So if you're using a different database name, you'll change that right there, test. Next, we create an instance of the driver. Now we do our connection. And if it works, then we'll write out a short message. If we have a problem, then an exception will be thrown. So we'll just print out a message that we cannot connect to the database. And then we'll also have a finally block that if our connection is not equal to null, then we want to close the connection. This is something you should always get in a habit of doing. And then we'll write out a message saying that we've closed the connection. Otherwise, we're just going to write out a message that says that we can't close the connection, which is a big problem. And notice I capitalized the C there, so let me fix that real quick. So close the if, close the finally, close void main, and close the class. So we'll save our file, then we'll compile, and our database connection was successful, and then we also successfully closed. So this is how you connect initially to a MySQL database using Java. And now we're ready to move to the next lesson where we're going to look at how to create queries to retrieve data from a table. In this lesson, I'm going to show you how to do a simple SQL query using Java. Let's start out by demonstrating how it looks in the MySQL interface. So I've already loaded MySQL. So we're going to use the database that we want. And here's my SQL query. I have a table named Films. It has 3 fields, title, year, and director, and 2 films, 2 records in the table. So now that we've seen how to do it in MySQL, let's see how we do it in Java. I've already started a program called Simple Query. So you'll see that we have a connection object, CONN. We have all the other variables and objects that we used to connect to the database. Now we're going to add some new objects for executing a statement. The first of those is a statement object, and we'll use that to formulate our SQL. We also have a results set. The results set is where the data from the SQL query is stored. Once we have that result set, then we can iterate through it just like it's a collection of any data using next, and we can index into the result set to look at the individual rows of the table we're querying against. The next thing we're going to do is instantiate the statement object by calling createStatement. That method will instantiate the statement object. Once we've done that, then we can retrieve a result set by calling the executeQuery method from our statement object. So here's our query, select star from films. Once we have a result set, then we can iterate through it using a while loop and the next method. So what we're going to do now is we're going to retrieve the different fields from a row. So we do that by creating a variable and then calling a method, either getString or getInt, depending on the data type of the field. So for example, the title is a string, so we're going to call the getString method with the index of title to retrieve the data that's stored under the column for title. Next, we're going to retrieve the year, which is stored as an integer. So we call getInt and the name of our column or field, which is year. And then finally, the director. Then once we've retrieved the data, then we can display it. I decided to separate those out to make it a little bit easier to follow. So now we're just going to write out a little heading with the data. So you can see what I'm doing right there. Like so. close off the loop. And then finally, and this is very important, close the result set. We also should probably go ahead and close the connection also. We don't have a finally block in this program. So we'll go ahead and close the connection as well. So let's save the file. Go back to our command prompt. Compile the program. And then run it. And there are our two films. Annie Hall, 1977, Woody Allen. The Godfather, 1972, Francis Ford Coppola. So, of course, there's much more to queries than simple select statements. We didn't even try to narrow down the result set or the data that we're returning any, and we can certainly do that, and we'll look at examples of that later on in the chapter. But for this lesson, I just wanted to demonstrate the basics of returning data from a query, and this is how you do it. So now let's move on to our next topic in the next lesson, where we're going to talk about how to create a new database and table using Java. In this lesson, we're going to learn how to create a table. So we're working backwards a little bit since we already just learned how to query a table. We're going to go backwards and learn how to create a table. Rather than put you through the drudgery of watching me type in all of this setup code, I've went ahead and included what we'd written before for the simple query program, changed the name of this program to create table, and all we'd be left to do is add the statements that provide the SQL for creating a new table. So the first thing we do is we execute a statement that will drop the table if the table we're about to create already exists. So we're about to create a table named books. And so if this table already exists, we're going to drop it, which means delete it or remove it from the database. So you do that first before you actually try to create a table. Now the next step is to write the SQL to create the table. So let's get started on that. So the way we do that is we use a command called create table. And we're going to build this in pieces. So the first piece says to create a table named books, followed by an open parenthesis. Then we begin to list the fields. So our first field is going to be the ISBN number. It's going to be a character field of 10 characters in length, followed by the title of the book, also a character field of 50 characters, followed by the author, another field of 50 characters, and then finally the publisher, also a field of 50 characters. So that closes the SQL statement, and then that closes the execute update method, and then a semicolon. And that's all we have to do. That will be executed immediately. If there's a problem, then we'll go into our catch, and let's change that from the generic error to error creating table, a little more specific to the task we have at hand. And that should be all we have to do. So let's save the file. Let's clear screen. Compile it. One little error. Let's go back and take a look at that. Let's add this into our code. Statement equals connection create statement. Save it. Come back. Compile again. Works great. Execute the program. And our table is created. So going back and looking at the code very quickly, we drop the table if the table doesn't exist. Then we create the table by naming the new table, followed by a list of the fields, which would be the field name and its data type and the length. The length is always in parentheses after the data type. And that's all you have to do to create a new table in a database. So with that, let's move to the next lesson where we're going to see how to insert data into this table. In this lesson, we're going to learn how to insert data into a table. So in the last lesson, we created a books table. Now we're going to add some data into that table. The way we do that is by once again using execute update. So we'll start it right here. We'll move down to the next line. And we type in the SQL. So it's simply insert into books. Then we provide a list of the fields. So we have ISBN, title, author, publisher. So we'll stop there, concatenate, and then we'll say values. And because this is going to be a long line, I'm going to stop it right there and move down to the next line. And my first set of values will be an ISBN. And notice I'm using single quotes to delimit these values. Then the title of the book, followed by the author. Author is running a little bit close, so we're going to move down to the next line and put that right here. And then the publisher is Oracle Press. And that's the end of that particular row. So we want to do another row, so we're going to put a comma right here, and we'll keep on concatenating, and we just start another row. So we start with an ISBN number, followed by the title, followed by the author, followed by the publisher. We better put the publisher on the next line. So we'll put a close quote and a plus, open quote, and then close the parenthesis, close the quote, and then close the method. And that's all we have to do. We'll write a little message saying record added if we make it to the end. For our catch, we'll say error inserting record. And that should be all we have to do. So let's save the program. Let's clear our screen. Compile it. And then run it. Record added. So looking at the code one more time, really there's not much Java involved in this. Once you've learned how to work, execute, update, then you know all the Java you have to know. Mostly this is just understanding how to get the SQL correctly into the execute update method. And that's just a matter of knowing SQL and being able to translate that into a string that you put into Java. So with that, let's move to the next lesson where we're going to talk about updating data that's already in a table. In this lesson, we're going to learn how to update a record in a table. And this time we're going to prompt the user to enter the data that they want to update, including the field as well as the data itself. So this will be a little more complex than the previous programs where we hard-coded all the SQL. Here we're going to have to build a string and then pass that string to the execute update method. So let's get started. I've got the beginnings of our program, update data, on the screen. Notice I've imported java.io because we're going to use buffered reader to get input from the keyboard. So that's where we're going to start. I've already added the declaration for buffered reader. Now let's instantiate the object. So now we're ready to prompt the user to enter some data. So the first thing we're going to tell them to do is to enter the record they want to update by entering an ISBN number. Next, we're going to prompt the user to enter the field they want to update. And finally, we ask them what data they want to enter to replace the current data. Now, once we get this information, we're ready to build the string that's going to contain the SQL plus our data. So we're going to call this an update string. And we'll start on the next line. So then we concatenate the field we want to use. And we insert the data that we want to put into that record. And actually right here, we need another single quote mark. It's very hard to pick up, but the data itself has to be in single quotes. And we have to use single quotes because we're using double quotes for our string concatenation. Then once we get that, we can finish up with where ISBN equals an ISBN. So that's our string. And the last step is to call the execute update method with our update string, and we're set to go. So we close out by displaying record updated if the record is updated. If it doesn't work, then we catch the exception and print out error updating record. So let's save the file, and then let's compile, and then let's run it. The record we want to update is ISBN number 0321-35668. The field we want to update is title, and the data we want is effective Java 2nd edition. So we hit enter, and it comes back and tells us that the record was updated. So let's put the code back up on the screen. And so modifying a program to include user input is not that much different than hard coding the input, other than you have to be very careful about getting the concatenation correct. And a lot of times that'll take 2 or 3 tries. You may even want to display the value of update string before you pass it to the execute update method to make sure that it's working correctly. So that wraps up this lesson on updating data, and that wraps up the lessons in this chapter on database programming in Java. I haven't covered every possible SQL statement. Certainly haven't done any joins or anything like that, any more complex SQL. But what I wanted to do is give you a feel for how SQL is handled in Java, and I think you've gotten that. And anything else that you might want to do, you should have a good foundation in writing SQL in Java to continue on to do more complex things. So with that, I'm ready to move on to the exercise where we're going to work further with SQL programming in Java. For this exercise, we're going to look at a way to update a database using something called prepared statements. And doing this will make the coding a little bit easier than the way we did it before, where we had to concatenate together a fairly convoluted string. So I've started this program. I took update data and simply copied it. We'll change the name to prepared.java, so be sure to save the file like that. To create a prepared statement, we first create a prepared statement object. So we'll do that first. Next, we're going to create our prepared statement string. And you'll notice that we have question marks in the places where data goes, the data that we prompt the user for. In this case, we're only prompting for 2 pieces of data, the ISBN and the new title, just to make things a little simpler. So notice how much easier this is already than what we did in the last lesson. Now, once we've created our prepared statement string, we can then instantiate our prepared statement by calling prepare statement on our connection with the string. Now, the next step is to prepare the data to be put in place of the placeholders. So we do that using a method called setString, where we provide the position of the placeholder, and they're numbered consecutively starting at 1, along with the data. So the first placeholder holds the title. That's going to be our data value. And then the second placeholder holds our ISBN number, and that's going to also use setString. The next step is to simply call execute update, and our record is updated. So notice how much cleaner this looks than the code I wrote in the lesson before. So you should consider using prepared statements rather than doing it the way I did it in the last lesson. Now let's save this program, clear our screen, compile it, and then run it. So we'll update a different record this time. We'll update the first record in our database, and we're going to call this 8th edition. And our record is updated. So going back and looking at the code, let's talk about this again. A prepared statement allows us to use placeholders rather than have to try to concatenate data together to build our SQL. So we write out a prepared statement as a string, call the prepare statement of our connection object with that string to actually build our prepared statement. Then we use one of the set methods, and I say one of the set methods because if we were doing numeric data, for example, there's a set int for that. Since all the fields I'm working with here are strings or chars, we use set string. So you call that on your prepared statement object, and then once you've set all the data values, then you call execute update on the prepared statement object to update the table. So that wraps up this exercise, and that wraps up this chapter on SQL programming using Java. In this chapter, we're going to talk about network programming in Java. Primarily, we're going to talk about how to work with TCP/IP and how to work with HTTP, two common protocols that are part of network programming. Normally, you'd start out with TCP/IP, but we're going to start out with using the HTTP protocol to work with URLs. So let's get started. We're going to call this program urlprog.java. To do network programming, we need to use the net set of classes, so we need to import java.net.star. We're also going to be doing some I/O, so we're going to need the I/O libraries or classes also. So the first thing we need to know is that most of the time with network programming, methods have to be able to throw exceptions. So in this example, main is going to throw an exception if we have problems making connections. What we're going to do in this program is connect to a website and get some basic information about the website and display all the content in the website in character form. So to get started, the first thing we have to do is we have to create a URL, Uniform Resource Locator object. And it's very easy to do. We simply provide the URL to a website. And that's the full URL, including the http:// just as you see right there. And this will work for any website at all. So you can replace infiniteskills.com with whatever website you want to look for. The first thing we're going to do is display some just basic information. And really just three things. Let's print a blank line here. Now we're ready to start. First thing we want to see is the protocol, which we know, but we want to see how to return it. We get it using a method called getProtocol, which we call off of our URL object. Next, we want to see what port we connected to. So we'll call the getPort method. And then finally, we want to see what the host is for this site. So we're going to call the getHost method. So let's go ahead and compile and run this program. So our protocol is HTTP, port is -1, and our host is www.infiniteskills.com. Next, we want to display the content of the website. In other words, the raw HTML. To do that, we have to create another object, and that's called a URL connection object. So the call is URL connection, then the name of our connection object. To do that, we call the open connection method of our URL object. So once we've opened our connection, next thing we want to do is check to see if there's content. And we do that by checking the length of the content that we returned when we open the connection. So that's what we're doing right here. We're saying int content len is equal to the con.getContentLength. And we're going to need an int variable to store the characters as we read them. So I'll declare that now. Then we write if content length is not equal to 0, then we're ready to display the content. So we'll put a little header, then a blank line. Then we create an input stream object from which we're going to read the characters as they come across our connection. And we have a little while loop that runs while there's more content to read. Then we read a character, convert it to a char, to a character, data type, until we're out of data to read. And we close our input object, close off the if statement, Otherwise, we'll write a nice little message. Sorry, no content. And we're done. Let's save our program. Go to the screen, compile, and then run. And as you can see, we have a whole lot of HTML to go through. Now, this information by itself, while not worthless, isn't worth much. We'd probably want to save it to a file and then search it for specific content, and we're going to learn how to do that in the exercise for this chapter. But in this lesson, I just wanted to demonstrate how to make a connection to a website and retrieve the content. And as you can see, very simple to do. So with that, we're ready to move on to the next lesson where we're going to look at how to communicate via TCP/IP. In this lesson, we're going to introduce the idea of TCP/IP sockets by providing you with a very simple client program that connects to a Whois server. Whois allows you to see some internet domain registration information about a specific domain. But first of all, let's talk a little bit about a socket. A socket is a way to make a connection with a server. Typically, when you're communicating via sockets, you have a server socket and a client socket. And in fact, you have to have both to have two-way communication. In this lesson, we're going to see, just in general, how to create what is really a client socket that allows us to connect to a Whois server. In the next lesson, we'll talk about creating a server socket, and then in the lesson after that, I'll demonstrate how to create a client socket, and then we'll connect our client socket to the server socket. But let's get started now on our sample client socket and a Whois client. So we're going to call this program Whois. First, we'll do our importing. Create our class. And then work into main here. For now, we'll just have a generic exception. We're not going to try to use try-catch here in this example, but in our next two lessons, we will be using try-catch. So the first thing we're going to do is create a socket. And we do that with the socket class. And then we're going to provide the name of our server, which is whois.internic.net. And the port that we're going to connect to, the Whois port, is 43, so that's the second parameter that we provide. Next, we're going to create input stream objects, which are created using the get input stream method, and an output stream object, which is created with the get output stream method, just like so. Next, we're going to create a string variable that stores the domain we're going to try to search for, infiniteskills.com, and we also need a new line character at the end of that to make sure that the command is executed correctly. And that's important to include that \n. Next, we have to convert our string into bytes. Bytes will be how we transmit the string. So the string class has a getBytes method that will take a string and turn it into bytes, and then we put it into a byte array, which we're calling buffer, kind of a standard name for that. Now we're ready to send the command. So we write output write buffer, and that sends our command through the socket. At that point, we're ready to get the input that comes back. So we have a while loop that grabs the characters as they're coming in to the socket, and then we're going to write them out to the console, converting each one to char as we go. And the last thing we need to do is close our socket. And there we go. So we'll save this, go to our command window, compile it, now run it. And there's our registration information about infiniteskills.com. So we go back through the program. We create a socket. We create an input stream to receive data. We create an output stream to send data. We organize the data to send, and we send it. And then in the while loop, we receive the data as characters, as bytes. And then we convert those bytes into stars so that we can read the output. And the output is our domain registration information. So that's a simple introduction to socket client programming. Now let's move on to the next lesson where we're going to look at a little more complex example where we're going to create our own socket server. In this lesson and the next lesson, we're going to develop an Echo server and an Echo client to demonstrate network programming using TCP/IP in Java. The Echo server will accept incoming messages, and the Echo client will allow us to send messages to the Echo server. So let's get started developing the server. We're going to call our program echoserver.java, interestingly enough. So we begin by doing our imports first, as always. So we import java.net.star and java.io.star. Our main program has to throw an I/O exception. First thing we do is set up a server socket, which we're going to call server sock. We put it in the global area because we're going to use it in 2 tries. Here's the first try. The first thing we do is we try to instantiate it by setting up a server socket on port 10,007, which is just a nice random port to use. And of course, our client will also be sending messages to that port. Then we have a catch. So if we can't make a connection, then we'll print out a message that says we can't do it. And then we'll exit the program since there's nothing else to do. Otherwise, we set up a client socket. First, we declare it and instantiate it to null. Then print out a message that says we're listening for a connection. In other words, we're waiting for a client to connect to our server. The code that does that is the accept method of our server socket object. And that will be the return value that's assigned to the client socket. And again, we put that in a try catch so that if we are not able to connect successfully, we'll write a message that says accept failed and exit out of the program. Otherwise, we'll write a message that says connection successful. Then we'll write out another message saying we're listening for input. In other words, we're waiting for the client program to send us some output. If we get that output, we're going to have an output object to accept it. Come down over here and write the rest of our parameters. And we also need to create a buffered reader object. We're going to have to come down to the next line to finish that. I'm going to indent right off here. And that should do it. Then we need a variable to store our input. We'll need 2 parentheses right here, so let me fix that. We'll print a little heading to say what's coming in from the server. And display our input line. And we're going to check to see if we want to terminate the program. And so we're going to break out of the while loop. And then finally close all of our connections. Close the while loop. Close main, then close the class. So let's save our program. Can't really run it because there's nothing to connect to it. but we can at least compile it. Compiles just fine. We can run it, but nothing will happen because we don't have a client trying to access it. So we'll just Control-C to break right here. And we'll move to the next lesson where we're going to write the Echo client that we can then connect to this server. In this lesson, we're going to create an Echo client to work with the Echo server we created in the last lesson. And then we're going to test them out by running the client and the server and see if they communicate with each other. So let's get started. We'll call this program Echo Client.java. And of course, we'll do our imports first. Main has to throw an IO exception. The first thing we're going to do is create some objects. Our socket object, we're going to call it sock. A print writer object, which we're going to call output. And then a buffered reader object, which we'll call input. So the first thing our client has to do is create a socket that uses the local machine as the connection. That's 127.0.0.1. And of course, the port that the server is looking for is 10,007. And I should mention that 127.0.0.1 is indeed the IP address of the server, which is the local machine in this particular case. Our output object gets an output stream from the socket. Our input object also gets an input stream from the socket. It's a bit of a complex statement, so it's taking me a little bit of concentration to get it right. And that looks kind of funky, but I want to make sure I get it all on the screen correctly. So that's how it's going to be. If it doesn't compile right, we'll fix it in a moment. That's all we need in our try. So now we're ready to do our catches. Our first catch catches an unknown host exception. If the local machine is not working for some reason, we'll get this exception. And then we'll just create a second catch for any other exceptions. The only other exception that we would probably get would be that we can't connect for some reason. Next, we need an input object to read from standard input so that the client can type something in. So there's our input object. Then we need a string variable to get user input, which we get right here. Then we display the user input, and then we return the echo from the echo server right here. And that's all this client does. So now we're ready to close everything. And that should be all we need to do. So unless we've made a typo somewhere, which is quite possible given all these complex method calls, everything should be ready to go. So let's compile it. Fortunately, everything worked. Now, what I'm going to do is I'm going to start the server here. So there's this starting the Echo server. Now I'm going to open another command prompt window. Let's bring it down a little bit. And here we'll run this client. So notice that when we ran the client, we got a connection successful message at the server. Now the server is listening for input. So let's type a message to the server. The server received it and echoed it back. Let's try another one. Received and echoed. So here again is the code for the Echo client. And now we've seen how to use TCP/IP to connect to computers to send messages back and forth, although it's not really like a chat client. We're really not sending back and forth in the sense that the server is only echoing back what the client received. With just a little bit of extra work, you could easily build a chat system so that the client could send its own messages and the server could also send its own messages. So that finishes up this lesson, and we're ready to move to the exercise for this chapter on Java network programming. In this exercise, we're going to create a simple chat program that includes both a server and a client. And the server can chat with the client, and the client can chat with the server. So it's a little bit different than our Echo server, which was really only one-way communication, in that the client could send messages to the server, and the server would echo those back to the client. Now we can send messages both ways. You'll notice I've got split DOS screens here. That's because one will be for the client or the server, and the other one will be for the client or the server. First, let me show you the two programs. I'm not going to type them in from scratch. They're too long, and it'll take long enough just to explain how they work. So let's look at the chat server first, and we'll go through it line by line. Of course, we have our two imports for net.star and io.star. First thing we do is we set up a server socket and tell the program what port to listen on. Next, we create a regular socket which accepts incoming messages, and that's where we'll be listening for. Then we create an input object to receive input into the socket. Then we create an output object so that we can send output. And then we have a buffered reader object so that we can type in messages from the server using system.in for them to go out. We create a string variable here. Now we have a while loop that runs continuously. So the first thing we do is we wait for input from the client. If that input equals the word by, lowercase b, then we break, and that stops the program and sends us automatically to close out all of our objects. And I'm not going to go over that again. Otherwise, we write out what the client sent us, because the client will send out first. That's this line right here. Then we write a prompt saying now the server's turn. The server can now send a message. So we get the line, and then we send it to the output. And that's all there is to it. Now let's take a look at the client program. Of course, the client program imports net.star and io.star. Then we create a new socket. We provide the IP address for the server, which is our local address, and the port. We create an input object to read our input. We create an output object to be able to send output. We create another input object to be able to receive input from the keyboard, our client input. We have a variable to hold the data typed in or received. And then we have another while loop that runs while true, so it runs continuously. We prompt the user to enter some data by putting a prompt client. We receive that input from the keyboard. We write it to the server. We wait for input coming back. Then we prompt that the server has sent some input. And if that line equals by, then we break. And then, of course, if we break, then we close out all of our objects. All right, so let's take a quick look at our programs. Let's get both of our windows up. So we start the server from 1. We'll do it from here. So now the server started. I did not put a message here this time. So the client's waiting for input. So we'll say hello server to the server. The client sent hello server. So we'll say hello client. Received by the client. Client says, what's up? The server says, not much. Client says, okay, not much for witty dialogue here. And then finally, we want to end this by typing by. And that stops everything. So that's an example of a simple chat program with both a server and a client. Lots of modifications you can make to that. You can have the server receive multiple connections so that multiple clients can connect. That would probably be the biggest change, so that multiple people can talk to each other. We could create a graphical user interface to make the program look prettier. But in this exercise, we've demonstrated very simple TCP/IP or socket communications, and that's what I wanted to achieve. So that wraps up this exercise, and that wraps up this chapter on network programming. In this chapter, we're going to be learning how to develop a graphical user interface using the Swing toolkit that's part of the Java Foundation classes. Swing is a collection of classes that allow you to build graphical user interfaces with things like labels and text boxes and checkboxes and sliders and combo boxes. All of the different widgets or controls that you're used to seeing in a graphical user interface. We can't cover all of these classes in this chapter, but we're going to cover the most fundamental of those. But we're going to start with a very simple example where we display Hello World in a label, just to get you comfortable with Swing programming, if you will. So let's get started. We're going to call this program swingexample.java. And the first thing we have to do is import the Swing library. So notice we write import javax.swing.star, and that will give us all of the classes. Rather than provide you with an introduction to the classes at the beginning, I'll introduce the classes as we go. We're going to look really at just two in this example, frame and label, but they're two important ones. The first thing we're going to do is start our class, swingExample. And we're actually going to create a constructor for this class, which looks a little odd. We haven't done that before, but that's another way to begin a program. So the first thing we want to do is create a frame. A frame is the window that our graphical user interface is going to be displayed in. So that object comes from the JFrame class. So we write JFrame, and then we name our frame. We're just going to call it frame. Then we call the constructor, and here we're going to put a title that will go in the title bar of the window. So Hello World application will go in the title bar. The next thing we want to do is set the size for our frame, and we'll just pick a size arbitrarily, 400 by 200. For this example, it doesn't matter that much. The next thing we have to do is we have to tell it how we want the frame to close. So that's a method called setDefaultClose And here we're going to pass a constant JFrame exit on, just like so. So that says when we press the close button to exit the program completely. The next step is to create a label. We use the JLabel class to do that. And in that label, all we're going to display is the text Hello World for a typical Hello World first program. So that's how you create a label and put some text into the label. The next step is to add the label to the frame. That's how we put widgets onto our graphical user interfaces, by adding them to the frame. So we take the label and add it to the frame. We want to be able to make the frame visible, so we call the setVisible method with true as the argument to display the class. And that's all we need for our constructor. Now we're ready to write the main program. Now this gets a little bit complex. And to explain it, I have to go into some detail that you're probably not going to understand, or you may not understand. And you're probably going to want to do some background reading. But when you're developing graphical user interfaces in Java need to run in a separate thread. And all that means is that if you understand anything about multi-threaded programming, is that you can have different parts of a program running in different threads. That allows you to have concurrent programs. There's a lot of detail in multi-threaded programming that I can't talk about in this chapter. We have a chapter on multi-threaded programming in this course, so if you haven't looked at that chapter yet, go look at it now to understand more about multi-threaded programming. But we are going to run our user interface in its own thread. So to do that, we have to call a method called InvokeLater, along with the constructor to a new runnable object. And to do that, we write public void run. Then we call the constructor for swingExample, and that will have it running in a separate thread. So we close off the run definition. Then we close off the InvokeLater method. This curly brace closes off the new runnable method. This parenthesis closes our argument list for invoke later. And then we can close off the call with a semicolon. And then we're finished with main and finished with class. So at that point, we're ready to save and then compile. We'll come back, compile the program, and then run it. And here's our Hello World program with Hello World displayed in a single label. Just for fun, let's change the size. That's about the only thing we can affect right here. Let's go 350, 150. Save. Compile it again. And then run it. And you notice we have a smaller frame and a smaller application. So that wraps up this introduction to swing programming, and we haven't done very much. But like I was saying before, there's a lot of material to cover, and we need to start out simply. So a Hello World program is always the most simple way to start. And so that's how we started. Now we're ready to move to the next lesson where we're going to look in a little more detail at the different widgets that we can add to a graphical user interface. In this lesson, we're going to look at how to add text fields to a graphical user interface. So let's get started. We're going to call this program textfields.java. First of all, we'll import the swing libraries. Then we have to have two other import statements. One to import the abstract window toolkit, that's awt.star. And then to do event handling, because we need to start learning how to do that, we also need java.awt.event.star. I'll explain about event handling and why we also needed awt.star in just a minute. So we begin our program. And the first thing we're going to do is go ahead and declare the two widgets we're going to have in our interface, a label and a text field. So we're going to declare those first. Then we're ready to call our constructor. Let me line my code up here. I went over one space too many. So for our constructor, the first thing we're going to do is instantiate our label. And I should mention what we're going to do is we're going to have a text field and a label, and we're going to type data into the text field and hit enter and put that text into the label. Nothing fancy or even all that practical. It's just a good way to test our text field and to start thinking about event handling. Text fields are instantiated with the JTextField class. There are several different ways you can call the constructor. I'm going to call it this time with a number, an integer that represents the number of characters wide the text field is going to be. After we've run our program, I'm going to come back and change that to where we instead instantiate the text field with some text already in the field. But we'll start out with just specifying a size for the field. Next, we have to create our JFrame object. You've seen how to do that already. Now here's a new command or a new method that we're going to call setLayout. Because we have multiple widgets, we need to provide a window management system, a way to put these widgets in our frame or the window. So we're going to use something called a flow layout. You'll see how that works in just a minute. Now we're going to set the size for the frame, and we'll set it at 500/250. We also need to just set our default close operation. We'll have it the same as before, which is a exit on close. Now the next thing we need to do is we need to wire our interface to handle events. And to do that, we have to do something called adding an action listener. So we do that to the text field. And what we're saying is we're saying that we want the text field to be able to respond to events that occur when the user is working with that text field. In this particular case, it's going to be when the user hits the enter key after they've typed text into the text field. And here's how we do it. It's a little complex, so let me type in without speaking too much yet. I'll come back and discuss what I'm doing here as soon as I finish. I'm almost through here. There we go. So here we say add action listener. And to do that, we call the constructor for action listener. And we tell it that when an action is performed, capture that action and take the text out of the text field, that's where getText does, and put it in the label using the label's setText method. So all we're saying in all this code is that after the user types some text into a text field and they hit the enter key, take that text and put it in the label. So after that, we're ready to add the label to the frame. We're ready to add the text field to the frame. And we can change that order in just a moment. Then we want to make the frame visible. Now we're ready for our main program. And this looks like the previous example in the last lesson. So we call the constructor for our text fields class, close the run method, close the invoke later method, and then close the argument, and then a semicolon, close and close. So let's test it out and see how it does. Save the file, come back to our command prompt, compile the program, and then run. I type some text and hit enter, and it puts the text in the label. Notice the label is to the left of the text box because of the way flow layout works. Let's go back to our code. Let's change the order. We'll put the text field first. Let's close up our code just to keep it all looking neat. Save, compile, and then run. Now when we type some text, it comes in on the other side. Flow layout works by simply flowing widgets onto the frame in the order that you tell them to be added. So by changing the order from the label coming first to the label coming second, we change the positioning of these two widgets. And the last thing I want to show you before we leave text fields is in this constructor, we'll change it from 20 to type text here being what will display in the text field when we run the program. Let's go to the screen, compile again, and then run. So we'll have to clear that out and see what you get. Notice that the field is the size of the text entered. So our text field box is only wide enough to display type text here, which is what we passed into the constructor. So that wraps up this lesson on text fields, and we're ready to move on to the next lesson where we're going to discuss how to work with buttons. In this lesson, we're going to learn how to add a button to a Swing program. So the first thing we're going to do is we're going to take the old program that we wrote in our last lesson, textfields.java. We're going to make a copy of it, copy it, and we're going to start a new program called buttons.java. Then we're going to paste the old program in, and then we're going to go back and make a couple of changes right off the bat. And you could do this with find and replace. I'm just going to do it manually because there's only a few places that it needs to change. Okay. So what we want to do is we want to add a button to the form. So the first thing we're going to do is declare a button. And that's using the JButton class, as you see right there. Next thing we want to do is instantiate the button. So after we instantiate the text field, we're going to type button is equal to new, JButton, and we're going to put a caption on the button that says put text in the label so that when the user clicks the button, the text goes from the text box to the label. The next thing we want to do is add an action listener for our button. So what we're going to do is we're going to copy this action listener. We'll add it in right here where the space is. And then we're going to change it appropriately. So we're going to change text field to button, and that's really all we have to change. So now when the button is clicked, we're going to get the text from the text field and put it in the label. Simple enough. We also want to change the size of our frame for this particular lesson, so we're going to change it to 200/150. Next thing we want to do, and actually the last thing we have to do, is add the button to the frame. We're going to put it between the text field and the label. So let's go back over the code that we added to our application. First of all, we declared a button, then we instantiated the button, then we wrote out the action listener code, the event handling code for the button, and then finally we added the button to the frame. Everything else stays as is because we already changed our call to the constructor right here. So everything's in place to run, so let's save the file. Go back to our command prompt, compile the program, then run it. Let me put the code in place where you can see it. So here's where we type our text. Here's where we click the button, and there's the text. I made it smaller than it needs to be so that everything stayed on one row. You see if I spread it out a little bit. Then we have the text field, the button, and the label all on the same line, which looks kind of funny. And I made a fairly small text field to boot. But notice how it works. And see how the flow layout works is that if our label field is too wide to fit on the line, it just drops it down below the other two widgets. Flow layout is not a perfect layout manager. It works great when we're just introducing these concepts, but later on I'll demonstrate how to use a different layout manager than flow layout. But for now it's working fine, so that's how you add a button to a GUI application. And with that, we're ready to move on to the next lesson where we're going to talk about list boxes. In this lesson, we're going to see how to work with lists and be able to select items out of a list or select an item out of a list. We'll start with a simple single selection. So let's get started. We're going to call this program lists.java. The first thing we're going to do is import the classes that we need. And we also need a fourth set of classes, and these are in Java x.swing.event.star to work with a list. The first thing we're going to do is declare a label. We're going to use that to display our selection. Then our list, which is the JList class. So we do JList list. Then we're going to get our list data out of an array. Here we're going to pick some New York City sites that tourists like to go see. So we're going to declare our array NYC sites, and we'll populate that array in just a moment. Our constructor will start out by instantiating our objects. So we have a label, followed by our array of New York City sites. So bear with me while I type a few things in here. Just two more here. And that's good enough. So we'll stop right there. Now we'll instantiate our list, and we do that by passing the array into the constructor, like so. And that will tell Java what items are going to be in the list. The next thing we need to do is we need to set a selection mode. And we do that by picking a value called single selection out of the list selection model class. So this says that when we click on a mouse, we're going to pick one item out of the list, and that will be the item selected. You'll see how that works in just a minute. The next thing we need to do is add our list selection listener. And that's a handful to type right there. And we do that by defining a void method value change. And it looks for a list selection event, which means clicking on an item. And we define a variable index. which will get the selected index value of the list item. So the first item is index 0, and the second item is 1, and so on and so forth. When we pick an item, if that value is not equal to -1, then we're going to set the value of a label to the string site to visit plus the value found in the array at that index position. That's how we pull the value out. The list doesn't actually contain the items in that sense. They're still in the array, and so we pull it out from there, from the array. Now everything else is just housekeeping. And we set the size, set the default close operation, add the list to the frame, add the label to the frame, and then make it all visible. Finally, we write our main program. And call the constructor for our lists class. And then we're finished. Okay, so let's save the file. Cross our fingers that we don't have any typos. And we don't, so let's run the program. Let me bring it into view. Here's our list of 6 items. If we select one, it shows up in the label. We can go through and select them in order or out of order. However we select them, once we click the mouse button, then it picks that item out of the array, not actually out of the list, and displays it in the label. So that's how lists work. Now, one thing we might want to add to a list is a scroll panel so that we can have a long list and have it not take up all of the frame with the list. And that's certainly something you need for any large number of items in a list. And we're going to see how to do that in the next lesson. So once again, very quickly, adding a list to a Swing application is essentially the same as what we've done for all the other widgets. The only difference is that we have to have a data source, the array, to store the list items. Then we instantiate the list item, set any properties like its selection mode, and then add a listener of some type to check for the event that we're looking for, in this case, the clicking on an item in the list, add it to the frame, and then we're set to go. So with that, we're ready to move on to the next lesson where we're going to see how to add a scroll panel to our list. In this lesson, we're going to see how to add a scroll pane to a list to make the list scrollable. And that will save some room when we want to have a long list of items. The first thing I want to do is start a new program by copying our old program to spanes.java. So then once we've done that, we're ready to open spanes.java. So the first thing we want to do is add our scroll pane to our program. So we're going to call it spane. So the first thing we do is have a declaration. After that, we're ready to instantiate it. So what we're going to do is we're going to instantiate it down here underneath our list. So we're going to say spane equals new j scroll pane, and then the argument to the constructor is the name of the list, in this case, list. So that instantiates the scroll pane. The next thing we need to do is set the size. There's a method called setPreferredSize. To do that, we call a constructor dimension with the dimensions we want for our scroll pane, and we'll just pick 120/90. After we've done that, we're ready to add the scroll pane to our frame. Now, because the list is now in the scroll pane, we don't have to add the list anymore. So we're going to comment that out, and we'll replace that line with the line frame add spane to get our scroll pane in place. And that's actually our list. So you can think of it as adding the list to the frame Even though we say we're adding the scroll pane to the frame, we're actually adding the list because the list now includes the scroll pane. That's a little confusing. Now, the other thing we need to do is we need to come up here and change all of our names from list to spane. So we do it here. We do it in the definition of the constructor. This is always the problem with cutting and pasting. And then where we actually execute the constructor, we've got to change it there also. Make sure we got all those. And we called it plural, so let's make sure we get that right. There we go. And to recap, we declare our scroll pane. We instantiate the scroll pane, which is this line right here. We set its size, which is the line below it. We add it, the scroll pane, to the frame, which includes the list, and then we should be ready to go. So let's save the file. Come back to our command prompt window. Compile. Run it. Let me bring it into view. See how we can scroll it up and down. We can pick. Let's scroll down and pick. Let's scroll back up and pick. We can scroll across and we can scroll up and down. So that's our scroll pane. So that's how you add a scroll pane to a list and add it to your Swing application. And with that, we're ready to move on to the exercise for this chapter where we're going to put all these different widgets into one application. And we're also going to look at a new layout for these widgets called grid layout. For this exercise, we're going to build a simple graphical user interface to perform temperature conversions from Celsius to Fahrenheit. We're going to use a grid layout instead of the flow layout to demonstrate how you can line up widgets to some extent. It's not perfect, and it still leaves you a somewhat clunky interface, but it is better than the flow layout manager. So let's start the program. We're going to call it tempconverter.java. First thing we need to do is import the different classes, so be patient with me while I do that. Now we're ready to start the program. First thing we need to do is declare the different objects, variables, and things we're going to use. So we're going to have two labels. I'll explain what they are for in a moment. We'll have one text field, one button, one string array to store the two possible temperature scales, Fahrenheit or Celsius, a list box to display the two temperature scales, and a variable temp index which will be used to get the selection out of the list. Next, we're going to have a function, convert, that takes a temperature and a scale and performs the specified conversion. So we check to see what scale equals, and then we perform the conversion that is called for. So here we're converting Fahrenheit to Celsius. Otherwise, we convert Celsius to Fahrenheit. Now we're ready to write the constructor for our class. So here we instantiate all of our objects. This is a label that will go by the text field to enter the temperature. Out label will be used to store the converted temperature, so it's going to be empty to start with. Our text field only needs 5 places to be able to store a temperature, which is probably not going to be more than 3 places long. We'll have a button. The user clicks to begin the conversion. Temps is our array for storing the two possible temperature scales, Celsius or Fahrenheit. And then we have our list, which is made up of the two temps. Next, we instantiate our frame. Here we're going to set the layout. to a grid layout. And the argument for the grid layout is going to be the number of rows and columns. Now there are other arguments, but we're only going to go with the row column argument. Next we're going to set the size. And we set our default close operation as usual. Skip a space because the next thing we're going to do is create our listeners. First we'll do our list listener or list selection listener. And for value changed, we're simply going to get the selected index and store it in our temp index variable. So that action is fairly simple. Next we have our action listener for our button. And for the action performed method, we're going to create a variable temp that will consist of the value entered into the text field. So notice that we have to get the value from text field, convert it to integer using parseInt, and then store it in the variable. So that's a little bit different than what you're used to. And we have to get the proper scale from the temps array, so that's our next step. And then the rest of the action in the program is right here where we set the text of the label by calling the convert function with temp and scale, just like so. So we close the definition for action performed, and then close out the add action listener. Now all we have to do is add our widgets to the frame, paying attention to the order that they're added. You'll see why in a moment. Now we make the frame visible. And there we go. Last step. And call the constructor for the class. Close the run method. Close invoke later. Close main, and then close the class. There we go. So let's save. Cross our fingers we typed everything in correctly. Got it. So let's run the program. Let me put the interface in the screen. So like I said, it's not a perfect interface. Our label is very boxy, but here's what we have. We have our temperature label. Here's our text field. This is our list, and here's our button. This is our out label to display the result. So if I type in 32 Fahrenheit and click Celsius and convert, I'll get 0.0. If I turn around and write 100, go to Fahrenheit and click convert, I'll get 212. So if I type 0 and stay at Fahrenheit, it'll give me 32. So those are the conversions that I'm familiar with, going from freezing point to boiling and boiling back to freezing. So this is not an ideal interface. You certainly would not want to publish this as any type of program for the public, but it gives you an idea of what you can do. Using a modern integrated development environment such as Eclipse, which we'll cover later, you can create a much more professional looking GUI than what we've done here. But what I wanted to show you was a different method for creating the graphical user interface using the grid layout instead of the flow layout manager. So hopefully you've gained something from this exercise. You've certainly seen some of the things you have to deal with, such as converting data from one type to another to get it into a text box or to get it out of a text box. And those are the kinds of things you have to work with when you're working with a graphical user interface in a quote-unquote real-world program. But with that, we're going to wrap up this exercise, and that wraps up this chapter on graphical user interface programming using Swing. In this chapter, we're going to study the process of creating concurrent or multi-threaded programs in Java. Concurrency is a very complex topic, and we're only going to be able to lightly touch on how to do multi-threaded programming in Java. But we are going to at least give you the opportunity to see some examples of creating programs with multiple threads. For those of you who aren't familiar with the concept of multiple threading, I have provided a diagram from the wiki page for thread. And the way a thread works is, first of all, you can think of the programs you've written in Java so far as all have been computed in the main thread. So whether you knew it or not, your programs have been running in a thread. It is possible to create a program with multiple threads. And so what happens is, when you create multiple threads, you can have one computation occurring in one thread, while a separate computation is occurring in a separate thread. There are lots of examples of programs that would benefit from this, such as chat programs where the chat server establishes communication with a chat client in its own thread, or a graphical user interface program that captures user input into the GUI in one thread and does some sort of numeric or computational process in another thread. And there's many, many more examples. In simulation, for example, you might have each object that's part of the simulation doing its processing in its own thread. At any rate, in this lesson, we're going to look at just a simple example of how to create a program with multiple threads. So let's go ahead and look at that program now. We're going to just look at a program already written and then run it rather than enter it from scratch. It's a little complex for that. And I should mention that some of the example for this program comes from one of the books I've learned Java programming from. It's titled Java Programming Advanced Topics, written by Wigglesworth and Macmillan. That Macmillan is no relation to me, by the way. So this program is a program called TwoThreads. Notice we've imported java.io.star. What we do is, in the main part of the program, we create a thread. So we have a data type called thread, and that thread is assigned the result of calling the constructor for a class we call user interaction, and you'll see it down below. Then once we've set up the thread, then we call the start method to start the thread. Then we create a second thread called second thread, and we assign it the constructor of another class called compute log. So then we start that thread. After we've started that thread, then we call the join method of the first thread. The join method waits for the thread process to terminate. And then once that thread process is terminated, then we'll go to the second thread, and then we call end to it. And we actually have to cast our thread back to compute log because the end method is part of the compute log class, not part of the thread class. So now let's take a look at our two classes. They're fairly simple to understand. User interaction simply prompts the user to answer a couple of questions. Hello, how are you? What are you doing today? The other class, compute log, simply continually computes the logarithm of the value of I, the current value of I, starting at 1. And we did that because that's a fairly processor-heavy task, and it would lend itself to be operating in another thread. And then this loop runs while a variable stop is false, and so the end method of the compute log class simply assigns true to stop the thread and in essence stop the program. So let's run it. Go back to our command prompt. I've already compiled it, but I'll compile it again. So understand that the second process, compute log, is running in the background, and we computed up to 11,880. So at the point where I entered the second prompt, the first thread was joined, and then the second thread was ended, and that's when it stopped. So that's how you create multiple threads. It's very simple to start them. But like I said before, actual concurrent programming is quite complex. One problem we have is that if we're creating object-oriented programs where we use inheritance of any type, we have a problem just using the thread class as a superclass. Notice that user interaction and compute log both extend the thread class. The problem is if I have, for example, a vehicle class that then in turn derives another class from that called car, I can't also extend that class to include thread. So what we have to do instead is we have to write our classes as implementations of an interface called runnable. The runnable interface allows us to create a derived class that's derived from a base or superclass that also can be written in its own thread or written as a multi-threaded program. So in the next lesson, we're going to take the two threads example and see how to implement runnable in order to write it as a multi-threaded program. As I mentioned in the last lesson, creating multi-thread programs just by using the thread class alone won't work, because if we have an object-oriented program with derived classes, those classes cannot derive both from their base class and from the thread class. So the solution is to implement the runnable interface. So in this lesson, I'm going to show you how to take the program we wrote in the last lesson and implement runnable. So the first thing we're going to do is we're going to copy tothreads.java to runnable tthreads.java. Runnable tthreads.java. So the first thing we need to do is change that name, runnable tthreads. Now there are a couple of changes we have to make. Let's go down to our classes first. And rather than extend thread, what we're going to do is we're going to have to write implements runnable to indicate that we are now implementing the runnable interface. And by the way, when we do that, runnable gives us the methods that we need to start and stop threads and just in general work with threads. So we also need to modify compute log, like so. Most of our work, though, is going to be in the main program. First thing we have to change is how we create the threads. Rather than write thread first thread equals new user interaction, we're going to have to write thread first thread equals new thread. We're still using threads, but in a different way. New user interaction. So we call the thread constructor, and then inside the thread constructor, we call our class constructor. Then we start the first thread the same way we normally would. Now, for the next class, compute log, we're going to do this a little different also. We're going to write compute log, we'll call it numproc for numeric processing, equals new compute log. That's the first step. Then we write new thread is equal to new thread numproc, like so. Then we start the second thread. We've already started the first thread. We start the second thread. We join the first thread. And now all we have to do to end the second thread is call numproc end. So really this makes our programming a little bit easier to understand. So let's save the file. Go back to our command prompt. One other change we have to make is we also have to change how we make our threads sleep. So right here where we have sleep 1, that needs to become like so. Now, go back to our command prompt, compile again. There we go. And there's our program. So, runnable interface gives us a means of creating classes that can be multi-threaded but also be derived from other base classes. And that's important when we're writing more complex object-oriented programming. And with that, we wrap up this lesson on the runnable interface, and we'll move on and look at some more examples of writing concurrent programs. Now we're going to jump ahead and look at examples where we actually write multi-threaded code where our different threads share data. And in this, we're going to look at the use of a keyword called synchronized and also see where we're going to still have problems with threads sharing data. Before we start, let's talk a little bit about what synchronized means. Synchronized is a keyword that, when applied to a method, requires a lock to run. And what that means is that when a method is synchronized, it's going to be locked so that only one thread can have access to it. Because what happens if two threads are trying to access, say, a variable at the same time? Well, that's called a race condition, and your program will lock up and crash because both threads can't have access to one variable at the same time. Another problem with race conditions is even if one thread gets to a variable before the other one, it may not be in the correct order. For example, if you have multi-threaded arithmetic operations going on, and an addition has to happen before a multiplication, if the multiplication happens first, the results of the computation are going to be different than what you were expecting. So to demonstrate all this, we're going to use a very classic producer and consumer example, where we're going to create two classes, a producer class and a consumer class. The producer class is going to produce integers, for lack of a better product to produce, in one thread, and the consumer class is going to consume those integers in another thread. And then we're going to demonstrate what happens when the proper coding procedures for dealing with multiple threads isn't written properly. So let's get started. We're going to call this program pnc.java. We're going to start off with a class called market, and that's just going to be where we're going to have two synchronized methods that our producer and consumer classes will utilize. Get is the first method, and put is the second method, and you can guess what these are for. The consumer class will use get to get an integer, and the producer class or a producer object will use put to produce an integer. Now notice we have the synchronized keyword in front of each of these methods. This guarantees that they will be locked when engaged so that multiple threads cannot be trying to access them at the same time. All right, next up we're going to create the producer class. We create a market to produce into. Then we create a new thread. First we get a market in which to produce. Then we get a new thread and start it. In the run method, we're simply going to produce integers by incrementing I. So I starts out at 0, and we simply continue to put new versions of I while the loop is running. Next, we create our consumer class. The consumer also takes a market object in its constructor. And we start the thread. The run method for the consumer object also has a while loop, and in the while loop all we do is get. Since we're not producing anything, there's nothing else to do but get integers that are produced by the producer. Finally, we have our PNC class. Here we create a new market, a new producer, a new consumer, and then a little message to the user that to stop this program, type Control-C. And we do that because it's going to run continuously if we don't. I'll show you how that works in just a second. So let's save the program, then compile it. Now I'm going to let it run, and we're already getting out of control, so let's stop it. And let's run it again. This time, I have to do it fast. Now, let's see if we can get a good feel for what's going on here. Yes. Notice that what we should be getting is a put and a got. Put 0, got 0. Put 1, put 2. But notice what happens. Because we don't have any way to know when a thread's going to execute and run, we simply have what looks to be random and chaotic puts and gots. Not at all an orderly market which is why I use that name for the class, which is what you want. Let's run it one more time, just so you can get a feel. Now again, you see, look at that. Here we had many puts first before we ever got our first got. And our first got's way down at 16, so we can see that we're not able to follow all the transactions as they occur. So what we need are some additional commands, if you will, to organize the cooperation of the threads. And so in the exercise for this chapter, where we're going to stop, is demonstrate using some methods called wait, notify, and notify all, how we can organize this producer and consumer example to make it work correctly. And we're going to see how to do that coming up in this exercise. To make the producer and consumer program work correctly, we need to add two methods, wait and notify, into our program so that one thread will know to wait until the other thread is finished, and the other thread will have a notify to let the waiting thread know that it actually is finished. So all we have to do are modify the get and put methods in our market class. So let's go ahead and do that right now. First thing we're going to do is add a Boolean variable val set to indicate when a value has been produced or set and is ready to go out. Our get method is going to change some. It's going to be keyed off of an if statement now. And we're going to have a try and catch blocks. In the try block will be our wait method. And again, it's stopping the execution of the thread. And in the catch, we're simply going to say interrupted if an interruption exception is thrown. Otherwise, we go ahead and print out that we got it, the integer that is, and then call notify, and then return in. Put works similarly but different. It also has a wait that's inside a try. And we're going to handle it the same way. Handle that is the catch if there is one, if an exception is thrown. Then after the catch, we still generate a new in value. Set the value set to true. Indicate that we've produced a new integer. And then set notify. Everything else stays the same. The producer and consumer classes are driving class. And notice that we changed this to PNC1 to separate it from the previous PNC program. So let's save our file. We'll come back to this code in a minute. I know I kind of skipped over it quickly. There's a quick view. It went kind of long, but you can already tell that it's working correctly. Put 727, got 727, put 728, got 728. Let's try to stop it early on. So we have put 0, got 0, put 1, got 1, put 2, got 2, put 3, got 3, put 4, got 4. So our code works. So again, to look at that one more time, everything is in wait and notify. Waiting until it's time to move on. Notify lets the other thread know that it's able to execute itself. And we have a wait in our put and a notify in our put. So by putting wait and notify in both the get methods and the set methods, we allow the threads to truly be synchronized and work in the proper order, not in a haphazard way as we saw in the previous program. Like many of the other chapters in this course, there's much more to talk about with multi-threaded concurrent programming. And to cover the whole area would require a much longer chapter. In fact, it would require its own course. So as always, what I've hoped I've done here is given you a taste for what multi-threading programming is like, given you the confidence to see that it's not all that hard to get started with it, although true multi-threaded programming is complex. But I hope you've gotten the confidence to go on and explore the subject more on your own and see what you can do with multi-threading. But with that, we're finished with this exercise on working with producers and consumers, and we're finished with this chapter on multi-threading. In this chapter, we're going to learn how to write Java Applet. An applet is a Java program that runs from a web browser, not from the console or from the command line. So because of that, we're going to have to do some things differently. We're going to have to include some HTML in our Java source file. We're not going to write a main method, and all data that we display will be displayed through a window, of course, since we're executing these applications through a browser and not through the console. So for this lesson, let's start with a simple Hello World example. So we're going to call this helloapplet.java. First thing we have to do is import a couple of sets of classes. First of all, we need the abstract Windows toolkit, since we're going to be writing an application that uses a windowed environment. And then we also need the Applet classes, since we are indeed writing an applet. So that's where we start. Our program begins with public class helloapplet, just like normal. But here we're going to extend the applet class. So helloapplet is actually a subclass or derived class from the applet class. To have a bare minimum applet running, we have to implement a paint method that allows the system to display a window on the screen. All we want to do inside the window is create a string that says hello world, or draw a string. That sounds kind of funny to say draw a string, but that's what you're doing since we're in a graphical environment. So we're going to write hello world, and we also want to add 2 arguments to tell the size of our window. And that's all we need. However, with this program as is, we'd also have to write some HTML that would call the applet when we loaded the HTML file. Well, that's a lot of trouble when all we're trying to do is test. So what we're going to do instead is put the HTML inside our source file. So to do that, we have to put it inside a comment. So we start off with a /*. This will be a multi-line comment. Then we write an applet tag with the attribute code being set to hello applet. And then we set the width of the window and the height of the window. And then close the tag. And then, of course, close the comment. So now we're ready to execute this program. So let's save it. So here we compile. And then once we've compiled it, then the next step is to run it. And to run it, all we have to do is type. And we get a warning, but we still get our screen. So I'll bring it over to our main window right here. And there's our Hello World applet. So you see we have a little title bar that tells us we're running an applet, and we have a little status bar saying the applet has started. And then in the applet itself, we have the string hello world. To close it, we simply hit the close button and we're finished. So that's all there is to getting a Hello World applet running. Now, of course, there's quite a bit more to applets than this, but for this lesson, that's a good start. So to review, you need the AWT, the Abstract Windows Toolkit, and the Applet classes. You provide a snippet of HTML in a comment. Then you write your class as a derived class from the Applet class. You implement the paint method. And in this case, because all we wanted to do is put a string, we wrote g.drawString. Notice that g is our graphics object, and we told it to string hello world onto that object. So with that, we're finished with this lesson, and we're ready to move to the next lesson where we're going to explore how to create applets in some more detail. In this lesson, we're going to look at the different methods that can make up an applet. Now, not all of these methods are necessary for every applet, but for a larger applet, you would probably include most of them, and certainly at least 1 or 2 of them are required in any applet that you create. So let's get started. We're going to call this program applet_skele.java for applet skeleton. So even though we're not going to execute this program, let's go ahead and write it like we were. So we're going to import java.auth.star and java.applet.star. We won't include the HTML code since we actually aren't going to try to execute this program. So the first method that you can include in a applet is init. Init is used to initialize variables. So if you have a set of variables that you need to use in the other methods, you're going to initialize them in the init method. After the init method is the start method. Start is used to do any sort of processing that you need to do just prior to when the applet actually is loaded. This is not the same as when the applet appears on the desktop or on the screen. This is just prior to that. So if there's any processing that needs to occur before the applet is visible, you'll put it in the start method. The paint method is the primary method where most of the executable code is located. You saw in the last lesson, Hello Applet, how we used the paint method to display the graphical user interface. And so that's where that code goes. Although not as common as the other methods, there's also an update method you can use when a applet needs to be updated for some reason. You'll need to look at the Java applet references for more information on that method. We won't be using it in this chapter. If a user leaves an applet page, you can use the stop method to perform any processing that needs to occur when an applet is not current. And then finally, the destroy method is used to release any resources that you've accumulated while an applet is running. So for example, if you're connected to a database and the program is ready to stop, when the user clicks the stop button or stops it, then the destroy method will be called and you can release resources at that point. So anything that you need to clean up in an applet, that code should go inside the destroy method. For those of you who are C++ programmers, you can think of destroy like a class destructor. So those are the methods that make up an applet. And again, they're init, start, paint, update, stop, and destroy. And they each have a special use, as we went over in the lesson, and you should be careful to use them in the proper way or else your applets will not run correctly. So with that, we're ready to move on to the next lesson where we're going to look at the use of a couple of these methods as we create an applet to display an image in the graphical user interface. In this lesson, we're going to learn how to create an applet to display an image. In this case, it's going to be the steaming cup of coffee Java image that most people recognize as a symbol for the Java programming language. So let's get started. We're going to call this program imageapplet.java. First thing we need to do, of course, is our imports. So we'll take care of that first. Now we need some HTML since we're going to actually run this applet. So let's fill that in real quick. Set a width of 400 and a height of 350. Close out the comment, and we're ready to start the class. So the first thing we're going to do is we're going to create a private variable called anImage, and it's of image type. Next, we're going to write an init method, and in that init method, we're going to initialize an image to our image. And to do that, we're going to use a method called getImage that's found following this path that I'm typing in right now. And I've put the image in my working directory just to make things simple. Of course, if you have it somewhere else, you'll write out the complete path right here. Next, we'll have our paint method. And all it's going to do is draw the image onto our applet. 50 and 25 will position the height and width of the image. And then just to demonstrate this, you can set the status bar of an applet. So we're going to write just a little simple image loaded message down there. And I'm just doing that to demonstrate how it works. We don't need to implement any of the other methods, so we're going to stop right there. And let's go ahead and compile and execute this program. So we're going to save it, go back to the command line. I'm always tempted to type Java image applet, but of course we're doing this through the applet viewer. So we type out the full name. Let me bring that into view. There's our Java image. There's my image loaded message in the status bar. And that's all there is to it. So to go back and look at the code one more time, it was very simple. We have our import statements, our HTML, declare our image object, initialize it in the init method, and then paint allows us to draw the image in the applet. And of course, show status allows us to change the status bar message. So that's how you display an image in an applet. And at this point, we're ready to move on to the exercise for this short chapter where we're going to take a program we've written before using Swing, our Celsius to Fahrenheit and Fahrenheit to Celsius converter, and turn that into an applet. And we'll see how to do that in this next exercise. For this exercise, we're going to take our temperature converter application that we wrote earlier using Swing and convert it into an applet. So I've already gotten started on it just because there's so much typing to do. So I've already included all the import statements. I've written the HTML. I've started the class, declared some variables, wrote out the convert function, and now we're ready to move on to the init method. So let's go ahead and get started with that. So the first thing we're going to do is create a label, followed by a second label, followed by a text field to store the temperature being entered. Then our convert button, and then our array to store the two choices for our list. Close the string right there. And then the list itself, initialized with the temps array. Now we set the layout, and notice we're not doing it within a frame. Our layout exists within our applet, the window that our applet creates, so we don't have to reference set layout from a frame. In fact, all of our frame code from the temp converter is commented out. Now the next step is to create a listener for the list. So let me do that. This is a little touchy code right here because it's so long. So here we get the user's selection, the number, the index from the list. Next, we create a listener for our button, so let's move over and do that. We're going to write code for the action perform method. First, we create a variable to store the temperature and retrieve it from the text field. Then we get the scale from the index. Then we place the converted temperature in its label. So here we call the convert function with temp and scale, the two arguments. Now here, got to be careful I get all my closing syntax correct. I believe that's right. All that's left to do now is add the elements to the applet. And then set visible to true. And we should be set to go. Let's go back and make sure that our HTML is correct. This program is called Temp Converter Applet. So we'll save the file. Cross our fingers that we have everything right. Java C temp converter applet.java. Then type applet viewer temp converter applet.java. And here's our program inside an applet now. You see we have the familiar applet parts. We can convert a temperature. Let's take 32 and convert it to Celsius. Gives us 0. Let's take 100 degrees, convert that to Fahrenheit. And there's 212. So applications that we write that are console-based, or not so much console-based, but not web-based, such as a Swing app, can very easily be converted to applets just by following the steps that I followed here. So you see the only difference between this code for temp converter applet and temp converter is, of course, it's an applet, so we have some extra parts. But primarily, the only thing that's missing from this program is the frame. We don't need the reference to a JFrame because we're putting the graphical user interface inside the applet, and the applet comes with its own frame, if you will, that provides us with the basis for our interface. So that wraps up this exercise and wraps up this chapter on Java applets. In this chapter, we're going to learn how to write server-side Java applications, sometimes called servlets. And to do that, we first need to download and install a Java-aware web server. So the one we're going to prefer is Apache Tomcat, or just Tomcat. So in this lesson, I'm going to show you how to download it and install it for Windows, and then the next lesson we'll see how to do it for the Macintosh. So I've navigated over to the Tomcat page. First thing I did was went ahead and chose Tomcat 7.0, the most recent version. So that takes us to this screen. So to download Tomcat, you need to select 7.029 or whatever the most recent version is. By the time you view this, the version number probably will be different, but it should be in the same place. For Windows, we're going to do the 32-bit Windows zip file, so click that. Select OK right here to open with WinZip. We'll do an extraction. You can place it anywhere you want to. So what I'm going to do is I'm going to create my own subdirectory, Tomcat, and extract to Tomcat. Now, what we're looking for is the jar file. And the jar file should be in the lib directory. There it is right there. The next step is to tell your system where to find the application. So what we need to do is you need to remember, and you might want to even write it down, the directory is going to be c:\Apache-Tomcat-7.0.29/lib/servlet-api.jar. You're going to see me write that in just a moment, so don't worry about it if you didn't get it on this attempt. So now what I'm going to do is I'm going to close these windows. I'm going to go to my Start menu, go to my Control panel. Let me bring this into view here. Scroll to my System icon. Go to Advanced System Settings. Bring this into view. Environment Variables. Select Class Path. Hit Edit. And let's add that path to our class path. So it's Tomcat, Apache-Tomcat-7.0.29/lib/servlet-api.jar. And click OK. Click OK. Click OK. You can close. And that's all we have to do. Now, before you can actually run a Java server app, you'll need to reboot your computer to make sure the class path has been properly changed. That's the only thing you'll have to do to be able to run Java servlets. So I'm going to go to the next lesson where we're going to talk about installing Tomcat on a Mac. If you don't have a Mac, you can skip that lesson and move to the next lesson where I'm going to show you a very simple Java servlet. In this lesson, I'm going to show you how to install Tomcat on your Macintosh. So the first thing you need to do is you need to navigate to the tomcat.apache.org website. When you get there, select the Tomcat 6.0 link. At Tomcat 6 Downloads, scroll down and look for the tar.gz file under the core binary distribution. Download it. Once it's downloaded, open your Finder. You should find it under your Downloads directory. Move it down to its own area or move it up, either way you want to do that, but get it out of the Download subdirectory. Then extract the file by double-clicking it, and that will unarchive it. Now you have a folder for Apache Tomcat 6.0.35. At this point, open up a terminal window and you should see the subdirectory right there, Apache-Tomcat-6.0.35. Let's rename it using the move command to something a little more manageable, such as Tomcat, like so. Then cd into Tomcat. Then cd into the bin directory. Then you should see a command called startup.sh. Type sh startup.sh, and that should have your Tomcat program running. Go back to your web browser, type http://localhost:8080, and you should see the Apache Software Foundation Apache Tomcat page. And if you see that, then your installation worked correctly. If not, go back through the video, go through the steps I took you through, and you should get it to work. And with that, we're finished with this installation and ready to go on to see how to use Java with Tomcat to build servlets. In this lesson, I'm going to demonstrate how to get a simple Java servlet running. And because we're going to be doing a lot of configuration, I've gone ahead and written the program already because it's very simple. We can go over it line by line here very quickly. So the first thing we have to do is import java.io.star and javax.servlet.star. Our class is called Hello World Servlet. Hello World Servlet is a class that extends the generic Servlet class by implementing the main service that all servlets have to implement, and that's the service. So you'll notice that the service method takes two parameters, a request, which is a servlet request object, and response, which is a servlet response object. That's again given the interactive nature of a web page, the client-server part of that. And it throws two exceptions, servlet exception and IO exception. We're not trying to handle those exceptions in this example, just to try to keep things simple. So the first thing we have to do inside the service method is set the content type for our response object. And we're handling HTML, so our content type is text/HTML. Then we need a way to write a response to our page. So we have a printWriter object, PW, and it is built from the getWriter method of our response object. And then all we do is write out a simple phrase, hello world, and then we close our printWriter object, and that's the end of the service. So that's all this servlet will do when we load it, and that's display hello world. That's good enough for a start because we're going to spend quite a bit of time right now doing some configuration, including compiling the class. So let's save and exit. And the first thing we want to do is compile the class. And we have to compile in a special way because we have to make sure that we make a reference to a specific jar file that's part of the Tomcat installation. So to compile our class, we're going to write hello world servlet.java like we normally do. Then we're going to set the class path. You could do this also in your environment variables, but I'm going to do it here just because I don't want to go through the whole process of setting it somewhere else. So the class path is our Tomcat path into our program, and lib, and then servlet api.jar. So the class path is C:\Tomcat/Apache Tomcat 7.0.29. That's where my Tomcat installation is. Then the lib directory, and then servlet-api.jar. Hit enter, and it compiles and creates a class path. Now the next step is we have to copy that class file into a particular subdirectory. So here we go. Make sure I get the directory correct. And then it's web apps, \examples, \web-inf/classes. I've already got it there. Let's do it again. So we'll just say yes, and now it copies. If you need to write it down, there it is. This is easy to find in any reference. There's the jar file for compiling, and there's the path to copy the class. After that, we have to do some configuration on the Tomcat side. So I've got another DOS window for that. So either using the same window or opening a new window, go to your Tomcat installation main directory, then cd into the following subdirectory. All right, so let's do that one at a time. Like so. Then you'll see at the bottom we have a web.xml file. We need to open that up, so we're going to open it up in Notepad. And I've already put these two settings in. Scroll down until you find the section of this XML file that has servlet information. And you're going to add the following tags. So you open servlet tag, then a servlet name, hello world servlet, then close servlet name, then open a servlet class tag, hello world servlet, close the servlet class tag, and then close the servlet tag. And just put it at the beginning of the servlets. When you finish that, scroll down, and here we're looking for servlet mappings. And we need to set a servlet mapping for our servlet. So open a servlet mapping tag, then open a servlet name tag, type in the name of our servlet, close that tag, open a URL pattern tag, type /servlets/servlet/hello world servlet, close the URL pattern tag, and close the servlet mapping tag. And that gives us our configuration. So we're almost ready to go. The next step is to start Tomcat. So cd back to the Tomcat/Apache Tomcat 7.0.29 directory, cd into bin, and then type startup.bat. And that will start Tomcat. It'll bring up a little window telling you that it's running. Next step will be to open up a browser window and then type the following: 127.0.0.1:8080/ and here's my example right here. And there's the servlet. So that whole URL is 127.0.0.1:8080/examples/servlets/servlet/hello world servlet. And that brings up hello world, which is what our servlet app was supposed to do. If you get an error, then more than likely you mistyped something in one of the configurations. Make sure the class file is in the right place, and make sure that you set up the XML file the way you're supposed to. If it didn't work, go back and watch the video again, and if you go through the steps that I went through exactly as I gave them to you, you should not have any problem. That's how we run a servlet in Java. So what we're going to do now is we're going to move on to exercises. Rather than have more lessons, we're going to go into exercises. And I'm going to show you two examples. One that uses GET requests to retrieve information from our web page. And in the second exercise, we're going to use POST requests to get information from a web page. So let's move on to exercise 1, where we're going to learn how to handle GET requests. In this exercise, we're going to see how to pass information from a form to a Java servlet using a GET request. So we'll start out by looking at the servlet code. I've already written it in, so we'll just go over it for a moment, then we'll configure everything and then run the program along with our HTML page. So we start off with our imports, java.io.star, javax.servlet.star, and for this program, javax.servlet.http.star, because we're going to be extending a different servlet class. In fact, we're going to see that class right now in the next line. So our program is called Retrieve Fields Servlet, and it extends the HTTP servlet class because we need a particular method for our program. And that method is called doGet, because that's what we're doing. We're doing a GET request as opposed to, say, a POST request, which we're going to look at in the next exercise. Our two parameters are a HTTP servlet request object called request and an HTTP servlet response object called response. And we throw IO exception and servlet exceptions as the exception objects. So the first thing we do is we set the content type for our response object to be HTML. So we write text/HTML. We instantiate a print writer object so that we can write data to our screen or to our page. Then at that point, we're ready to retrieve data. So to retrieve data, we call the getParameter method on our request object with the name of a field from our form. So what we're going to do right now is go back and get to our form. Take a look at it real quick. Here's our form. It's very simple. The most important thing to understand is that in our action attribute in the form tag, we have a call to our servlet. So it's localhost, same thing as 127.0.0.1, port 8080, examples, servlets, servlet, retrieve field servlet. So when we submit this data, it will load that program, our retrieve fields servlet. The fields for our form are full name, address, city, state, zip, and then we have a submit button as well as a clear button, which is not implemented. So going back to our Java program, we get each parameter or get the data that's stored in each parameter when the request is happening and store it in a string variable. So full name, address, city, state, and zip all get stored in string variables, and then we turn around in the last part of the program, write that data back out to a new web page. Again, that's just for demonstration purposes. And then we close our writer and we're finished with the program. So our next step would be to compile that. So let's go back to our Java directory and begin the process of compiling. We have to set the class path attribute, and it's C:\Tomcat\Apache Tomcat-7.0.29/lib/servlet-api.jar, close quote. And there's our compile. Then the next step is to copy the class file to the appropriate subdirectory. So we're going to copy retrieve field servlet.class to C:\Tomcat\Apache Tomcat web apps examples webinf/classes. I've already tested this, so we'll say yes and copy it. The next step then is to go into our XML file. And then we scroll down to the servlet tags. Create a pair of servlet tags, servlet name tag, retrieve field servlet, and a servlet class, retrieve field servlet. This is exactly how we did it with the Hello World servlet example. In fact, those tags are right below. Then we move down to servlet mapping and create a pair of tags, servlet name and URL pattern. Make sure you get that order correct. Then when you're done, exit and save. I haven't changed anything, so it's saved. Then start Tomcat. I already have Tomcat started. I'll just remind you how to do that if you've forgotten. Startup.bat. And I also should probably mention that to shut it down when you're finished with your examples, you just run shutdown.bat, also from the bin. Now the next step is to load the form and test our program. So I'm going to open that file. There it is, I believe. Yes, that's it. And then we hit submit. And there's our data. Full name John Doe, address 1 Main Street, city Anytown, state AS, zip code 11111. So that's how you create a servlet to retrieve data using a GET request. Now we're ready to move on to the next exercise where we're going to use a POST request instead, and we'll use a little bit different form also. In this lesson, we're going to look at how to handle a post request using a Java servlet. This time I've brought up the form that we're going to work with. This is a simple form in an HTML page, which allows us to select a language from a drop-down box, and then we're going to submit that to our Java servlet. So you see we have our form, and the only thing we need to notice different about this form is that because we're using post, we have to set the attribute method to post. Otherwise, the servlet will think it's trying to do a GET request rather than a POST request. So then I simply provide 3 selections, C++, Java, JavaScript, and a submit button for the user to click when they're ready to submit the form to the servlet. The servlet looks like this. Again, it's a very simple servlet to write. We import the same class as we did for the GET request. Our program is called PostSell SEL servlet. Again, we extend the HTTP servlet class. Same parameters and exceptions, but notice this time the method is doPost rather than doGet. After that, everything else is the same, except for the different types of fields that we're working with. We set the content type. We create a printWriter object using our response.getWriter method. Then to draw the data out of the request, we get the parameter lang, which it gets from the form. We store that result in the string variable language. Then we write it back out to the user. Compile this program the same way you did before with the same class path. I'm not going to show you again because you've seen it several times now. Then copy the class path to the proper subdirectory. If you don't remember, go back and look at the other video. Next, you need to set up the web.xml file with the servlet tags and with the servlet mapping tags. Here are the 2 servlet tags, servlet name and servlet class. And if we scroll down to our mappings, here are 2 servlet mapping tags, servlet name and URL pattern. Again, the only difference is we've changed the name of our program. Otherwise, it looks just like the exercise 1 example, which is right below it. Once you've done that, you're ready to go. So bring up a web page. Load the form. Here's my form. Of course, we'll pick Java as our language we prefer. Then when we hit submit, you selected Java as your favorite. So now we've seen how to display a simple message, our first example. And we've also seen how to process GET requests and POST requests. So I feel like now you have a very good background in writing Java servlets, and you can take it from here using the proper reference materials to write other types of servlets that you need to write. And with that, we wrap up this exercise, and we wrap up this chapter on Java servlets. In this chapter, we're going to look at programming with JavaBeans. A JavaBean is a class that exposes its methods and properties. Properties is a new term we haven't used before in this course, to other programs or applications. With JavaBean programming, we can perform component-based software design. What that means is that we can write independent components and then have each component look at other components to determine whether or not that particular component has a method or has data via a property that the component can use to get its own work done. So by being able to write components, we can simply plug components in when we need them and simplify the software development process. So in the next few lessons, we're going to be looking at how to do some simple JavaBeans programming. So I'm going to start off first by creating a class that will serve as a JavaBean. So we're going to call this class temperature. It's going to be used to store a temperature and then have conversion methods that can convert from, say, Celsius to Fahrenheit or Fahrenheit to Celsius. To start, we have to import a class we've never used before, serializable. And that's because a JavaBean has to be a persistent class. And by that it means we have to be able to save the state of an object at any particular time. So for example, we might write out the contents of the fields of a class to disk. And by that, we're saving the state of an object, and that's what persistence is. And we implement persistence via the serializable class. So any class that's going to be a JavaBean has to implement the serializable interface. So here we have to write public class temperature implements serializable. First thing we have to do is create a constructor, and this constructor has to be a default constructor. So I'm going to arbitrarily use the default constructor to set the temperature to 0, the current temp. We're going to define that in just a moment when we define the field for the class. After the constructor, the next thing we want to do is create what are called getters and setters, or properties for this class. In this particular class, we're just going to have one real field that has data we want to retrieve or set, and that's going to be temp, or the temperature, the current temperature. So a property temperature should be able to be gotten, in other words, returned, or set. In other words, we ought to be able to pass in a value for the temperature and set that field to that value. So the way we do that is we write what are called, as I said, getters and setters. So we'll have a get temp that returns the current value of the temp. And we have a set temp that sets the value of temp, in this case via the parameter t. After that, we can write whatever methods we deem are necessary for this class. I'm just going to have 2 to keep things simple. I don't want to make the definition too confusing. And here we're going to have a C to F method that will convert our temperature from Celsius to Fahrenheit. And then another method, F to C, that will convert the temperature from Fahrenheit to Celsius. And that's all we're going to define. Again, I'm trying to keep this class as relatively simple as I can. Since we're going to be looking at concepts that are new, I don't want to get too bogged down in details of a complex class. I want to concentrate on the procedures we're going to need to follow to do JavaBean programming, not on trying to create a fancy class definition. So we'll end this lesson here with this definition of our class, and now we're going to move to the next lesson where we're going to see how to create things called property and method descriptors that will enable other programs to access the properties and methods of this temperature class. In this lesson and the next lesson, we're going to learn how to create a Beaninfo class that will allow us to get information such as properties, descriptions, and method descriptions about a Bean class. So let's get started. We're going to call this tempinfo.java. The first thing we do is we import java.beans.star to get access to the Bean classes that we're going to use. In this case, just one Bean class. Our class is called tempinfo, and it extends a class called simple Beaninfo. That's why I call these Beaninfo classes. So the first thing we do is we create a method called getPropertyDescriptors. And it returns an array of property descriptor type, which is a special type used with Beaninfo classes. So our method is called getPropertyDescriptors. Takes no parameters. And inside the body of the method is a try. And the first thing we do is we create a property descriptor object, temp, which is going to hold information about our temp property from our temperature class. So we call the constructor for property descriptor, and we provide it with the name of the property we're interested in and the class where it is defined. And notice we're using the class object, which is our compiled temperature class. So then once we've done that, we create an array of property descriptor type. We'll call it PD for property descriptor. and we retrieve the data stored in our property descriptor object. And then we return that as the return value of the method. If there's a problem, we'll catch it, and we'll just simply print out exception thrown. Won't really matter too much what we say there. And we also need another return value, return null, if an exception is thrown, because the method has to return something, otherwise it won't even compile. So this is the property descriptor part of our Beaninfo. We also have method descriptors, so we're going to do that in the next lesson. So let's compile this real quick to make sure that it works correctly, or at least that it compiles correctly. And it does, so we're set to go. So let's move on to the next lesson, where I'm going to show you how to get information about methods and add it or extend this class with method descriptions. In this lesson, we're going to learn how to add a method descriptor method to our TempInfo program so that we can get a description of the methods that are part of a JavaBean class. So I've already put the TempInfo code up on the screen, and I've added an import statement to import java.lang.reflect.method because we're going to need to use the method class in order to get method descriptors. So let's get started. Our method will return a method descriptor array, and the method itself is called getMethodDescriptors. And it immediately launches into a try block. And the first thing we do is we create a class object called CL and assign it the temperature class, temperature.class. That's the file that we get when we compile temperature.java. Next, we're going to create another class object, args, which is an array, and it will hold the parameters for our methods. Now, in this case, because our methods have no parameters, it's an empty object. So that's why you have the open curly brace and the closed curly brace. But we still need the object, args, even if it doesn't have anything in it. The next thing we're going to do is create a method object, C to F, that is obtained by calling the getMethod method of our class object CL with the name of the method and our args object. Now, at this point, we're ready to create a method descriptor. So we're going to call that C to F DESC. And here we call the constructor for the method descriptor class with our C to F method. Now, once we've done that, we're set to go, except we want to add a short description to our method descriptor object. So we're going to do that now. And close it up. So now we need to do the same thing for the method F to C. So I'm going to type here and not talk much since it's essentially the same thing we already did. Close it up. Now we're ready to build the method descriptor array. And that consists of our two method descriptor objects, C to F desc and F to C desc, or DESC. And then we return it as the return value of the method. We're in a try catch, so we've got to write the catch part. And here we're just simply going to say exception thrown. And then we need to return null if we don't return the method descriptor array. And with that, we're finished with the definition of the method, getMethodDescriptors, and we're ready to save the file and compile it. And we get a little message telling us we might be using unchecked or unsafe methods, but that's okay. And there's our definition. So now we have a getPropertyDescriptors method and a getMethodDescriptors method and we're ready to move on to the exercise where we're going to demonstrate how to pull this information out of our JavaBean class. In this exercise, we're going to finish out the chapter by demonstrating how we can inspect the temperature JavaBean class to see what the properties and methods of the class are. So let's get started. We're going to call this program temp-inspection.java. First thing we do is import the beans classes. So we import java.beans.star. The class is called temp-inspection. First thing we do is set up a try block. Then we identify the class that we're working with, and that's temperature. Then we create something called a Beaninfo object. And this is where our get property descriptors and get method descriptors are. And the way we get the property and method descriptors is by calling the introspector class with the get Beaninfo method and our class as a parameter. Then we're ready to display properties and methods. So first of all, we create a property descriptor object, which will be an array of our property descriptors. And we call our get property descriptors method from the Beaninfo object. Then we write a loop that goes from 0 through the length of the property descriptor. And for each indexed property, we call the getName method to display the name. And that will display the properties of the temperature class. Next, we're going to print a blank line. Then we're going to display the methods. And we're going to do the same thing we did with properties. We're going to create a method descriptor object. That is an array of method descriptors. And then we call the get method descriptors method from our Beaninfo object. And then write a loop that goes from 0 through the length of the method descriptor object. Index into the method descriptor array, calling the getName method to return each name. Then we're finished with the try. And then we catch our exceptions if there are any. And we'll just display a simple message. Close the catch, close main, then close the class. So we'll save the file. Compile temp-inspection.java. Then run our code. Now you notice that besides the properties and methods that we created, some are added automatically. That's due to inheritance and properties and methods that we pick up through the inheritance chain. There you see temp, there you see C to F, and there you see F to C, along with get temp and set temp. So those are all of our methods and all of the properties of the temperature class. So using this temp inspection program, we can write another program to look at our temperature class and figure out what its properties and methods are, which will help in trying to figure out how to interact with that class. So that wraps up this exercise on inspecting a JavaBean class, and that wraps up this chapter on JavaBeans. In this chapter, we're going to look at something called Java NIO, which stands for New I/O, which of course would stand for New Input-Output. These are new methods of performing input-output in Java. They're really not that new, but they're called that because they differ from the original ways that you performed I/O in Java. This new I/O is based on buffers and channels rather than buffers and streams. And to demonstrate what we're talking about, I'm going to develop a little file copying program in this first lesson as kind of an introduction to NIO. So let's get started. We're going to call this filecopy.java. So the first thing we're going to do is import some files. First we need the IO files. Then we need the new IO files. And then specifically, we need the channels files because we're going to be working mostly with what are called file channels in this example. So we'll start our program. Main has to throw an IO exception. We're not going to catch it in this example, but you still have to throw it. We are going to put our code inside a try, but we're just going to have a try finally instead of a try catch. So the first thing we're going to do is create our source file objects and our destination file objects. And so we're going to get our file names from the command line. So the source file will be in args sub 0. And the destination file, the file that we're going to copy to, will be in args sub 1. Then we're going to check to make sure that there is not already a destination file. And if not, then we're going to create a new file. And that's the end of our quote-unquote maintenance work. Now, because we work with channels versus streams, we have to associate our source and destination files with a channel. So we're going to have a source channel for our file, the source file, and a destination channel for the destination file. We set them to null right here because we're going to put them inside a try. So the way we associate a channel with a file is like so. We're going to write source channel equals new. Then we use our old friend file input stream with our source file. And then we call get channel. And that associates the channel for the input file with the source channel object. And then our destination channel is set up the same way, except of course with the file output stream. I don't need that dot right there, so take that out. And then to perform the file copying, we can do it very simply using a NIO method called transfer from, which lets us take all of the data from one channel and transfer it to another channel. So the way we're doing it is we're saying start at the 0 byte of the data and go all the way through the full size or the length of the data in the source channel and transfer that to the destination channel. Then when we're finished, we have a finally block. And as long as the channel is not equal to null, we're going to close it. And then we do the same thing on the destination channel. And close the finally, close main, and then close the class. So let's save our file. Let's see if we have a file that we can copy. There we go, minmax.txt. So first let's compile. Everything looks good. So let's say Java file copy minmax.txt to minmax.back. Let's look at both files. There's minmax back. Let's do this a different way. Actually, we still see some of these other class files, but there's our original text file, and there's our backup file. So this was an introduction to NIO in Java. The nice thing about file copying is that it's very quick. We use one method to perform the copying, actually a transfer, and we don't have to set up a loop or anything to copy byte by byte. However, you can loop like that. And so in the next lesson, I'm going to show you how to write a type command, the DOS type command, where you just display the contents of a file using a more traditional approach, yet using Java NIO. And we're going to see how to do that in the next lesson. In this lesson, we're going to look at how to use NIO to read from a buffer. What we're going to do is we're going to write a utility to recreate the type command in DOS that displays the contents of a file on the screen. So let's get started. And in doing that, we're going to demonstrate how to read data from a buffer. So we're going to call this type nio.java. First thing we do is import our files. Our main method has to throw IO exception, so we'll make sure to include that. First thing we're going to do is create an int variable that will keep track of the size of the buffer. Next, we get our source file from the command line, like so. Then we create a file channel object. And here I'm going to have to drop down to the next line to finish this line. Now we're ready to work with the buffer. So we're going to put this inside a try. The class we're going to work with is byteBuffer. And we're going to allocate a buffer of size 1024 to try to maximize our performance. And then inside the try will be a do while loop. Here's where we read into the buffer and store the size in count. If the size of the count is not equal to -1, in other words, it'll be -1 if there's no data to read, otherwise there's data to read, first thing we want to do is rewind the buffer. It's an NIO method, rewind, which gets us back to the beginning of the buffer so that we can read from the beginning of its contents. So that's the first thing we do. Then we write a for loop. And here we're going to get a byte, let's use the expression, out of the buffer and print it. But to do that, we have to convert it to char, like so. And that's all we have to do. And again, we're going to do this while the count is not equal to -1, while there's data to read in the buffer. And here we're going to catch any IO exceptions that may occur. We'll just write error reading file. And then we're finished, so we close off our two definitions. Save the file. Compile. And we'll type out the file that we copied in the last lesson. And it has a couple of method definitions in it left over from, looks like, our binary search tree programs. And there you see how we type out a file. So, working with buffers in NIO is very simple, very straightforward. We simply read the data from our source channel into the buffer, and then when we're ready to work with that data, we simply pull it out using the get method, cast it to char, and display it. And that's all we had to do. So that wraps up this lesson on working with buffers in NIO. Now we're going to move to the next lesson where we're going to talk about working with the file system with NIO. In this lesson, we're going to use one of the more advanced features of Java NIO. And what I mean by that actually is that we're going to need to use the most recent version of Java, Java 7. So if you don't have Java 7, if that's not the version that you downloaded, then go back and download it now, following the instructions for downloading that we went over in the beginning of the course, and then come back here. The version of Java I've been using for the lessons has not been Java 7, it's been Java 6. I always like to use one version below the most recent version, primarily to make sure that everything that I do is stable and there won't be any problems with a program that I might give to somebody else or that I might perhaps sell to a customer. What I want to do in this lesson is look at some methods for returning information about files. And we have to use Java 7 for that because these features aren't available in Java 6. So I'm going to use my Java 7 version for this lesson and then for the exercise that follows. But to do that, I'm going to have to go back to that version. And I hope I got this file path correct. And I do. So there it is. So you see what I did? I just went to Program Files, into Java, and then to the JDK 1.7.0. I need to go one more directory down to get to bin, where my compiler is located. So now we're ready to write the program. So we're going to call this program filedata.java. We need to import java.io.star, and then we need to import java.nio.file.star to get started with. So our class is called filedata. So the first thing we're going to do is we're going to get a file to get data on. We're going to do that by using a path object. And so we're going to say paths.get arg sub 0. And in arg sub 0 will be the full path to the file that we want. So that could either be a file that's in the working directory, in which case you only have to give it the file name, or it could be the complete path. The example I'll use will involve the full path, just so you can see how that works. So once we get the file, we're ready to begin getting information on it. So the first thing we're going to do is just print out the file name. To do that, we call the getName method off of our file path variable with 1 as the argument to make sure that we get just the name. Now the next parts of this will require being used inside a try block. So first let's see if our file is hidden or not hidden. So we have a isHidden method. It's a Boolean method that will return true or false. And if it's not hidden, we're going to say it's not hidden. Otherwise, we'll display that it is hidden. Another attribute we can look for, another piece of data we can look for, is if the file is writable or not. In other words, can we write data to that file? Now, we won't go to all the trouble of saying if it's not writable that the file is not writable. We're going to stop with that. We'll also check to see if the file is readable. And I've already seen a little mistake I made right there. That should be files. There we go. File is readable. And there are many, many other attributes you can look at. I want to stop there just because you get the main idea of what I'm trying to do. More than that is just being a bit redundant. Then we're going to catch an IO exception. And we're just going to print a simple message. Error checking file attributes. And like I said, there's many, many other attributes you can check. I would just look at the documentation for java.nio.file to learn about more of the attributes you can check. These will give you a good sense of what you can do with NIO and file data. So let's save that. Come back to our screen. Compile it. Then we'll run it with a file that we've used previously, grades.txt. It's in the data subdirectory right off the root. So notice again that I'm using double backslashes to escape the special character D, although there's not a special character G, just to make sure that there's not. And there it shows that the file I'm looking for is grades.txt. File is not hidden. File is writable. File is readable. And we could even do this on the file that we created here, just for fun. Now, notice that when we did that, we get an exception. Let's try it again. It's going to be a lot of trouble to go to the whole length of that. Let's see if I have a text.txt file. There we go. Let me go back and show you this in the code. So when using paths like this, you have to be very careful because without providing the full path as the argument, the command line argument, you're going to have an exception when the program is run. So just keep that in mind when you use this particular program. So that wraps up this lesson on getting file data or getting file information. Now we're going to move to our exercise for this chapter on NIO. We're going to stay in Java 7, and I'm going to show you how to write a utility that will read the files out of a directory tree. In this exercise, we're going to write a program that displays the contents of a directory, including all the files and all the subdirectories and all the files of the subdirectories of a directory. So let's get started. We're going to call this program showdirtree.java. I've already started it. I've included the import statements that I need. And the first thing we have to do is we have to create a class that provides the functionality that we need, and it is going to be called FileVisitor, and it extends an interface called SimpleFileVisitor. So that's how we started off. In this class, we have to create one method. It returns something called a FileVisitResult, so that's its return type, and the method is called visitFile. Its parameters are a path, and then a set of basic file attributes. Continue on the next line, like so. This method throws an IO exception, and all this method does is displays the current path and returns a constant FileVisitResult.continue, saying we need to continue reading more files and file directories. So that's the class, very simple. So now we're ready to write the class that runs our program. First thing we do is create a string variable dir, dir, that holds the directory we want to display. We're getting that from the command line. Then we display a little header saying the starting directory is our dir, or the value that's stored in dir. Then inside a try block, we call a method from the files class, walkFileTree, with the path that we specify, and a call to our FileVisitor class. And that's all we have to do, except catch our IO exception, which is really just a formality. So let's do that. Print an error if we have trouble somewhere. And that's it. So we'll save the file, come back to our command prompt, compile it. Let's do a simple one. This only has files, so we don't have a problem. Now let's do a little bit more complex one. Say our Windows directory. And notice it goes on for quite a while. So we're going to stop. Let's do our program files subdirectory. I'm doing this primarily to show you that it's going to throw an exception because you can't specify a directory or a file name with a space in it. One of the weaknesses of Windows. So what I have to do is I have to put that in quotes, like so that it represents a name without a space, if you will. And now we're still in my Adobe subdirectory. We'll watch it just for a second. The best thing you can do is try this on your own system and see the different results that you get. Yours are not necessarily going to be like mine, of course, because you may have different programs installed. All right, so you see we're working through Adobe. Now we're in Photoshop. Now we're in Reader. Now we've gone out of Adobe into Broadcom. I'm going to stop there. So the program to walk a directory tree is fairly short, 20-something lines of code, including some spaces there, and including 3 lines of imports. So this is one of the powerful features you get with Java NIO, and I would encourage you to explore these with Java 7 to see how you can add them to your own applications. But with that, we're finished with this exercise, and that wraps up this chapter on Java New I/O. In this short chapter, we're going to look at the StringBuilder class. The StringBuilder class is provided as a way to perform string operations in a more efficient manner when you're working with either long strings or many string operations at once. For example, a large number of string concatenations that have to be performed one after another. In those situations, the StringBuilder class is more efficient than the string class because with a string variable, every time you make a change to it, you're making a copy into a new variable. In other words, in Java, strings are immutable, whereas with the StringBuilder class, you build one object and think of it like an array. And every time you either append or concatenate new strings onto the current string, you're simply modifying the contents of an array rather than creating a new copy of a variable. So in this first lesson, I'm going to demonstrate why strings are inefficient and why string builder objects are more efficient. So let's start off by looking at the file we're going to work with. What we're going to do is we're going to build a string out of a file of words. So let's see if I can get that up here. There's our string of words, or our file of words, just a bunch of animals. And what we're going to do is we're going to build a comma delimited list, or a comma delimited string out of these animal names. So let's get started with the program. So we're going to call it stringconcat.java. Let me get my screen into place and adjust it just a bit here. There we go. So we start off, we need to import a couple of things. So we need java io.star and import java util.star. And we get the program started. First of all, we need a buffered reader object for our file. Then we need a couple of string variables, word and words. Let's initialize them to empty string. We need the file to open. There's our file. Then we need some variables to keep track of the time it takes to do both types of concatenation, both with the string and with the string builder object. So we need start time, stop time, and duration. And we also need to initialize those. Now we're ready to begin. So because we're reading from a file, we have to put that in a try-catch. So the first thing we do is we associate our buffered reader object with the actual file. Then we start our time by getting the current time in nanoseconds. Then we write our loop that reads the file. To build our string, we take the word that we read with readline and concatenate a comma to the end of it. We're not really interested in the string, we're just interested in the time it takes to build the string. And we get the time again when we're finished. And then our duration is equal to our stop time minus our start time. And then our catch. And we'll just print out a toString of the exception. If we have one, we're not going to have one here. And then let's display the time to concatenate using a string. And then let's stop the program so we can see how long that takes. So we'll save the file, go back to our command prompt window, compile, and then run it. And we see it takes 6,305,689 nanoseconds to concatenate that string of animal names. So let's go back to the program. And then we're going to add into our program by reinitializing start time and stop time and duration. Then we're going to create our string builder object. We'll call it SB words. And then we just call the default constructor for the string builder class. In the next lesson, I'm going to describe the string builder class in more detail. This is just to give you an idea of why it's important to have it. And here we're going to have the very same program as we had above, The only difference is we're going to append to our StringBuilder object in just a minute. Right here. So that's how we concatenate. We don't really concatenate. We use the append method of our StringBuilder object. Then we're finished. So we get the stop time. Then we compute the duration. Add our catch in real quick. And then display the time. Make sure we have our two closing curly braces still in place, and we do. So we'll save the file. Go back to our command prompt window. Clear the screen. Compile. And then run. All right, so this time it took almost 2.5 million nanoseconds to concatenate, and it takes 872,318 nanoseconds to append. So you can see clearly that appending with StringBuilder is faster than concatenating with string. So for operations such as the one we're performing there, it's clear that the StringBuilder class is preferred over working with just plain old strings. So now we're ready to move to the next lesson where we're going to look at the StringBuilder class in more detail. In the last lesson, I introduced you to the StringBuilder class, and in this lesson, we're going to look at the more popular methods that you'll use when working with StringBuilder objects. So let's get started. We're going to call this program stringb.java. We don't have to import anything, so we can go directly to our main program. You saw in the last lesson how to instantiate a new StringBuilder object, just like this. You can also initialize an object by passing in a string as an argument to the constructor. So let's take a look at that. It didn't make sense to do that in the last lesson because we were concatenating and building a new string. But here we want to start out with the string, so we can do that. Then if we want to display what's in the StringBuilder object, we can call the toString method. So let's save that, compile, and then run. Okay. We left out the word is, so we can insert that into our string using the insert method, which takes an offset where you want to start the insertion and the string to insert. So the offset will be the position after the space, essentially where T is. So that's going to be position 0, 1, 2, 3, the fourth position. So if we say insert for the word is, just like so, then let's display the string again using toString. Compile it, and then run it. Okay, so we need a space. And this is a very common mistake you'll make. Put a space right there. Try it again. There we go. Exactly how we want it. We can use index of to tell us where a particular substring is in the string. We're about to run out of room, so let's move this down to the next line. So we save it. So index of takes a string or a substring and will tell us where that object is, where that string is in the larger string. So it's at position 7. If we want to delete the string, we can say sentence delete. And then we can give a starting position 4 and a stopping position 6. Then let's display the string again. compile, and then run. So now we've taken it out. We can also delete a single character using a method called delete_at. So let's take out a space. So we know there's going to be a space at 0, 1, 2, 3. So let's delete that space and see what we get after we've deleted it. Let's clear the screen, recompile. All right, so you see we had an extra space. Now we've gotten rid of that extra space and we're back to where we were. Another thing you might want to do with a string is reverse it. So we'll reverse it and then display it. Compile and then run. So notice it reverses the letters as well as the words. So you could use that to check for palindromes and other little interesting little parlor games like that. So those are the primary methods of the StringBuilder class. Now there are lots of overloaded methods for each one of these. So there's inserts for all different types of data types, and there's lots of different delete methods. So I would suggest you consult the documentation for the StringBuilder class to look at all the variations of these methods. But these are the primary methods you're going to use when you're working with the StringBuilder class. And with that, we're ready to move to the single exercise for this chapter. For this exercise, we're going to write a little program to demonstrate how to create randomly generated sentences using arrays of different sentence parts and then randomly put them together to form sentences. So let's get started. We're going to call this program grammar.java. So the first thing we're going to do is create a series of arrays to store different parts of a sentence. We're going to start with the determiners, and we'll have 4 of each sentence type or each sentence part type. So we'll start out with 4 determiners. They're going to start the sentence, so they're capitalized. Next, we're going to have some adjectives. After the adjective, we'll have some nouns. And after the nouns, we'll have some verbs. Once we've done that, we're ready to create our StringBuilder object. And we create our random number generator. Now we're ready to start building some sentences. So we're going to build 4 sentences. So first we generate a random number. Then we use that random number to randomly pick a determiner and then pin that to our StringBuilder object. And we do the very same thing with our adjectives. And then again with nouns. And then one more random number. And then our verbs. Then we write out the sentence. And then instantiate sentence again so that it's empty so that we can generate another random sentence. So with that, we're finished. So let's save the program, compile it, and run it. There's our first run. There's our 4 sentences. I left off the period, but that's okay. Notice that we can't be sure of determiner adjective agreement and huge instead of a huge. Although for the last sentence, "and ugly monster sits," the determiner is correct. Let's run it again, and you'll see the results. You'll notice we have lots of problems with these sentences, but it's a great start if you want to use it as a basis for creating a true system that creates random sentences. So with that, that finishes the exercise, and that wraps up this chapter on the StringBuilder class. In this chapter, we're going to talk about regular expression processing in Java. A regular expression is a string of characters that's used to describe a character sequence. We call that character sequence, or the regular expression, a character class. So for example, if I'm trying to look for the word Java in a text, then I might put Java as my character class, and that would be the expression that I'm searching for, just the word Java. I'm using the brackets because that's a common way to specify a character class, is via the brackets. But the actual class itself is just the characters JAVA with the capital J. Case matters unless you tell the regular expression that case doesn't matter. So the character class would specify the pattern that you're looking for. So for example, I might specify AEIOU if I'm looking for vowels inside a word or a string of some type. After character class, another component of a regular expression is the wildcard character. The wildcard character in regular expressions is the dot, and the dot will match any character at all. So for example, in a character class, if I wrote J dot, then that would match any string that began with a capital J followed by any other character or no character at all. So the dot is the wildcard character. We also have things called quantifiers. Quantifiers are used to specify matches that can be made. So for example, if we put a plus in a quantifier, that means match one or more of the character class. So for example, we could write JA plus, and that would say match one or more character sequences of JA. Another quantifier is the star. Star means match 0 or more. So here we could write IE star, meaning match 0 or more character sequences of IE. The last quantifier is the question mark, and that means match 0 or more. So for example, I might write J question mark, and that would mean match any two characters after the capital J. That could be 0 or more, so I could match 0 after the J, or 1, or 2, just depending on what string sequences are actually found. A limited example of regular expressions comes in some DOS commands. So let's take a look at a couple of those real quick before we move on to regular expression processing in Java. For example, when I say dir star, I'm saying match any file name and any extension. Here the dot is not actually a wildcard because we use it to signify the separator between the file name and the extension. So dir star matches anything. If I write dir t star, that matches all files that begin with T. If I write dir type star, then I narrow it down to only those files that begin with type. I could also write dir ty question mark star, and notice it doesn't match anything because there's nothing that only has ty followed by 0 or more characters. If I wrote dir ty question mark star, then it matches type.class type.java. Now if I write dir ty 3 question marks star, now it matches those files that have the word type followed by a number. So those are some simple examples of regular expressions. You may or may not already be familiar with those. But that's going to wrap up this brief introduction to regular expressions, and we're ready to move to the first lesson where we're going to discuss how to write a pattern, which is a character class in Java, and what happens when we try to match a pattern with some other text. And we're going to see how to do that in the next lesson. In this lesson, we're going to learn how to write simple regular expression pattern matchers in Java. And then in the next few lessons, we'll increase the complexity of what we do with the regular expressions. But for this particular lesson, I just want to introduce you to the fundamentals. So we're going to call this program regex1.java. First thing we need to do is import the regex classes. So we need to type java.util.regex.star. To get started, we're going to create a string to match against. So we wrote now is the time or now is not the time. Then we need a pattern to search for. We're going to start off very simple with just a word, now. The word now is all we're going to search for in this string. We will increase the complexity of these regular expressions as we go through the chapter, but we're going to start with a very simple pattern now. The next thing we need to do is we need to create a pattern object that compiles our pattern. In other words, it puts it in a form that the regular expression engine can use. So that's what we do right there. So now our pattern is compiled into the pattern object pattern. I know that's a little bit confusing, but it actually is easier to understand using the same words for the objects as for the class. Next, we need to create a matcher object. We're going to call it just match, though. That puts our pattern and combines it with our string to create a set of matches, if there are any. Now, of course, it could be that there are none. We're going to find that out here in just a minute. Of course, we can tell from this example that there will be. First thing I want to do is print out my string, so I'll have that to look at for output. Then what we're going to do is we're going to use one particular method for working with matches called find. And I'll stop here for a second and explain. Find will go through the string, starting at the first character, and look for matches of our pattern in the string. And every time it finds it, it's going to mark the index location where it found the match, the starting index location. So our first starting index location should be position 0. We'll see as we go through the program what happens. And what we're going to do is we're going to print out a message. And the way we return that index position is with a method called start. Start returns the index position where the match starts, hence the name. So let me check my parentheses, make sure I've got the right number. I do. And the second thing we're going to do is print out the actual match itself, primarily because I want to introduce you to another method called group. And group returns the sequence of characters that the regular expression matched. So we'll close off the while loop, close off main, and close off the class, and we're ready to compile and run. So let's save our program, go back to our command prompt, compile it, and then run it. And it says we found now at 0. The match is now. Found now at 19, that's the second now, and the match is the word now. So again, this is how we set up regular expression processing. We create a pattern object, we create a matcher object, and of course we have some type of string to match against. We have some sort of pattern that we're looking for. And then in some way or other, we execute the regular expression. Now, of course, there's other ways to work with regular expressions, and this is just the easiest way to introduce the subject. But now I'm ready to move on to the next lesson, where we're going to look at creating patterns, primarily, or regular expressions with a little more complexity. In this lesson, we're going to look at how to write regular expressions using metacharacters. And I'll explain what metacharacters are as soon as we start our program. So let's go ahead and get started. We're going to call this program regex2.java. A metacharacter is a shortcut for a character class. So for example, \w is the metacharacter for a word. \d is the metacharacter for a digit. And \s is the metacharacter for a space. And we're going to look at how to use all three of those in this lesson. So let's get started. First thing we need to do is import java.util.regex.star. And we'll start our program. It will start out similar to the program we had before. Here's our string that we're going to examine. Here's our pattern, and for this first one, we're going to do the word metacharacter. The next step is to compile the pattern, then create a matcher object. Then we're going to display the text or the string. Then we'll begin to examine what words match our regular expression. So let's write a couple of system out print line statements. And this looks just like our program from the last lesson. So let's compile. And then run it. So you see that it matched every single character. So we're just a little bit off with our regular expression. Also, I should mention that notice in the pattern that we have to put 2 backslashes. Again, that's because we can't let the compiler assume that we're trying to write a special string character like \t or \n. So we double backslash our regular expression metacharacters just like we double backslash the new line character, for example. But now, getting back to the problem, this matched every character in the string. What we want to do is have it match groups. So what we need is to add a quantifier, the plus right here. So by doing that, let's go back to our program, clear the screen, compile, and then run. There we go. It matched 90% effort, 100% of the time. The different words, although 90 and 100 are numbers, that are part of that string. And understand that the \w metacharacter will match any A through Z or 0 through 9 character. Now, the metacharacter for digits is D. So let's give that one a shot. We'll change it to D, save our program. We'll leave all that output there. All right, so you see we have the same problem. With \d, it matches every digit. What we want it to do is match groups of digits that make numbers. So what we need to do is we go back to our regular expression and put the plus quantifier in. Now let's try it again. Clear the screen this time. Compile, and then run. And here you see it matched our 2 numbers, 90 and 100. So let me do one thing here. Let me add a commented out pattern for the word pattern. And then we have the digits. Let's comment it out also. And now let's look at spaces. If you check back in our string, you'll see we have 1, 2, 3, 4, 5, 6, 7 spaces. So now we don't really care about where the spaces are, at least for this output we don't. What I want to know is how many spaces we have. So what I'm going to do is I'm going to comment out the while loop that displays the matches, add a count variable, and then for every find, Every time we find a space, increment count by 1, and then we'll display how many spaces there are. And again, we counted 7 in our string. So let's clear the screen, compile, and then run. 1, 2, 3, 4, 5, 6, 7, and total spaces equals 7. So to wrap up this lesson, we've learned about metacharacters, at least the beginnings of metacharacters. And we looked at 3. The regular expression to match a word using the metacharacter \W, the regular expression to match a number using the metacharacter \D, and the regular expression to match a space using the metacharacter \S. So that wraps up this lesson on metacharacters, and we're going to move to the next lesson, which is a little more practical, where I'm going to demonstrate how to use regular expressions to replace substrings in a string. In this lesson, we're going to look at a practical use of regular expressions, and that's to replace a set of substrings within a string using a method called replaceAll. So let's get started. We're going to call this program regex3.java. Our import statement comes first. And we start the program. So for our example, I'm going to use my own name, which is frequently misspelled in several different combinations. So what I'm going to do is I'm going to put a couple of my family members in here with different ways that our last name is spelled. So that's the string we're going to try to match against. The pattern we're looking for is capital M, little c, big M. And we could go farther, but we'll just stop with that. We could have stopped at the C because MC is only going to match the last names, but that's all right. Then we compile our pattern, and we create our match object with the string as the argument. Let's print the string as it is originally. Now here comes the key line in the code. We're going to reassign values to the string using replaceAll as a method of the match object. And we provide the argument the way we want the new substring to look. So notice that we matched through a space in our pattern, so our replacement string needs to also include the space. We use the space so that it'll stop right there in a match. So then once we're finished with that, print out the names again, and we close everything up. So let's save our program, compile it. Made a little typo, we'll fix that very quickly. Compile it, and then run it. So here are all the misspellings, IAN, EN, and IN, and there are all the substrings replaced with the correct spelling. So this is one of the best uses of regular expressions, using replaceAll to go through a complete string and make spelling corrections or other types of error correcting, whatever it is that you need. So that wraps up this lesson. This was a fairly brief lesson, and we're ready to move to the exercise for the chapter, where I'm going to demonstrate a few more common uses of regular expressions. For this exercise, we're going to use regular expressions to validate 3 different types of data. First, we're going to do a 3-digit number, then we're going to validate phone numbers, and then finally we're going to validate dates. So I've already got the program mostly written. It's called regexercise. All I've left out is the pattern, or the regular expression. So we're going to do 3-digit numbers first. So to do 3-digit numbers, we're going to enter the following pattern. \\D for digit, followed by open curly brace 3, close curly brace, and then of course close the string. this is a fairly simple regular expression. Although, as you see, it's a little too simple. So let's compile. Then let's run it. So let's try a 3-digit number, 356, and it works. Probably should have put this in a loop, but I didn't. Let's try it with another 3-digit number. Works fine. Let's try it with a 2-digit number. It says number is not in 3-digit format. That's fine. Let's try it with a 1-digit. That works great. Let's try it with a 4-digit, 2,569. And it says number is in 3-digit format. The problem is that we need to add a couple of extra symbols, extra commands, if you will, into our regular expression, which we're going to use for the other regular expressions as well. A caret symbol at the beginning and a $sign at the end, which essentially means match the pattern exactly at the beginning and the end. This keeps it from having problems with this particular regular expression with a 4-digit number. So now let's try it again. Save the file. Let's clear the screen. Compile again, and then run. First, let's make sure it still works for a 3-digit number, and it does. Now let's try a 4-digit number. Number is not in 3-digit format. So again, there's our regular expression for matching a 3-digit number. Now let's move on to the next example. Comment that out. I'm going to leave the patterns in, but I'm going to change the prompts. So this time we're going to do phone number. So we're going to prompt the user to enter a phone number. We can get the number in just like we did before. But now the pattern is going to be different and more complex than one we've seen before. So let's work through it slowly. We start off with our caret symbol to represent match from the beginning. Then we enter the character case 2 through 9 to represent that the first digit can be a digit 2 through 9. Area codes start with 2 digits. I forgot to mention that the phone number format we're going to use is dashes between the area code, the prefix, and the rest of the number. Okay, so we start out by saying the first digit can be a 2 or a 9, followed by, we need 2 backslashes here, any 2 more digits, followed by a dash, followed by any 3 digits. It really doesn't matter after the area code. Followed by a dash, followed by any 4 digits, and then $sign to anchor it at the end of the string as well. All right. We can change our response a little bit. Number is in legal format, or number is not in legal format. That'll be good enough. So let's save our file. Clear the screen, compile again, and then run. So let's enter a good phone number, and that number is in legal format. Here's one that will not be in legal format because the area code started with a 1. Let's try one more. And this time we're only going to write 3 digits for the last part, and that is not in correct format because of that. So let's look at the regular expression for that one more time. Here's the match for the first set of digits, the area code. It's the most complex. Followed by the match for the second set of numbers, followed by the match for the third set of numbers, specifically saying that there must be dashes in between. So with that, let's move on to the third example, and this is an example of a date. And this will be a little bit more complex. Start off with the caret symbol at the beginning. Now here we have to group. Start with an open parentheses, indicating that it's going to be a group. So here we're going to group the first part of the date, which will be the month. The month can start with a 0 and then a 1 through 9, or, and to represent or we use the bar, which is the shift backslash. Or it can start with a 1 followed by a 0, 1, or a 2, because it can be the 10th month, the 11th month, or the 12th month. So that will get the month, and then we close off that group. Then for the day can start off with a 0, Remember, we're talking about date formats where days 1 through 9 could start out 01 through 09. So then we have the character class 1-9, or a 1 or a 2, remember this is the month, followed by the character class 09. Now, we're going to run out of room on the line, so let's bring this down to the next line and indent it just a little bit. A day can also start with a 3, so we start with a 3, followed by a 0 or a 1. We can also write the character class 01. So let's do that. Then close off the group, followed by a slash, indicating we're going now to the year. The year can be 19 or 20, or start with that, followed by a digit, followed by another digit, and then we anchor the ending of the regular expression or the pattern or the match with the $sign and close it off. Let's change our prompt at the end. The regular expression looks formidable, but when you break it down into parts, it's really not. Let's do that again real quick. This is our month. Remember, our month can be either 01, 02 through 09 or 10, 11, 12, followed by the day, which can start with a 0 or a 1 or a 2 or a 3, depending on where we are in the dates. And then we have the year, which is either 19 or 20, followed by 2 more digits. All right, so let's give it a try. Clear the screen, compile, and then run. Forgot to change our beginning prompt. Let's close out, go back to our program. There we go. I just don't want it to look confusing. Compile again. Now run it. So let's try a date. That date is in legal format. Let's try another date. This time let's go beyond. That date is not in legal format because there is not a 13th month. That date is not in legal format because there's not a 32nd day in any month. Now, we didn't take into consideration February or months that only have 30 days, but again, we're just looking for the standards for legal dates, not real world legal dates. Let's try it one more time. And that date is not in legal format because we didn't finish out the year. I'll stop there because that's enough examples. So in this exercise, we've seen 3 examples of how regular expressions can be used to efficiently validate data. The first example was a 3-digit number. The second example was a valid phone number. And the third example was a valid date. And with that, we've wrapped up the exercise and we've wrapped up this chapter on regular expressions. In this chapter, we're going to learn how to draw graphics using Java. We'll start out with simple lines and then we'll move up to more complex shapes and even learn how to color in shapes once we've drawn them on the screen. In these examples, we're going to be using Applets as a means of displaying our graphic images or our graphic objects. So let's get started. We're going to call this program drawlines.java. So since we're using Applets and the Abstract Window Toolkit, we need to import the proper classes for that. So that's what I'm doing now. And then because we're writing this as an applet, we need to write our HTML code. We have the width and the height. Then we close the tag. And then end our comment. So our class is named drawLines and it extends applet. Then we have to implement the paint method. And we provide a graphics parameter. So to draw a line, we need 2 points, an XY1, XY2. So to do that, we're going to have to create 4 points, X1, Y1, X2, Y2. So let's do that first. So then we create our X2 coordinate and our Y2 coordinate. Then to draw a line, we simply call the appropriate method from our graphics object. In this case, it's drawLine. and we pass in our 4 coordinates, and that's all we have to do. So we'll close the method definition, close the class definition, save our file, go back to the command prompt, compile it, and then run it in the Applet viewer. Bring the screen over, and you see that we have a line going right across the middle. So that's how you draw lines. Let me add a couple more into this example. First, I'm going to copy this so I don't have to type it over again. Then call the drawLine method again. Then add one more change. Call drawLine again. Now we're ready to save. Clear the screen. Compile. And then run it through the Applet viewer. So our second line goes up and down. Our third line goes to the diagonal. It's hard to tell because it looks like it's not, but understand that we have a status bar here at the bottom that's not shown very well. Let's close that out and look at our code real quick. Drawing graphics is really not difficult. All you have to do is understand the positioning. So if you understand XY coordinates, you understand that, then you just have to know which method to call in order to draw a line. And that method is drawLine. So with that, we're finished with the lesson and we're ready to move to the next lesson where we're going to learn how to draw different types of shapes such as rectangles and arcs. In this lesson, we're going to learn how to draw 3 different types of shapes: rectangles, ovals, and arcs. For rectangles, we're going to draw one particular type of rectangle, a square. For ovals, we're going to draw one particular type of oval, a circle, and then we're going to draw a semicircle for our arc. So let's get started. I've already started the program. It's called drawshapes.java, just to save us some time and drudgery for you watching me type in all this code. So let's get started on our first shape, the rectangle. We need XY coordinates just like we have for a line. So let's add some XY coordinates right now. To draw a rectangle, we call the drawRect method, and then we simply provide it with our coordinates. So let's see how that looks. Save it. Compile it. And then run it through the Applet viewer. And there's our square. So now let's move to ovals. Ovals are drawn within the boundaries of a rectangle. So what we're going to do right now is draw essentially a square and then have our oval, which in this case is going to be a circle, fit inside that bounded rectangle. So the method is called drawOval, and we simply provide it with our coordinates, just like we have for our other shapes. So let's save our file, compile it, and then run it. And there you see a circle. So the circle was drawn within the boundaries of a square. So you see it's very simple to draw these shapes. It's just a matter of defining some coordinates and then calling the correct method or the method that you want. Now, to draw an arc, we provide beginning positions in the coordinate system. So we're still going to provide x1, y1, x2, y2 coordinates. But then when we call the method, we also have to provide 2 pieces of information: a starting angle and an angle sweep. So in other words, we want this arc to sweep 180 degrees starting at 0 degrees. That would make it a semicircle. So this 5th parameter is the starting angle, and the 6th parameter is the sweep angle. So after that, we're finished and we're ready to compile and run. So we'll compile it, and then run it. And right there you see the semicircle, which is drawn as an arc, not a semicircle. So here's how you draw rectangles, ovals, and arcs. Again, the methodology is not complex. I would think you'll have a lot more trouble working with coordinates, especially if you haven't had geometry courses in a long time, than you will with the actual methods themselves, because they're all very straightforward. You just have to learn what the parameters are. So that wraps up this lesson on drawing shapes, and now we're going to move to the next lesson where we're going to talk about working with colors. For example, how to create a colored line and how to fill in our shapes with colors. In this lesson, we're going to look at how to work with colors. Working with color is very simple. You simply have to set a color that you want for a particular object and then draw the object in that color. Now, there's two ways to set the color depending on whether you're drawing lines or a shape. If you're drawing lines, then you're going to use the set color method of the graphics object to determine the color for the line. If you're going to draw an object, such as a rectangle in a color, then you're going to first set the color, then use a different method. For example, for rectangles, you would use the fill rect method or fill oval method for ovals. I'm going to demonstrate how to do that in just a moment. First of all, I need to talk a little bit about color values. There's two ways to set colors in Java. One way is by setting the RGB value. That stands for red, green, blue, and that's a mixture of red, green, and blue. The other way is to use what I call a color constant, such as color.red or color.black or color.blue. And I'll show you how to do that also in just a minute. So let's get started. I've created a new program called colors.java, and I've already got the code up here, again, to try to save you some of the drudgery of watching me type out all this code. So the first thing we want to do is draw a line in a particular color. So here's our code for drawing a line. So before it, we're going to add some code for setting the color. So the first thing we're going to do is create a new color. And we want to use a red, green, blue value. And I'm going to put RGB here as placeholders for where the RGB values are going to go. Now we're going to take a quick diversion and look at what RGB values are. Bring up a web page. Here's a RGB color chart, and I just picked one from Google. This is no plug for this company or anything. It's the first one that came up. So you see all these different colors. The colors are there on the right. For example, here's blue. Well, blue's RGB value is 0 red, 0 green, 255 blue, being the most blue you can have. Notice how shades of blue, like steel blue, have more red, more green, and less blue. If you go down the scales here, for example, is red, where red is all 255, and then green and blue are 0, 0. So anyway, you can use RGB values to pick shades. If you're like me, colors are pretty much red, green, blue, black, white. But if you want a particular shade, then you want to be able to set a red, green, blue value. So let's just pick one. Let's pick one that's somewhat dark. How about dark olive green? So I'm going to copy this value. Then we're going to go back to our program. And we're going to place it in our statement to create a new color. Then I have to change those dashes to commas, which I'll do right now. So the first thing we have to do is create a color. Then we have to call a method called setColor to set the color to the color we want. Now that's going to be the color that everything is drawn with in our graphics window. So let's take a look. We're going to save that. Let's clear our screen. Compile it. And then view it. And it may be hard to tell, but that is the green that we picked. Let's pick another color, one that maybe will show up a little bit better. Let's try fire brick. So I'm going to set that, go back to our code, save it. Back to our command prompt window, compile, and then run. And there you see that the color's changed. So that's one way to set the color, and that's how you draw a line of a particular color using RGB values. Now another way to do it is using something called a color constant. Let's comment out this line code and uncomment our rectangle code. So now we've set the color to red. And if we want to draw a rectangle in red, we're going to change the method from draw line to fill rect. And that's going to draw the rectangle specified by the parameters and then fill it with the color that's set. So let's give that a shot. Compile and then run. And sure enough, there's our red rectangle. Let's do one more. Let's move our commenting out down to here. Uncomment our oval. Start the comment below that. There we go. Set our color to green. Change draw oval to fill oval. Save. Compile. I obviously made a mistake on my commenting, so let's go back to the code. Alright, so that's always a problem with commenting. I commented out the initial declaration, so let's save that. Try it again. And there's our green oval or green circle. So now we've seen how to work with colors in Java graphics. We can either create a color using RGB values, create a color object, and then set the color to that color object as we did for the line, or we can use a color constant with the set color method. And then if we're drawing a shape, we use fill rectangle or fill oval or whatever the shape is to draw the shape in the color specified by the set color method. So that wraps up this lesson on using colors, and now we're going to move on to our exercise for this chapter. For this exercise in the graphics chapter, we're going to write a program that draws grids in an applet window of a specified size. In other words, if we specify 20, then it's going to draw a 20 by 20 grid of rectangles. If we specify 10, then it'll draw a 10 by 10 grid of rectangles. So let's get started. We're going to call this program drawGrid.java. So we start off with our imports. Then our HTML. Now we're ready to begin our class. So our function is going to be called grid. It's going to take two arguments, two parameters, a graphics object and an integer to represent the number of rectangles we want to draw. So in other words, this would be 20 if we want a 20 by 20 grid. The code itself is simply a matter of writing a series of nested for loops, actually just one nested inside the other. And inside the nested for loop, we draw a rectangle of x times side, y times side, side, side. And that's all we have to do. The paint program simply has to determine the number of sides we want, or the size of our grid, and call the method with our graphics object G and the value for the number of rectangles we want. And there's our program. So this is very simple, yet it does pretty good work. So let's take a look. So we'll compile it. And there's our grid, 20 by 20. Let's change it. Let's make it 10 instead of 20. Compile it, and then run it. And there's 10. Notice it gets quite small, and we could go even smaller than that. Let's go larger just to see what happens. Let's go 30. We may have to adjust the size of our applet window. We'll see here. Compile and then run. Yeah, we're just a little bit small. We can bring it out. Still not quite there, but you get the idea. When you need a grid in an application, here's a simple method for drawing that, and you can specify how large you want it by providing a different value for the side argument. And with that, we're finished with this exercise, and that wraps up this chapter on graphics. In this chapter, we're going to provide you with an overview of the Eclipse integrated development environment for Java. Eclipse is one of the more popular development environments for writing Java programs. And we can't cover all of the features of the IDE in this chapter, but I will show you how to install it and a few of the major features you need to write programs, especially the programs that you see in this course. So let's get started. Open your web browser and go to www.eclipse.org. When you get there, you'll see a Download Eclipse link. Click it. We'll click the most popular IDE for Java EE developers, although we could also use just the standard IDE as well. We'll go ahead and get the most popular one. So click that. We're downloading for Windows 32-bit, so we'll click there. Click on the arrow. Click OK to open with WinZip. We're just about finished with the download. If you have WinZip, and I certainly recommend that you do have it, it'll bring it up automatically. So what we want to do is we want to take the Eclipse directory and extract it. We will put it in our own subdirectory, Eclipse. So now we get to sit back while it extracts the files. So now that it's over, here comes our folder. We can open it up. Let's double-click Eclipse just to make sure that it loads correctly. So it asks us to select a workspace. You can use the default, or you can pick another one if you choose to. I'm just going to use the default. If you haven't figured this out by now, Eclipse is a very large program, so it's taken it quite a while here to initialize and start up the first time. It will be quicker in the future than this. Here comes the main screen. I'm going to put it into view for you, and we'll stop at this point. So our installation was successful. We've got the IDE up, and we're ready to start writing Java programs. The next lesson is on installing Eclipse on a Mac. So if you're not using a Mac, skip that and move to the following lesson where we'll be demonstrating how to actually use Eclipse. In this lesson, we're going to install Eclipse on a Mac. So open your web browser. When you get it open, navigate to the Eclipse homepage, which is www.eclipse.org. Click the Downloads link next. We're going to install the most popular version of Eclipse, the IDE for Java EE developers. So scroll over to the Macintosh links. You can do the 32-bit or the 64-bit. Select the mirror that's already showing up, or the library. This one's Georgia Tech Software Library. Then it will begin the download. That's going to take a minute or two, so hang on while it downloads. We're just about finished now. Now it's going to decompress the gzip file. So go to your Finder. We'll find the file that we downloaded. Move it up out of Downloads. We're going to open that tar file. So now it's going to unarchive Eclipse and put it into its own directory. And once we've done that, it's ready to go. There's really no other installation we have to do after that. So be patient here while we unarchive the files. So there's our Eclipse directory. So we'll open that. There are the files that make up the software system, and the Eclipse file with the little purple icon is the main program file. So we can open that, and it's going to take it just a minute or so to load this first time. Keep in mind that it's not going to take this long every time you try to run Eclipse. It's just this first time it's got to do a lot of configuration and setup. In the future, it will load quite a bit faster than this. Okay, then it's going to come up and ask us to select a workplace. This default workplace is perfectly fine, or you can change it. So either make a change or leave it as it is, then click OK. Now it's going to take just a moment or two longer. And there it is. So we'll be moving on in the next lesson and demonstrating how to actually use Eclipse. But here we do know that we have it installed correctly. So with that, we'll end the lesson and move on to the next lesson. In this lesson, we're going to write, compile, and run a simple Hello World program in Java using Eclipse just to get you comfortable with the basic operation of the program. In other lessons, we'll look at some more of the details of using the IDE. But here I just want to get you comfortable with how to create a project and run it inside of Eclipse. So, first of all, load Eclipse, which I've already done. Then once Eclipse is loaded, select File New in Java Project. Type in a name for the project. Notice where the project will be created. Also make sure that Create Separate Folders for Sources and Class Files is selected. Click Finish, and you're ready to go. Move over to your project name, right-click, click New, and select Class. Also name this class Hello. Click Finish. Notice that Eclipse has provided you with the template for all of your code. So all you have to do is come into public static void main. You can erase that or leave it in, it doesn't matter. And type in the code you need. In this case, system.out.println, hello world. Add the semicolon. Notice it added the parentheses for you automatically and everything. And that's it. We're going to look at some of the features of the IDE in another lesson, but for now, let's just come up here, select Run. Just click Select All here. Click OK. And if you come down and look at the window right here, I've highlighted it. There's the output from our program. And that's all you have to do. So using Eclipse is very simple. There's a lot of features that can make it somewhat of a complex program. But for just creating a Java project and running it, it's very simple. And this is the first hurdle we have to clear in learning how to use Eclipse, is at least figure out how to run a very simple Hello World program. And this is how you do it. So we're going to wrap up this lesson now and move on to the next lesson, where I'm going to show you more features of the program and how to create a class definition and then use it in a program. In this lesson, I'm going to provide a brief overview of the Eclipse IDE, Integrated Development Environment, not going into any particular depth in any of the features, primarily because I really can't. There's too many to cover in depth, but just to give you an overall tour of what Eclipse looks like. So Eclipse is just a regular Windows application or Mac application. You've got a menu bar across the top. You've got an icon bar right underneath the menu bar. We'll come back and look at those in a moment, especially the menu bar. Then the rest of the screen is divided up into basically three areas. On the left, we have a Package Explorer area. This simply will list the different parts of your project or package if you decide to develop it as a package. We're going to work only with projects, so it's really the same thing. The middle screen, the most important part, is the main editor window. This is where you'll be typing in your code, and we'll see that in more detail. Down below that is a console area. I call it console because primarily that's what you're going to use it for, to view your console output. But it also will display errors. You can generate and display Java documentation, and you can also create declarations in this window. But primarily we're going to use it for its console application. The menu bar has standard menus for working with files, for performing edit functions, for working with your source code. We'll see more of that as we get into programming. For refactoring your code, such as taking out code that's reused and turning it into methods or extracting classes. To navigate through Eclipse, to search for different things such as text or files. Project for working with the overall project. Run for running programs and debugging. Window for working with the windows that make up the app. We won't look at that at all. And then finally, there's the help function. Down below, you have the standard icons for shortcuts. The one we'll be using the most is Run to run our application. And then for creating new pieces of a project, such as a complete project or a class or a file, things like that. And then we have many other icons also. That's the brief overview of the IDE. Like I said, there's quite a bit more we can talk about. We could spend a lot of time covering all the different sections, but I want to focus on what you need to know to begin using it as a programming environment. So we're going to wrap up this lesson on the overview now and go into some practical aspects of using Eclipse, including how to use the code completion and code correction features of Eclipse. In this lesson, I want to show you some ways that Eclipse will help you enter programs. One of the nice things about an IDE is that it provides lots of support for a programmer when they're entering a program. So let's look at some examples of that. One of the great examples is what I call code completion. So for example, if I'm trying to figure out what I want to do with the system object, once I hit the period, then Eclipse brings up a list of possible objects or methods or properties that I can use next. So for example, I can use out. And if I double click it, out then comes right onto my screen. If I hit dot again, now it tells me what methods are associated with system.out. If I type fast through it, you won't really even see it. Now let's stop right there. Notice when I type systemout.println, it automatically brought the parentheses up. Let's do that again so you can see it better. I'll go a little bit slower. I type in the first open parenthesis, and then Eclipse automatically added the closing parenthesis for me, saving me some time. I typed an open quote, and Eclipse automatically added the closing quote for me. Here I can just type hello world \n if I want to. Now, notice that at this point, there's a red squiggly line under the closing parenthesis. That's because I haven't included my semicolon yet. So once I do that and hit enter, the red squiggly line indicating a syntax error is cleared. Let's look at another example. Let's do just a simple for loop. Notice that I open the parenthesis and it gives the closing parenthesis for me. Now, if I want to put this in a code block, I type the open curly brace. Eclipse automatically adds the closing curly brace. So notice how Eclipse is following along as I type, trying to anticipate both what I'm going to type next and the errors that are already occurring. It's not anticipating the errors. It's actually seeing the errors as I type. Once I finish out the statement by, for example, adding a semicolon to this line, then it clears the syntax error at that point. So Eclipse can help you complete programming statements, and it also helps you find almost all syntax errors. In fact, I would say that all syntax errors are found by Eclipse, literally as you're making them. Now let's look at one more example. I'm going to create a class outside of our main class. Notice I started the class with an opening curly brace and it automatically closed it for me. So we're going to create a very simple name class. We're going to use this again in our code generation lesson next. Mostly just watch as I type as it finds the errors that I'm making. Notice right now I have an error over the closing parenthesis of my argument list because I haven't opened the block yet. Now once I open the block, then it goes away. Create a default constructor. So now this is a class that I've added into my code. If I come down into my main program and create an object, I'll just go ahead and do it. Code completion now recognizes my object, my name, as being an instance of the name class, which it finds up in the code above public class code sample. And notice that not only does it provide me with a list of the built-in methods that are inherited from object, but it also gives me a listing of my setFirst method that I've created. So code completion is a very nice tool, especially for the busy programmer who's trying to get a lot of code written quickly. Once you get used to using code completion, then it can really save you a lot of time. Now, as an instructor, I find code completion to be somewhat of a cheat for my students because the IDE tells them what they're supposed to be typing instead of having them type it themselves. So I see the pros and cons to code completion. I've pointed out how errors are shown, especially syntax errors. You can also use Eclipse to give you suggestions. So for example, let's say I type this in for the setFirst method. Well, that's clearly wrong because it only takes one argument. If I put my cursor on the error and type Control-1, it will give me a list of suggestions to fix the problem. So for example, the most obvious one is remove argument to match setFirst string. So here I can see that, oh, I have two arguments when the prototype or the definition of setFirst only takes one string argument. So it also tells me some other things I can do is change the method to have another parameter or create another method that has two parameters. And so I can pick one of these methods to fix my problem. Well, the way to fix the problem is to change it back to one parameter. Now I've already got John, so we'll change that to Mike. No mistake there. Fix that. Clear that out. There we go. So by pressing Control-1 on an error, I can get a list of possible solutions to the error. So that's an overview of entering code and error correction in Eclipse. Now I want to move to the next lesson where we're going to talk about code generation, where I can use Eclipse to actually generate code for me. In this lesson, we're going to learn how to use code generation to fill out the simpler details of a class. So let's get started. We'll start a new project. We're going to call it CodeGen for code generator or code generation. Now we're going to create a new class, same name, CodeGen. So we're going to start out by creating a class name. It will have two fields, first and last, which is good enough just to get us started. So now to generate code for this class, we'll put our cursor up in the class definition someplace, come over to the source menu, and scroll down to where it says Generate Constructor Using Fields. We'll start with the constructors. So we're going to click that selection. Here it asks us which fields we want. We want to select them all, so we click Select All and click OK. And notice that right here, it created our class. Now it also created a call to the superclass object. We can take that out because we're not going to use that. So here's our constructor. Let's create another constructor. This time let's do a last name only constructor. So we'll come back down to Generate Constructor Using Fields. This time we're going to select last, then click OK. And where we have called a super, we'll put our own code in and say this dot first equals empty string to initialize the first field. So there are two constructors. Let's move on and generate some more code. This time let's generate getters and setters. So we want to generate getters and setters for both fields. So we'll select them, then click OK. So here we have a get first and a set first, a get last and a set last, along with our constructors. And there's the whole class definition. Let's do one more. Let's generate a toString method. So we want to select only the fields. So we'll click OK. And there's our toString. And notice the format it used. It lists the name of the class, followed by an open square bracket, and then our first field equals, comma, and then our last field equals, and then a place for the data. So let's move down to our code. We'll erase that comment. And let's just create one object and we'll play around with it a little bit. Now let's try one of the setters. Let's copy and paste our call to toString, like so. And let's try one of the setters. And then just for fun, let's print the name using the getters. Like so. Take a look at our code. Don't see any errors, so let's run it. So we had first equals Jane, last equals Smith. Then we changed the first name to Barbara. Then we have Barbara Smith without a space, as in our last systemout.println statement. So as you can see, it's very simple to generate definitions for lots of class methods using the code generation tool. Now, of course, you can't use it to do all of your class definition, but for these simple things like constructors, getters, setters, and toString, the code generation tool works exceptionally well. So that wraps up this lesson on code generation. And now we're going to move to the last lesson for this chapter, where we're going to talk about debugging using Eclipse. In this lesson, and this is the last lesson of the chapter, we're going to spend just a few minutes looking at debugging and some of the debugging tools that are available in Eclipse. So what I've done is I've written a program that computes the square root of a number using Newton's method of successive approximations. So I've written it in a very functional style with several functions to do all of the work. We have a square function that squares a number. We have an average function that returns the average of two numbers. We have an improve function that takes two numbers and gets their average. That improves our guess. That's what we're working with. Then we have a function called good enough to see if a particular guess falls within a certain range of precision. And then finally, we have the square root function itself, which calls itself recursively until the guess falls within the precision range that we specify. So if you look down at main, you see that we provide a precision of 0.001, and then we try to find the square root of 9. So when we run this, we get the result 3.000915, so on and so forth. So if we want to debug the program, it's not even so much debugging that I want to describe. It's if we want to watch the progress of the program and be able to look and see what's happening as the program runs. What we can do is, under run, we can say debug as Java application. So let's do that. Now, these errors are not really in the program. They're from a previous version. So we're just going to click proceed here. So running as debug still gives us the same answer. So what we want to do is we want to do that again. But this time, before we do it, we want to toggle a breakpoint. And toggling a breakpoint will allow the program to slow down so we can use what's called a stepper to step through the program. So we picked our breakpoint to be at the beginning of square root. If we would choose something different, we can highlight the line, come back up to run, and click toggle breakpoint there. To do that, though, we might want to clear all the breakpoints, remove breakpoint, and then select the one we want. I want to select this particular line so that we can look at the guess as we go through our program. So we're going to toggle that breakpoint. So notice there's a blue circle indicating that we have a breakpoint on this line. So now let's debug. And so what happens is the program begins its launch. It tells us that it's going to launch in what it calls a debug perspective. We say yes. Notice the window changes we have. And notice that we have here in the top right a window that shows our variable values. Now, if we come down into the program, we can put our cursor on the variables to see what our different variables are. X is 9. The precision, we already know. It's listed up here in the window, but we can also put our cursor on the variable to see the value. And then our current guess is 1.0, which we selected. So what we want to do is we want to step through the program. So we can do that by pressing the F5 key. And the F5 key takes us into the next part of the program. So now it's taking us to the improve method because that's what was called next. Because the next line was to improve our guess and get a new value for guess. So we click F5 again, or press F5. It takes us to the average function. The average function adds X and Y together, divides by 2. That takes us back to improve. Improve now returns its value to guess. So if I step past guess, now the guess is 5.0. So then the next line tells us to call the program recursively. So we call it again. Notice we go back into square root. We'll step in. Notice at this point, guess comes up into our variable window because we've modified the initial value of guess. So guess was 1.0. Now that it's been modified, its value appears in the window. So we can step through it again. First thing that happens is we square X. Now we're going to check the precision. We're going to get a new version for guess. So we go through this whole process again. I'll move a little bit faster now. Now we have a new value for guess. It's 3.4. Now we have our new version of guess in the watch window. We go back into good enough, goes back to square. We make a new improve on guess, and now guess's value is 3.02. So as you can see, we're working our way down to 3.000. Let's step through it one or two more times. I'll go a little bit faster. Here we go back into improve. Improve calls average. Now the guess is about where we're going to end up. So now we return guess. We go through the recursive call a couple more times, then we finally break out. And now we're at the last line of the program. And notice we hit F5 and our results show up in the console. So a lot of times when you're working on a program, stepping through the program will help you figure out why you're not getting the result that you expect. And by closely watching the line-by-line progress of the program and keeping track of the variable values along the way, it will help you determine what problem there is in the program and be able to fix it. Another good use of stepping through a program is to learn how your program operates. So for example, when I'm teaching beginning programming classes, I have my students step through a for loop or a while loop or a series of if-else-if statements. And by following the control flow, you can learn quite a bit about not only how this particular program is operating, but how the program construct you're looking at operates in general. So that's a brief overview of debugging in the Eclipse IDE. As with all the other features of Eclipse, there's much more to debugging than what I've shown you here, but we could have a whole course just on debugging in Eclipse, and we don't have time for that. So hopefully you've gotten a good taste for the Eclipse IDE, and I encourage you to begin using an IDE, even if it's not Eclipse. you should look at maybe several different environments. Do a Google search for Java IDEs to get an idea of the different ones that are available. There are several in the academic environment that are not quite as feature-packed as Eclipse is that you might find easier to use to start with. But Eclipse is one of the more popular IDEs, so I wanted to give you an overview of how it works as a general introduction to Java IDEs. So with that, we're finished with this lesson, and that wraps up this chapter on the Eclipse IDE.